Good morning, everyone. Morning. Welcome to this 96th edition of the Zak World of Façades conference. My name is Ahmed. I'm part of the organizing team here at Zak Exhibitions and Conferences. Very happy to see you all once again in person. After 4 years, I think 2018 August was the last time we had a Kuala Lumpur edition of Zak World of Façades. This event, as you all are aware, was originally scheduled for August 2020, but we all know what happened in 2020. Of course, we waited for a long time to organize this event. Our sponsors who had already signed up way back in 2020 have been extremely patient in waiting for this event to happen. I'm sure all of you were also, so thank you all for being here present in person. It really means a lot for us to come back with face-to-face events after a lot of webinars, Zoom meetings, and other virtual stuff. So thank you once again. This is the 96th global edition of the Zak World of Façades conference. We started this back in India in 2012 as a small networking event. It's grown tremendously all around on the globe. This is basically our 2022 map, early 2023. So we have events all around the globe. It's not that we did anything special. It's just that facades are becoming more complex globally. Okay. Yeah. There's an overlap. Happening. Anyways, I'll continue till they fix it. So facades are growing. Facades are becoming complex globally. So there's a need of new solutions, as well as there's a lot of requirement with respect to energy sustainability. So it was easy for us to talk about sustainability, energy, fire safety at all these editions, and this basically brought across the growth of the conference in different countries. We've been extremely proud of our event sponsors, without whom we wouldn't have been able to do it. I'd like to thank our event sponsors for today. Our presenting partner, Schuko. Schuko is a German manufacturer, global leader in aluminum door window curtain wall systems. This is AGC Smart Glass division. They have a very interesting active glass BIPV solution, which you can see on display outside. Like all our sponsors, all of them have a booth outside. Axalta is a leading manufacturer of powder and liquid coating. Something happening. CSG is one of the leading high performance glass manufacturers out of China. Dow is the parent company of the Dow sealant brand, earlier known as Dow Corning. Elwal is a leading non-combustible aluminum composite manufacturer from Greece. Hilti is a company based out of Liechtenstein, next to Switzerland. All of us know Hilti. They have a lot of innovative solutions for the facade. Kinlong is a leading glass hardware and fitting manufacturer out of China. LB Aluminium Berhad is one of the leading aluminum extruders here based in Malaysia. We have Saint-Gobain Glass exhibiting here with us today. Saint-Gobain needs no introduction, a leader in high-performance glass solutions. Serge Ferrari is a French company into fabrics for facades. Siderice is a British manufacturer of pacifier protection. They have solutions for curtain wall and rear ventilated facades. Vector Foil Tech is a leading innovator of ETFE solutions. You'll be hearing from them later on what ETFE can do for your facades and roofs. And our technology partner is Orgadata. All the delegates, if you notice, your lanyards will have a USB stick, so that's courtesy Orgadata. Orgadata are a German software company into estimation software for the facade and those windows. We don't have a delegate kit this time around, so the USB stick has the brochures of all our event sponsors for the event. Our next event in the region, so-called Asia Pacific, is in Japan, so that's also presented by Schuko. That's on the 12th of October. In Southeast Asia, our next one is in Hanoi. That's our second event in Vietnam. We did Ho Chi Minh back in 2019. And of course, a little bit of an extension in the same Asia Pacific region. We have a Melbourne edition on 16th February, and we have Auckland on 23rd February. This is our overall calendar for Asia Pacific from now until March next year. As I mentioned, we're extremely proud to come back to Malaysia once again. As I've always said, it's important to have a facade event in every country around the world. Of course, I can't promise we are present in every country, but we'll try to be present wherever we are possible. The reason is there's a lot of demand in terms of high performance glazing products. Facade is easily one of the biggest culprits in carbon emissions, but now there are new techniques, there are new strategies in designing more sustainable facades. Just to give you an overview, Malaysia opened up late like other Southeast Asian countries compared to let's say the Indian subcontinent, the Middle East, Europe and America after the COVID pandemic. In the last 1.5 years, we've been doing events in those parts of the world. And one thing which is very common in those parts of the world is they have acknowledged the fact that climate change is the next big thing going to happen after this pandemic. So they are taking steps. So what they have done is, currently we're looking at operational carbon, which is basically the carbon used in the consumption once the building is being built. But people are moving towards embodied carbon. Embodied carbon is the amount of carbon used in constructing the whole building, right from the suppliers to the supply chain to the construction process. So that's something which has become a very big topic in the Western world, where embodied carbon is being looked at very carefully. So we have a lot of references to embodied carbon in today's seminar. It's not yet picked up in Asia so much, but eventually I think as responsible designers, engineers, consultants, we need to start looking at embodied carbon. That is something which is very important. What it is more in detail, our presenters will be talking about. So we will start with the first presenter for today. I am unfortunately your event host also for today. Our preferred host, Stephen Tano from Shuko UK, unfortunately could not make it. So I will continue from here. And I think speaking of embodied carbon, our first presenter can talk to you more about it. It's Michael Chin from Arup. He's a principal in the Singapore office of Arup. He also leads the technical specialism and the facade engineering team over there. So his topic is on the future of facades in a decarbonized building industry, and what he means by decarbonization is something to what I had to say in my opening note. So Michael will talk more about what is operational carbon, embodied carbon, why it is important, and he'll take this forward from here. Before Michael starts, quick housekeeping questions. Keep your phones on silent. I would appreciate if there's no disturbance. Second, we won't take any questions due to the paucity of time, but our speakers are going to be around. You can catch them in the breaks and you can ask them questions. And each of our sponsors have a booth outside over there. I request you to please interact, connect with them. It's because of these companies we are able to do these large, grand, high-end events. They've been extremely patient and supportive. As I've said, this event was originally planned for 2020, did not happen. So they have been wanting to meet you all in person. So please do network with them in the breaks. We've got plenty of them. It's important you guys meet each other, because you never know what solution they have could be something useful for you in your next project. So over to Michael Chin.
Okay, good morning everyone. I'm Michael Chin. I lead the Facade Singapore office, but also a series of technical specialism, acoustics, fire, risk and security, and all the stuff that I'm not so familiar with. All right, so today, hopefully I'll be talking about something that interests most of you, right? And Ahmed already alluded to that very succinctly earlier. Decarbonization and how does it, what are we doing about decarbonization? What do we need to do? What are the project examples that we have done? Primarily in the Western world a bit more, at least at this point. but it's definitely coming here, and we are all definitely, all of us here in this room feeling the impacts of climate change, all right? So before I start with that, maybe a quick plug about Arup. Right? We are a UK-based company. We are 14,000 strong around the world. This year is our 75th anniversary. Ove Arup, who is the founder of the firm, actually set up the firm 75 years ago, and he has since grown into many offices around the world, 60 over offices around the world, 95 offices around the world, and 16,000 professionals. So we used to say in Arup, there are things that, there's almost nothing in engineering that we cannot do, right? Somewhere around the world, someone will know how to do it and solve the problem. Okay, so specifically on Façade, which I come from, we've got about 300 people globally. There's a big team in London, there's a big team in Singapore, Australia, East Asia, some of you would know. But we are a very diverse team to talk about everything, who is knowledgeable across all spectrums of Façade. Track record as well, that's one of our projects over there. Just a quick chart on our team. We've got about 25 people in Singapore. But this slide is most important. We've recently, proud to announce that recently we've set up a Malaysian team led by Sean over here, who will be essentially having a session, the last session, and the first and last session will be covered by Arup today. So I'm happy to announce that. Okay, let's subject matter, proper subject matter, decarbonization. It's a big word. Everybody throws this around. Talks about embodied carbon. Talks about operational carbon. What it is? What is it? Is this kind of big word about decarbonization? Right. As Arup, we try to be at the forefront of everything that we do, and obviously this is one big item that we want to solve, as a firm, as much as possible. And most of you will know many of your firms are already committed to some sort of net zero targets, right? In Arup, we aim to bring it one step further. We want to go net zero. Net zero is the key word by 2030. Right? It's a very ambitious target. 10 years from now, maybe in 10 years, I'll tell you whether we have been successful or not. All right. Of course, we joined the WGBC net zero carbon building commitments, and all the big list of pledges and initiatives that we have done. So at Arup, we want to solve the problem. We want to be the problem solver. We want to be the forefront of these things, and seeing how we as consultants can look at this problem and hopefully come up with a solution that can provide and tackle these issues, especially with regards to climate change. Okay, so very quickly, what are the key trends that we notice in the real estate industry, which is what we are in, right? The first one, things very clearly, something that we all see, on a day-to-day basis, right? Every day we see in the papers, climate change is real. We have almost as recent as now, heat wave in southwest of China, Sichuan province, where it's actually producing lots and lots of the hydroelectric, right, coming from water. But when you don't even have enough of water and drought is coming, what happens then? Right? Of course, in New South Wales you have flood, bushfires, all around the world. All these events are become more and more predominant, and we can't deny that. Obviously, there's an obvious push that we say climate change, everything that's not doing right, climate change, which in some ways, good or bad, it is an issue that we have to face today more and more. And of course, in Singapore, most of the areas are low-lying, right? And if it goes up by 1 meter, you can imagine most of Singapore becoming even smaller than it is today. And on the business front, we see a lot of sustainable investment now, green bonds, green loans, something that has material aspects on the property industry with respect to ESG and sustainable investment. when you hit an organization in the pocket, obviously, it becomes a big issue. And, the last one recently in Singapore, you had to do climate exposure. So as part of your finance reporting, you actually have to do, disclose what have you done for the climate, which again, put the money where your mouth is. You as an organization, all of us has a responsibility to make sure that these things happens. We are doing something towards the climate. Again, there are lots of all this I won't talk a bit about, but are terms that are familiar to some of you and potentially some of most of us, which are we're going to see it probably in a very, very near term. So if you look at it, most of the firms and World Building Council has kind of agreed and said that, okay, by 2050, the world needs to be at net zero in order to make sure we still keep our global temperatures below 1.5 as pledged in the Paris Agreement. Well, is that going to happen? All right, if you work backwards, 2050 is not that far off. All right, by now, the midway of it, 2030, we almost have to be quite sure that we've got to cut 50% of our carbon. So, that's the biggest conundrum. Can we actually do it? That's something that we have to try. Well, buildings. What is the impact on GHG, greenhouse gases, as well as carbons that is coming from the building industry? These are just numbers that fly around, right? 39% of the entire buildings industry, that's where your carbon's coming from. And out of that, 28% is the operational, right? And 11% is actually embodied, right? So materials and what we are doing from a design point of view, how does that affect the carbon downstream? So this is kind of like the whole life, typical whole life carbon cycle for new developments. Right? And you see the spikes are generally where when you actually construct the building, and then the operation, of course, runs through the entire period. And then at some point, you decide to replace and refurbish. You've got that spike over there. And then at the end of it, it comes to deconstruction, and that's the stage where it's spiked again. So, a lot of times, this is the entire whole life carbon, and you can almost tell which are the areas that you need to tackle. Right? If you tackle the big spikes, and the big spikes actually influence the operational carbon in between, you can more or less, try on your journey, and that's where the most impact is. So this is just one very interesting chart that and it's easy, I suppose, simple to understand, on carbon breakdown, right? On the left you have embodied and operational carbon, and then obviously operational carbon you can do something with the passive design, active design, operation stuff, and then after that you decarbonize your grid, that's another element over there, and finally you then try to bring down the embodied carbon part, which there's multiple ways to actually do this. So it's quite an interesting chart how we actually do it, but like I said, easier said than done. But at least pictorially we understand where we are, hopefully. From a material point of view, this chart, I think a lot of you have actually seen it, right? The embodied carbon part actually runs from A1 all the way to C4, right? And so there's actually a big component over there. And some description in terms of embodied carbon. So sometimes you hear people have been talking about this, throwing the terms around, cradle to gate, cradle to completion. When I say cradle to gate means where you actually start production all the way to where your factory gate is. And cradle to completion is, you bring it to site and you actually, it gets constructed on site. And of course, operational carbon and whole life carbon. We are more interested in whole life carbon because that's the one that, you tackle the entire spectrum of the life of a building, right? But again, I would say, wherever you are in the cycle, at least at this point where we are in Southeast Asia, at least, the awareness is important. Build awareness. There are some areas of of areas that we can tackle. So some of you are, for example, suppliers, manufacturers. You need to decarbonize your grid. You need to look at how to have more sustainable energy, to actually power up your machines and power up your plants. So those are the things that you do. And then the people downstream will have their set of requirements to actually look at, to actually decarbonize, let's say, for example, our operations. Just be aware of this. This actually is not so important. Important thing is, we are on this journey. Okay, so how is, very quickly, how is embodied carbon being calculated? Everything, there are terms being thrown around. Obviously, it's a big new topic. Everyone will come and tell you, and this is, my embodied carbon. And we need to really understand what's the level of detail, I suppose, what's accurate, what's included, not included. As I said earlier, cradle to gate, cradle to a whole life cycle. All of that is important to understand. We don't have enough data, especially for in Southeast Asia region, so we need to collect that. And I think some of the jurisdiction, for example, in Singapore, has already started with this LCA or life cycle analysis, where we have started to essentially collect data. Data is all we need now. Once you have enough data, then you can start looking at how accurate your data is. Okay, I mean, just in terms of, again, where kind of like the benchmark of the measurements of how do we actually, the framework of assessment, and this, the typical ones is Eurocode, right? And from British Standard, then we've got a series of RICS, calculation framework, and then it comes down to your local targets. Again, these are just framework, right? I guess the life cycle assessment code, the BSEN code 14,0400 is probably the most important benchmark that we're looking at this point. Again, even in this standard, it actually tells you there's no single method of actually conducting LCA. All right? Different regions are entitled to conduct LCA in their own manner. The most important thing is awareness, and we are moving in a single direction. I think that's one of the things that are more important. Once we have that data, then we can then decipher whether the data is accurate or not accurate. When you don't even have data, you don't even bother. So in Arab, we've actually developed some tools along the way to help us look at some of these carbon comparisons, I suppose, more effectively. For example, we have, I come from Façade world, right? And you look at curtain wall, for example, different systems of curtain wall. Some you have full height vision glass. Some of them you have a smaller window wall ratio. You got a bigger spandrel. All of this optioneering, we do it quite commonly. But how to quickly look at this in carbon terms? And Arabs developed a software we call Carbon Insights, and essentially what it does is you've got optioneering, A, B, C, D, E, F, G, of different facade configuration, and immediately the idea of this tool is to look at the carbon content of each and every one of those solutions. So when you look at it from left to right, you see 3 different configurations, slightly different, which is quite common when designers actually look at options. But immediately we can tell which is the carbon content of each and every one of those solutions. It adds another layer, another spectrum of comparison when we look at carbon. Obviously, you look at this, 203, that's the best, most efficient in terms of carbon. But from a downstream point of view, from a cost point of view, holistically point of view, whether installation-wise, fabrication and all that, those kind of things you need to factor in, of course. It just provides one, I suppose, aspect of looking at things more efficiently from our side, at least. And this is something that we've done, right, in our projects. New build, 3 different options. Architects out there will probably be very familiar with this, right? We do this again and again and again. But now we then start looking at this and see, what's the carbon content. And we can do this pretty quickly, and that's key in today's world. Refurbishment as well, we can actually do that, right? Same thing, build a model very quickly, look at different options, look at different configurations, add a carbon content to it, potentially shift the story. May not, but sometimes it does. This is something that we did in London. It's a Google HQ. Again, the normal components of design, of high-end development. You've got a very star architect, and you've got a big group of very established consultants, and we are on multidisciplines. And Arab was also the facade engineer on this job, and we started looking at how does the facade is actually what it is, and how do we actually design that the facade in the most optimal manner to a certain extent, right? And you've got all the usual challenges, right? You've got because of the site is long, and if you know where this site is very long, that's one thing, but also it's on the east and west direction. So those are really worse for solar exposure. And then at the same time, you've got all your high energy targets that you're supposed to meet, right? And all of this just looks at it. And of course, most importantly is that little box at the top there. The architect's looking at a shingle facade, right? It's kind of like a self-shading facade, all right? From a design point of view, that's what the architect wanted. But whether what shape, what size, what depth, should this essentially configuration be, how to actually do this in the most efficient manner, quickly, that's something that we have to, again, use software to guide us, to inform us. And this is something that we did in a software called Arab Solar. And we incorporate all of this, so your G values, the glass, as well as the shading, looking at different times of the day, the shadow that's being casted onto this. I mean, you will actually do that in any case, right? But how in the olden days, you probably look at this, specifically software by software, and then you go to and fro with the architect, again, the whole process can take quite a long while. Whereas when I show this, or when we show this, and we kind of iterate this with the architect in front of us, with the client team as well sometimes, it becomes very clear, what we are looking at. All right. Different aspects actually interest different stakeholders. So software like that visually actually helps in us deliver our, get to that goal a lot faster. So this is what it is. You see that shingle facade coming up, quite interesting facade. I was talking about Arab Solar earlier, right? And this was just another kind of intro video of what we do. Of course, the model needs to be there, right? You build a model, you more or less get your messing that you want, and you kind of iterate with it, and you put in your G values, you put in your glazing values, and your vertical, your fins, projections, and you can kind of play with some of these aspects all within that model. And we can sit in the same room and we can talk about these things quite effectively. So you imagine as a design tool, it can be quite, it's very efficient. It saves us a lot of time. Cleverly correlate and say that, by that time that the building is built, 90% of the economic life cycle is already determined. So essentially, this big circle here, you say all your operations downstream, is actually more or less affected by this little kind of dot downstream, which is 0.1% and 1%. We try to, I suppose the British way of saying it, penny wise, pound foolish. It happens a lot of times like that. But it gives you quite a picture of what the relationship is. True or not 100%. It could differ from project to project, obviously. So yeah, as I said, I think you will get to a point where we start looking at countries and jurisdictions starts to give you carbon targets, right? We already have green mark target, green ship and all that, platinum targets and all that. And now, because of this carbon, we will get into that target on the left-hand side, which is the embodied carbon target, kg of CO2 per meter square, right? It's not ready yet, but when that comes, we've got then get into a situation where we have to start looking at all the different configuration to actually get to that point. So whether it's embodied carbon, maintenance carbon, and operational carbon, all of that contribute towards meeting that target, right? Okay, so some of the things that facade related, I suppose, and we can control to a certain extent, and we do it on quite a day-to-day basis in a lot of us which are designers. And one of the biggest item, I suppose, is materials. And we started looking at, I suppose that few biggest construction material, concrete, steel, aluminum, and glass. These are the most carbon intensive. Like it or not, they are the most carbon intensive material that you can get out there. Unfortunately, there's probably not that much of a viable solution or replacement at this point of time, right? If you say glass, what replaces glass? With the actual same characteristics. Steel, which element provides that kind of weight to strength ratio as compared to steel? Again, probably not that many out there. Aluminium and glass, obviously, more pertinent to what we do. But if you can see some of this, every one of these elements here has a carbon footprint, right? And if you start considering sequestration, and then you start considering recycling content, and greening your energy sources, all of this can then be reduced, right? So instead of saying, don't use aluminum, use timber, for example. Let's look at aluminum. One way is look at aluminum and how to lower down the carbon that aluminum produces. Low carbon aluminum, low carbon glass, low carbon steel. There is out there at the moment, but probably don't make so much of commercial sense at this point. But as that number becomes important, as I said, that embodied carbon target becomes important, there's no way to get around that. Just very quickly about glass recycling. Glass recycling is not very efficient process, unfortunately, but it's very good in terms of decarbonization. If you recycle glass, you only use up to 5%, right, of the energy that you will need to build to actually melt glass from scratch. Right? Unfortunately, you've got a process of delamination, and removing and all that, of existing glass, and glass is actually not friendly in that sense when it comes to recycling. So a lot of it actually ends up in a dump somewhere. All right, but a lot of it has, if you can do it, and the technology is coming out there, really, converting some of this glass into grade A glass cutlets, we call it, and that one can be recycled. It goes back into that system, at various levels. Then you obviously, save some carbon in along the way. Again, I just briefly talk about aluminum. What's the future aluminum? Low carbon aluminum, there is already out there. It's just at the moment it's quite expensive, especially bringing it to Southeast Asia. Recycling is fantastic. You can recycle aluminum almost indefinitely. Right? In fact, I think 95% of aluminum is already being recycled, and you use up to 33% of the energy to actually make new aluminum. Right? So it's a very good process, and we are actually doing that. It's just that we don't have enough aluminum to go around. Right? There's not enough supply. And of course, we do things like energy efficient solutions, lean design, durable solutions that can last a bit longer. Don't tear down your buildings, refurbish. These are some of the things that we can do. It's quite common sense, I think. Unfortunately, commercial sense or not is another issue. Low carbon aluminum, again, this is very popular in Europe. Right, hydro, using hydroelectric power. And when I put on this slide, it seems very sensible. But after that, in the past week or so, we had this crisis in Sichuan, where they have all the majority of their power generated by hydropower. And unfortunately, the rivers are drying. So in that kind of solution, then what happens, right? So we almost, the energy security story, the energy security piece, whether it's solar, wind, hydro, is still not, what's the word for it? It's still not solid yet. It's still not consistent. All right, so that's something to think about. Recycled content, obviously, this is, again, no-brainer. Whether it's plastic, rubber, you don't make new product, you instead of downcycle, you upcycle, all right? Or you basically bring it back to the system in another form. You keep the carbon in the you don't have to generate new carbon to actually bring in more material. Biomaterial, again, some of these things, essentially it's materials that are built from living things, whether it's algae, hemp, bamboo. We do this at this point, but in very small quantities, I must say. But it is some of these possible technologies out there already, some experience. That solar leaf one is quite interesting in that sense. It's an Arab project, collaboration with a university, and basically it's algae and sunlight, producing CO2 and biomass, which then goes into the system again. Very interesting, but then I don't think you like that green facade, not for every one of us. Okay, some track record, I suppose, projects that we are doing. Unfortunately, a lot of these are European-centric, just because they are a bit advanced in what they do, but it is kind of good examples of refurbishment and thinking about circular economy. Right? The first step is if you don't build new, then obviously you are already keeping a lot of carbon in the system. And in Triton Square, there are three principles. So you go in with the principle of looking at, hey, I'm not going to knock this down, and rebuild, right? So that's the first commercial point you've got to take note, and a lot of these are government-driven to a certain extent, right? This is a grade A conserved building, you can't knock it down. So then you've got to find value, reuse, and make it reusable. So you start looking at this 30, 40-year-old building, what can be done, what cannot be done. And eventually it became something like that. There's a double screen, there's an outer screen which is being removed, right? And some parts are being extended, and you clean the aluminium on the outside and you actually put it back into that system, right? Whereas the inner screen, you do some refurbishment, including a glass replacement. Glass is always an issue because the olden days, or the old glass is not DGU, they are all single or laminated piece. Right. So, from a thermal performance point of view, it's almost not acceptable today. So these are some of the things that it's being done. Right. So the blue and they are being kept in place, and then the pink one outside, which is being refurbished. Clean, refurbished. Checked whether they are okay, not okay. So there's also quite a lot of skills involved and all that. And then, of course, the parts that are being removed because they are deemed not acceptable, and then new, right? Good or bad, it's definitely from a climate point of view, from a carbon point of view, refurbished 3,500 meters square, 1,270 tons of carbon, and lots of savings, 66%, 54% in terms of carbon. So the story in a carbon context definitely is one of the things that we should be doing a lot more. But of course, it requires a good understanding of materials, supply chain, and all that, right? Because you are taking out something that's 30 years old and then checking that it's okay, not okay, and then put it back, right? This one is very quick. Basically, a museum with timber, and they timber inside and glass skylight, and the timber was considered okay, no problem. But then they refurbished the glass skylight on the outside, changed a bit of the aluminium sections, and again, goes back to the system. Quite innovative. In this part of the world, probably we won't do it. This is my last example, Lloyd's of London. Again, this one of the more interesting ones. And from day one, again, I must emphasize there's already something and a remit from the client to actually say, hey, let's refurbish this. this is grade A office space, let's see what we can do, maximize it. Right, and then the interesting about this is a sparkle glass. There was, in the olden days, they actually have a roller, they run past it, and this is what you get. Quite interesting. But when they wanted to do this or restart the project, this roller technology, on that roller particularly for this project previously was already gone, obsolete and thrown away. So essentially what they do was to take that piece of glass and then they put it into a DGU format. Right, so basically from a single glaze, take the glass, put into DGU, very highly complex process, and then put it on again. So it's a very deliberate way of thinking, and some parts they're made into different ornaments around that office. This is the magic, right? But this magic costs money. Save carbon costs money. Okay, so last slide, very quickly. I think it's something that we have to do. We all see where the direction is going, with climate change, and this is possibly one of the most effective way of, moving in that direction. As energy efficiencies of buildings improve, the time in the other parts of the production and the installation of building material becomes more important. And then there are more codes and all this, that will essentially govern this whole process. So we got to then look at things in a totally different lens. Once we add a carbon story to it, it doesn't mean it changes the things that we have to do significantly, but I think that's potentially something that it will come, and it will drive our design decisions, and a new approach will come. All right, and we'll come to the way we eventually build and look at our real estate pipeline in the future. We can't be building, because at some point we've got to stop. So again, this is the inverted triangle, and the last piece, if you don't remember anything out of this presentation, is probably look at the lower bits where we say build clever, build efficient, minimize waste, build low carbon. Not so much of build nothing, build less. Otherwise, we won't be here today. In the next few years, if we do build nothing, we will be eating grass already. But that's something to think about. Have this in mind. This is a good mentality to have, because eventually this will drive our business decision and the way we actually develop our real estate and our buildings in the future. Okay, with that, thank you.
Thank you, Michael. Thank you. Hello. Thank you, Michael. So, as I said, embodied carbon is, I think, the thing to look forward. We are not yet reached our operational carbon levels, but we have something else to consider now, embodied carbon, just because the world is reacting differently. Our climates are changing very fast, so operational carbon. Europe has taken a lead. They are obsessed with embodied carbon, which is rightly so. Designers, consultants in the UK and Europe, especially the UK. UK is probably going to be the world leader in embodied carbon calculations. They are obsessed. You saw one slide where Michael showed about laminated glass, embodied carbon level being very high. So every manufacturer now is coming and trying to work on how to reduce embodied carbon. So in London this year, we will have a manufacturer of laminated glass interlayers talking on how they are launching low carbon interlayers. So efforts are being taken in other parts of the world consciously, and I think in a couple of years, after the Western world have incorporated embodied carbon, have reached embodied carbon to a level where they can advise other parts of the world, Malaysia and other Southeast Asian countries will be in a better position to learn from what they have done, and this is something which we need to consciously look at. Some corporate clients are already asking for embodied carbon savings, but I'm sure other developers and other investors will also be asking for the same, if not now, then in the near future. So thank you, Michael, for that excellent talk. We're moving on to our next presenter. It's Nicholas Ling. He is a partner at Konzepte Architects. He's going to be talking on skin deep, and he's going to be covering enclosure, inside out, and messaging. So can I request Nicholas to come on stage, please?
Next back, yeah. Morning. Wow, it's a bit of echo. I think it's a bit sort of a bit funny, or it was a joke by the organizers to sort of pair me up or to come after Michael. Actually, in many ways, this talk is quite a bit different from what Michael has actually set up for us this morning. And also, to a certain extent, it's a bit of a segue off the beaten track, perhaps, on what the conference is about. I think we, as a practice, sort of think about buildings, yes, the facade as an important element, but the facade as a system and part of the makeup of the building. Maybe a bit of an introduction. We are a very small practice called Konzepte, but I run a design office or design strategy team alongside the practice proper. And we'll take you through 7 projects this morning, looking at facades perhaps in different ways. It looks fine on this, but it's black, yeah. Oh, there you go. Excellent. So if we look at facades, or we draw it right back to its sort of beginnings, we're looking at facades, or at least even before there is a building, as an enclosure, as in its most simplistic form. And we're all familiar with these typologies. The need to moderate, in a way, between the elements or the environment, and to create I guess, or to contain an environment that's perhaps a bit more conducive to the way we may want to live. And on one hand, the extremes of the desert, on the other hand, this is the South Pole Station. And then facades have also the second burden, perhaps in the past, to be structural, to hold the building up. Hence the small windows and the ratio of structure to opening. But obviously, as technology allowed us, we've seen a Seagram building, a departure from that to a certain extent, where the facade itself was liberated from the burden of structure. But we do see architects revisiting that along the way, and still today, where the facades becomes part of the structure. And I guess the third obligation, or the third burden of facades, has been, to a large extent, storytelling, or messaging, if you like, for a representation of an agenda, or a people, or a culture. And we can see, obviously, and that is rung through. So it's gone from the basic needs of providing enclosure and moderating between environments and structure, and to this point where we feel, as humanity, as people, to begin to tell stories through our buildings, through our facades. So I would like to take you through 7 projects of ours in no hierarchy, no sort of order, perhaps just exploring the way we think about facades, the way we work. Less, VLT or G values or double glazed units, but perhaps in a way that connects with our humanity a bit more. So this is a very tiny building in a tiny city, my hometown of Kuching. It's 14 stories high. It's shaped predominantly by the planning guidelines. So we have the local council to thank for the form of the building. It's a very simple building, and it's basically a concrete exoskeleton, a concrete RC structure, punch windows, and effectively, it's a concrete skin that's wrapped around a floor plan. And you can see we have actually wrapped the plan, or actually living spaces, around a very small central core, with the west side given over to communal space and a vertical canyon of about 14 stories. So the living spaces faces north, a bit of the east, and then south. So this skin becomes this unifying sort of device, if you like, bringing the community together. From the outside, it's a very simple object, but there's a sense of complexity and a sense of, I guess, interactivity behind that very quiet and simple skin. So that's that 14-story vertical canyon, which also serves as a fire escape, and where the fire lifts are located, that connects the ground all the way up to the top of the building. So the facade in this case is ambiguous to a large extent. It is both serves the purposes of enclosing a building, but at the same time bringing the community together under one roof, literally. So this is about to break ground in the heart of Kuching early next year. I've got quite a few slides, so we'll quickly go through. The next one is our explorations, perhaps into computational modeling. In this case, to address the fins on the facade. So we look at fluid dynamics, and we collaborated with a third party to devise a script of some sort that was able to connect the forces that we were modeling in our wind tunnel testing with the shaping and the sculpting of the fins on the facade. And there were some 3D printed models produced as part of the process, and ultimately a translation of that data or that modeling outcomes to the fins on the building. And this was actually modeled based on the forces of the actual wind dynamics around the building. So this is about a 40-story tower in Malacca. Another one that we explored in a similar fashion, which has just been built or just been completed along Jalan Ampang, also took that sort of approach, where from the sort of the computer and the data, there was sort of physical modeling to sort of test the geometry, and also we had to go through a rationalization process to establish the different degrees of the rotation of the fins. This is a very small hotel that's currently being built in Cambodia. And we were exploring in this case this idea of a facade that was connected with the community that it housed. And it's a double skin system, so we've got the glazing with the, so this is the facade with the second skin stripped off. So we've got very simple double glazed units, punch windows which face onto the Mekong River, and then allowing the residents or and this is a hotel by the way, allowing the participants to sort of participate in the sculpting and the changing of the facade. So the building stacks up as two zones. We've got the lower zone quays. Okay, right. Sorry about that. So the building is composed of a ground floor, which is connected to lobbies and arrivals and restaurants. We've got two zones of quays, the lower zone, upper zone, sort of broken by the facilities. So as I mentioned before, the facade comprises of the glass, obviously the enclosure, and then a second skin of screens which the occupants could actually change and modulate to look at and to enjoy different levels of privacy, enclosure, and obviously screening. So in this way, the occupants become, I guess, part of the look and part of the outcome, ultimately, of the facade. And it allowed for a very dynamic, ever-changing facade of the building. So not something that's sort of quite completed in a way ever, and continues to evolve as the occupants use the space. This is our fourth project. It's again a very low-rise building in Kuching. And this is very, sort of, in a way, it was sort of designed in a very simple way. It was hemmed in on all four sides by existing projects. So in many ways, it was an attempt to not overlook and not look directly onto our neighbors, but at the same time also to orientate the units so that we mitigate the western and eastern sun to face it in a north-south direction. So the solid faces and the shear walls were sort of oriented west and east to cut out the eastern and western sun, and also served as a structural a wall without any transfer from the ground. And in a way, it allowed for a certain identity for each unit, which also mirrored, I guess, the sort of the floating villages around and along the coast of Kuching. So you can see here that every unit has an address on the facade, and they're not sort of hidden in a sort of ubiquitous form, homogeneous form. This building has broken ground and it's slated for completion in 2024. The next building is one we're halfway through construction. It's a very simple building on an extremely tight site. It's on an 11,000 square feet site, a bungalow site in the heart of the city, next to Tribeca. If you know Tribeca, along Jalan Imbi. It's a 40-story building, and this I must do a bit of a plug for our partners Shuko, who are the glass suppliers and the facade suppliers on the project. And being a very small site, I guess the architectural operations that we were afforded or could pull off was obviously very limited due to I guess the need for efficiency, structural logics as well dictated a lot of that. So the site sits on the corner of two very small streets. At street level, it's extremely compressed in its condition. There was really a very little view around the corner. So I think the attempt, or at least the intention from day one, was to liberate the corner, to bring the city in as part of the building, despite it being a very small site. But also at the same time connect the building with the broader city. And we did that through these three small cuts in a very simple building. At the top, obviously, to connect with KLCC and the views in that direction of the city. And at the mid-level, to connect to the golf course. And obviously at the ground, to connect with its immediate neighbors, in this case being the century-old rain trees. The structural system was I guess, key to the developable, or to the actual usability of the site. The building sits on effectively four super columns, the three cores as well as one column on the corner, and transfers to a shear wall configuration above the transfer plate. So three supercuts introduced to the building, sort of mimicking, I guess, to a certain extent, the sort of the stratification of the tropical rainforest, housing different sort of gardens and different green spaces. At the ground, obviously opening up to the lobby. You can see here, with these big cuts, we were able to again connect the small footprint of the building with its immediate surroundings. At the mid-level, another big cut to then connect with the golf course in the city, and obviously at the top to connect with the skyline. So in this building, a very simple DGU facade, sort of in a way contrasting and juxtaposing with the big cuts. The car park podium is sort of resolved with these gills, which open up in one direction to serve as ventilation. So the building is under construction. We aim to complete this by the end of next year. The next project is a hospital, a private hospital that we have under construction in Bukit Jalil. And we took a more sort of, in a way, scientific approach to sort of thinking about healthcare and the building of clinical facilities. And there was a lot of looking into the work of Aaron Antonovsky, which is a psychologist and also a researcher. So he talks about this sense of coherence within healthcare buildings, this idea of managing stress, which ultimately contributes to the recovery rates of patient. And there are sort of 3 points that he speaks about, which is comprehensibility, manageability, and ultimately meaningfulness, which is stories. Right? We're all familiar with hospitals being like this, at least some hospitals. Obviously, that's gotten a lot better over the years. I think there's this attempt to then connect hospitals with the community. So hospitals not as things you go to when you are sick or you need help, but things that are part of the city, that are part of the community. We have a very deep floor plate, and what we tried to do here was to create openings within the floor plan to connect the building with its immediate community, with the surroundings. At the same time, became an orienting device where people were, the moment the lifts open, they step out the lifts, they could understand where they were relative to the surroundings. So that was a sort of a commitment by the client from the early days. So there is sort of large windows, if you like, onto its immediate surroundings and the city. And in doing so, we were able to, in a way, make the floor plates a lot shallower by bringing in light and views throughout the building. And in this attempt of creating an envelope which could connect with the sort of the humanity of the patient, there was this attempt to bring landscape and nature close to clinical areas in a very real way. So you could be in your ICU beds at the same time being alongside a garden right next to it, or you could be a doctor in the theaters, a surgeon operating at the same time with views out onto the gardens. So simple, very simple moves like that. So the facade is composed of these planter gardens along its perimeter for its podium, which we've been working with our landscape partners to sort of source native species which are native to both, the region and the area. So there's sort of 3 facade systems, if you like. We've got facade system A, which is the podium, which deals with a lot of the clinical functions of the building. Again, the clinical spaces are right adjacent these sort of planter gardens. And then facade type B, which are the inpatient units, which sit up above the building, or they occupy the top level of the building. And we can see here sort of a more detailed subsection. Sorry. And the entire podium facade has been sort of modularized so that the building could adapt over time as the clinical functions shift and change and the models of care moves around. The facade could adapt to these different conditions. So just a quick detail to sort of explain the facade design. You could see on the outer layer the planter boxes, and we've got a plenum which allowed for services and service penetrations to exit the building for exhausts or for intakes. So in a way, as the clinical functions shift and change, and as these penetrations shift and change, they were always contained within the plenum boxes. So a very simple detail to resolve the ever-changing needs of a hospital and to hide all of that, obviously. The inpatient units, again, just adopt a very simplistic way of thinking about the facade as well. These are the single bedrooms. So we've got openable windows for the inpatient units. And sort of the decision was made very early on in a project for the amenity of the patients lying in a bed. And we simulated this, obviously, with a real bed and in real dimensions, that the windows in most hospitals obviously have a 900 up stand, I guess to a certain extent for cost and for maintainability. But it was decided very early on to commit to this aspect ratio of a more vertical view out, so that in sitting in bed or lying in bed, the patient was able to connect with the ground, which is a really important thing, according to a lot of studies. And it normalized the process of being in bed as well, so you didn't feel that you were in a hospital. In the double bedrooms, again, a very simple move of introducing 2 windows instead of 1. So the sort of the outboard bed did not, in a sense, hog the outlook of the room. So one window was in a way unique or adopted by the outboard bed, but the inboard bed, and also for the doctors or patients entering the room, there was always a view and connection out. So in clinical spaces, a lot of these small moves contribute to the overall, I guess, amenity and the stress management of the building, and ultimately the recovery rates of patients. And there's a lot of empirical sort of research that point towards that and that can back that up. So you can see here the second bed or the inboard bed is still able to have the amenity of natural light and connection with the outside. The last project is one that's extremely close to our hearts as an office, and ultimately, as we spend the rest of the day talking about facades in a very technical way and very important, obviously, and conversations around the carbon footprint and the embodied energy and the performance of facades, I think it's sort of important to be reminded ultimately that we are, after all, participants in the making of buildings, and which contain people. Which contain cultures, which contain memories, and ultimately connect with humans and all of us. This is a small museum that we are working on, which is a memorial for the Vietnamese people who lost their lives during the Vietnam War, traveling from Vietnam to Australia. So this project is in Melbourne, which we won via a competition a couple of years ago. It's in the suburb of Springvale. So the whole building has been designed about this idea of telling a story, but not just telling it through pictures hanging on walls, but through walking the journey from obviously Saigon through this arduous journey of being on a boat, being obviously a lot of people dying, women being raped by pirates along this way, and then ultimately landing on foreign land in internment camps in Malaysia, in Thailand, and finally making their way to new land in Australia. So a very simple diagram we prepared for the clients. So this idea of the museum being one that you had to walk to experience this story. It's composed ultimately and it's sculpted by these GRC walls on the facade, which again serve 2 purposes, obviously to tell a story and to modulate views and light, at the same time also to manage the western sun. It's a very small building. It's 5 stories in height, 6 stories in height. And you can see the main core in the middle here, being this sort of journey that people have to walk, and it's annexed by gallery spaces as you go up the building. So DGUs to manage again the climatic demands of Melbourne. GRC panels that are with ferrous pigmentation to connect with the red earth of Australia, of the new land. And that continues internally as well. So the sort of immersiveness of the narrative and the story. And I'd like to sort of end with this slide because I think it's a reminder again that it's for people that we ultimately are designing for. So the project has broken ground. I'm very excited about it, and thank you very much.
Thank you, Nicholas, for that interesting presentation. A wide array of projects. Okay, so moving on next, we've heard a lot about glass, aluminum being spoken. I think our next two presenters are talking about two lightweight, innovative materials which are slowly picking up traction, but are the way to go forward. The first of them is ETFE. Mathieu, Penrose, Executive Vice President of Vector Foil Tech, based out of their Singapore office, is going to be presenting on what is ETFE, how it is a lightweight, sustainable, and structurally safe solution for the modern building envelope. So over to Mathieu Penrose, please.
Good morning. Salamat pagi. So today I'm going to be talking about ETFE building envelopes. What is ETFE? So it's a fluoropolymer. Critically, it's not a plastic, and it's not derived from the petrochemical industry. Unlike plastics, fluoropolymers don't have problems with fire, sustainability, recycling, UV resistance. And a picture there is one of the most selfied projects before COVID at the Jewel at Changi Airport. ETFE has been around a long time, invented by DuPont, and it was a material that had amazing corrosive and aging properties and could take very high and low temperatures. And it was our founders 40 years ago that took it from the chemical world and brought it into the architectural world. Now, the idea is simple. Take 2 layers of ETFE and inflate it with air. And that air gives the lightweight properties. It gives all of the thermal, high thermal performance, and critically, it's always lightweight. Now, just a view of a typical system from the underside. You have this ETFE cushion of 2 or 3 layers welded and connected into a perimeter frame, very much like a large curtain wall system. And from above, again, very similar, and one of the things we have to use quite a lot in the northern hemisphere are these anti-bird wires. The birds don't like to stand on the ETFE. It's self-cleaning and slippery, so it just stops those angry birds we have in Europe. Now, the system is lightweight, but it's very advanced. It can take very high thermal movements, very high structural movements, airtight, watertight, and has a secondary drainage channel. Now, yes, ETFE is lightweight, probably around 90 to 95% less weight than the DGU system, but is extremely strong and can bear 400 times its own weight. So this is a video from 20 years ago with a young Kevin MacLeod when we were doing the opening of the Eden project. And the great thing with ETFE is we can load share. You put a point load on it where maybe glass would break or shatter. ETFE will distribute that load across its surface, and ETFE can be used in typhoon and hurricane conditions. Now, projects we're most famous for, currently the largest ETFE project in the world. This is the Beijing Water Cube for the 2008 Winter Olympics. And there's 100,000 square meters of ETFE used on the exterior and also the interior. And it's one of the few Olympic buildings that make money. It's a tourist attraction if you go to Beijing. And the practice pools on the left were converted into an all-year-round water theme park. Now, this project you'll hear a lot about towards the end of the year. It is the largest ETFE project in the world. It's the King Abdullah's Gardens, a gift from the people to the King of Saudi Arabia, about 120,000 square meters. So look out for this project. It's being installed as we speak. But the most famous project, of course, probably in Europe after the Beijing Water Cube, was the Eden project. These are giant domes, approximately 55 meters in span, 100 meters long, and they're about 8 meters in diameter, each cushion. And ETFE, of course, is the best translucent material for plant growth. And because of the lightweight nature of the ETFE, we also get very lightweight steelwork. Those giant domes you saw on Eden only had 667 metric tons of steel, something like 25 to 30 kilograms per square meter. Now, one of the really exciting projects that was Hudson Yards. It's the largest private real estate project in US history. There's the Heatherwick vessel on the right, and on the left is the shed. And the shed is an amazing show for the developer. It's an exhibition space that can double in size. And it's only possible because the ETFE is so lightweight, but also flexible to take the cranking, the moving of that facility. And of course, for the developer, it's all about the show and get people talking about his project. We do a lot of work, obviously, with engineers and architects, but we also work with people like Disney Imagineering. And this unique 6,000 square meter canopy in this form, I mean, if you think about it, what else could do it? It needs to be lightweight. It has to take an extreme shape, has to be watertight, thermal protection, and at nighttime transform. And this is where ETFE really gives you options. It's so successful, it's one of the few projects that started in Asia and is now being rebuilt in the American theme parks. And what you'll see about ETFE is during the day, it looks quite solid. It's giving you thermal protection. At night, it becomes translucent, and with simple lights, it starts to glow. So you get a daytime identity and a nighttime identity. Now let's look at typical uses of ETFE. Let's start with airports. Project Jewel, right at the heart of the Jewel is the largest indoor water fountain called the Vortex. And right in the middle of that is this wonderful 12-meter wide single ETFE cushion. If it was done in glass, it would need somewhere between 50 to 70 pieces of glass, which would completely destroy the look of this open shaft of light. Of course, right outside, we have 4,000 square meters of drop-off canopies, and the Jewel is connecting terminals 1, 2, and 3, and we had to install all of the steelwork in ETFE whilst the airport was open. Now, this is Beijing's second international airport, nicknamed the Starfish. It's, I believe, the single largest single building in the world. And when you enter, you'll be greeted by these single layer, great big cantilevered ETFE drop-off canopies. Now, high wind loads. When we talk about the Philippines, we're now looking at design wind speeds of, I think, 310 kilometers per hour. And recently, Cebu had a very, very hard typhoon. And one of the big power cuts for months. And one of the things that was not damaged was the ETFE. It's flexible. It moved. It literally, as the wind blew, the ETFE moved around and it didn't shatter or break or get affected by flying debris. This was also the winner of the World Architectural Festival Transportation Building of the Year, and these curves were inspired by the rolling waves of Cebu and then all reflected in the structures. Now, we've done a lot of projects in Malaysia. Very, very fortunate to work here. So Aspen Vision City in Penang was a joint development with ICANO, Southeast Asia, or IKEA. And right through the middle, you have this 13,000 square meter canopy. And it undulates, not just for show, but it also allows free movement of air. There's a lot of vehicles parked under the canopy, and we had to do modeling to show where would all the fumes go and how would you deal with it. And again, that avenue is where all the attention is. The ETFE allowed a 24/7 venue. Just interesting, the developer really pushed it. He managed to get the two Guinness World Records from the ETFE. I think it was the largest canopy in Malaysia and the longest canopy in Malaysia. Now, we've also got what we call the mega canopy at Bukit Jalil. It was a very complex project given to us by Pavilions to make an outdoor event for any event, from car launches to fashion shows to discos to dog shows to playgrounds. I'm going to talk about this as the case study later, but a little peek view of this 7,000 square meter canopy. Hard to see the scale. Maybe look at the small Alfred in the bottom of the picture. Now, Pavilions like to give us complex work. This was a late addition to the Royal Pavilions Hotel. The main contractor just said, don't do it, we can't do it. So Pavilions gave us the engineering, the steelwork, and the ETFE. And our job was to install a canopy 80 meters in the air with two of the busiest roads and basically no access. Well, the only strategy was a tower crane. And we used our brains and we went, right, the tip load of the tower crane's 2 tons, maximum capacity was 6 tons. Everything is designed and engineered around that. So the largest trusses were 36 meters long. We designed them 6 tons maximum, hoisted them in 2-ton sections onto the flat roof, welded them together, and then the tower crane could install them. And then you see here the blue netting is our safety system, so no scaffolding required, pre-installed on the trusses and lifted into place. And the results are amazing, giving protection to the facade, to the balconies, and to the courtyard. Equally challenging was the connection. This was a retrofit. We couldn't add any bending moments to the existing columns, and it was there to stop the driving rain problem. Every time you had driving rain, it went halfway down that avenue of restaurants. So again, we put in these ETFE canopy, we put in ETFE vertical louvers, all while probably 100,000 people a day were moving between Pavilions and KLCC. Okay, I hope they can help. We might just have to reset this image, apologies. But the project I'm going to talk about there is the avenues. If you went to Kuwait, there's only one place you go, the avenues. Over 4 phases, we installed 117,000 square meters of ETFE. And why do they keep coming back to ETFE? Well, one is the lightweight structures, high thermal performance, and high light transmission, and low maintenance. But one thing Kuwait suffers greatly from is sandstorms. Horrendous sandstorms. The ETFE is unaffected by the sandstorm, And if I could show you the picture on the left, which is hidden, you would see the sand builds up on the glass roofs, but the sand does not build up on the ETFE. It's completely clear. So yeah, a big problem in the Middle East, and it's getting worse, is sandstorms, and a lot of this was to do with draining of ancient swamplands during the Iraq wars. Okay, so this was a photo taken just after one of the big sandstorms. ETFE is here on the left, not cleaned, and the dust just blew straight off it. Okay, well, I'll talk a little bit about the next project. It's Arctic. It is the first lead transportation building. It is a mixture of 8 different public transportation systems in Anaheim. If you were going to go to Disney, you would likely go through here. And one of the main reasons of that lead award with Platinum is, of course, the huge reduction in carbon footprint, because the steelwork ended up being 50% lighter. The ETFE performance was greater than triple glazing, and a very low, and ETFE has basically the lowest carbon footprint you can have of the translucent materials. So let's see if, so what you would see here is these giant 7-meter long ETFE cushions. And what I can't show you is, in the daytime, you have this solid aluminium look, and the aluminium is reflecting all of the heat, while at night, some simple LEDs on the building turns it translucent, and you have that daytime and nighttime identity. All right, so those images you couldn't see. Singapore Sports Hub. So the wonderful thing with Singapore Sports Hub, it has a moving roof of ETFE. That can open in about 20 minutes, but also that roof is integrated with 20,000 LEDs. It becomes a pixelated 20,000 screen and Singapore's largest flag. Now, a lot of work we do, because the ETFE is about 90% less than a glass system, we do a lot of retrofits. This is the largest stadium in Holland, and they turned a convex stadium into, well, a concave into a convex, no scaffolding, fully operational, brand new walkway with ETFE to protect guests and transform the look of the building. High wind loads. So again, I get a lot of people go, well, this is a lightweight material. How do you take high wind loads? Well, we do. This is the new Ocean Park all year round theme park. It's, the wind loads are very, very high, and building control is very difficult in Hong Kong. We had to deal with about 5 kPa or 500 kilograms per square meter of load. We designed the steelwork, no trusses, and integrated into our own roof. We also had to put 40 openable smoke vents, also cladded in ETFE. So don't worry about any of the loads. We work exactly the same in every country. We design to local design codes. Resorts, ETFE's used a lot, whether it's hot or cold. You always want natural light. Paradise City's the first sort of casino resort in Korea. And the ETFE was used, obviously, for the daylight, but critically to either keep you cool in the summer months or warm in the winter months. And similar again in center parks in France. But in this scenario, we're using a glue lamp structure. In a chlorine environment, a lot of materials get attacked. Glue lamp and ETFE tend to be the perfect solution. Resorts World, 25,000 square meters of ETFE allowed everyone to move around the resort 24/7. It was also in the Universal Studios, and again, the ETFE was themed to try and help the overall styling of the theme park. Education, again, ETFE is used heavily. This is the largest preschool in the world, Early Learning Village it's called, and all the outdoor areas were covered with ETFE because we could control the UV levels to keep the children safe so they could play all day long without worrying about being sunburnt. And again, a lot of education facilities here in Malaysia. One of the first ones was University of Reading, a 3,000 square meter naturally ventilated space between the learning blocks. And one of the oldest projects here is out in Bandar Utama. It's actually at the British School, and they invested right at the start. They wanted an event space where the children could always play, and parents never had to worry. Now, some of the technicals. Inflation. This is Clarke Quay, which we're currently upgrading for Capital Land. It's 17 years old now. This little white box, size of a suitcase, is an inflation unit. It inflates that entire roof you see there of 1,500 square meters. And that little box, typically German, it's fault tolerant, efficient, quiet. Put it up there, forget about it. It costs about $1 a day to run. Now, printing. ETFE is transparent, naturally, totally transparent. We add basically a special print. Because ETFE is a self-cleaning surface, one of the hardest things you can do is apply print. So our prints, this is the same skylight, top and bottom. At the top it looks solid, underneath it looks transparent. And that's the technology print. We change the prints to change the thermal performance, light, medium, dark, and then patterns. And from that, we have all of the empirical and proven data, so we can tell you, you can tell us your performance requirements, or we can tell you what we know works. We can also increase the number of layers within the cushion. So you start to go from double glazing to triple glazing to quadruple glazing UV performance, but at 95% less weight. We can add color into the ETFE. We start playing visual tricks. As you see on these projects. Longevity. So these are some of our first projects almost 40 years ago. Samples were taken. There was no change mechanically or chemically in 40 years. What is changing is every year the ETFE the clarity gets closer and closer to glass. They've worked out how to get the molecules to line up so when the light passes through it, you have greater clarity. Some of the older projects look a bit milky. The later projects are very close to glass. ETFE is sort of the brother of Teflon, so you have those self-cleaning, non-porous surface. And in fire, ETFE, you look it up, you'll find zero problems the last 40 years with fire. ETFE will move away from the fire and self-extinguish, and in this case, make a smoke vent. Okay? I lost a lot of time, you know. So we have all of the testing facilities. Again, EN 13501, I think our friend Mathieu Meur will be talking more about this, really looks at flame spread and is the best testing you want. We obviously do a lot of work locally with Bomba on our projects to get all the approvals we need. And we have every type of test you can imagine. We are the most sustainable, lowest carbon footprint, most recyclable, translucent material in the facade industry. And we have all of the different credits and certificates you need if you want to help that. Now, 2 more minutes, case study. Hopefully you might have seen this project, or you might not have. It's Pavilions 2 on the outskirts. And again, this amazing 7,000 square meter canopy. Now it's a 120-meter span. So this is what was given to us. This was the dream. And on the left was our renders based on our engineering, or the top picture, and on the right was what we delivered. We hit the brief. There is 125 meters by 115 meters clear space on this canopy. In addition, we did everything: steelwork, engineering, authority submissions, fans, PA systems, lighting, winches, you name it, was all awarded to us. And the final result is amazing, and I'll show you how we got there. We engineer like everybody else. We follow the local design codes for the steelwork, for the ETFE. We use the same combination of wind loads, maintenance loads, service loads. This was the solution. We needed a long span with no trusses. One thing Vector Foil Tech hates is trusses, but we can get away with them. So our solution is basically long built-up beams, diagrid bracing with a tension ring perimeter, all sitting on tree-like pin-based columns. And as I said, when you start looking at the scales involved, and then this is the different breakups, you see the longitudinal layers and the tension ring. Again, we're working to all ultimate limit state for all the structural engineers. We work exactly how you would with all your other materials. Now, our biggest problem was we couldn't put any load on the car park. Tiny little pre-stressed slab so we had no way of bringing mobile cranes onto the site. So the entire strategy was based around a tower crane. And we put up temporary support, and then we used the tower crane to hoist every member from the perimeter fire road. No heavy vehicle could go under the canopy. So here you really see how much movement there is between each beam. And we're using our safety net system to install the ETFE. And the longest cushion in the world, 120 meters long, and the end result is a roof with no joints along its length, exactly requested by KLPDS. And finally, the work below, we could finish off the MEP using boom lifts. And you've seen the results. Thank you very much.
Thank you, Matthew. So if there are any questions for Matthew, they have a booth outside. You can ask him and his team the questions. Okay, the next material is fabrics. Fabrics are the next important thing for building envelope design. You can use fabrics in different ways. Mohammed Bahsh from Search Ferrari is going to be talking on tensile membrane facades, their architectural functions and benefit.
Good morning, ladies and gentlemen, and welcome to Search Ferrari Group, worldwide leader of producing technical and architectural textile fabric. Actually, before I start the facade presentation, I would like to take you into corporate introduction of the company. So our strategic market actually fall into four key segments. We start in tensile architecture, which is the solutions for anything in roof or facade, including acoustics. The second market segments we're active in actually is modular structures, which is anything temporary, including hall, festival, event structures, etc. The third market segments, it's the solar protections, which includes indoor and outdoor blinds. And the third, but not the last but not least, actually, is the furniture and yachting, indoor and outdoor furniture for these kind of segments. We start now in our facade and how we can actively participating and providing a solution in the facade solution. Literally, actually, if we take the word facade, it comes from the French language, which literally means face. So in architecture, the facade of the building is often the most important from a design point of view. So it set actually the fashion. So it provides the signature or the identities of any building. Yet in fabric, the most important things, it's not only just to have a pretty face, but also it has to be durable and it has to function, long-term functioning. Now, we associate ourselves to the, in architecture, to the natural light. We know that we all perform very well with natural light, but unfortunately, 90% of our time is spent indoor. So in the fabric facade, we take this element seriously into consideration. So basically what we do is providing a high performance solution in improving the indoor environment by providing maximum translucency and natural light into the building envelope, yet enhancing the sun protections and thermal comfort by providing the natural air ventilations into the building, but also controlling the glare and temperature. And of course, reducing the energy load, and that is one of the most important things which we will see later in the next slides. And the most important part here also is to increase the building value by providing some sort of exclusivities or landmark images. Now, if we take the fabric and how we can construct the fabric in facade, we have two constructions way. One, we call it the modular membrane facade, which is basically the framing system that can become in different dimension and different shapes. And also, this is basically is for the second skin solution. And the second one is the tensioned membrane facade, which actually with the support of the primarily steel and cables, we can create a main skin as what we see here in the photos of Burj Al Arab. What we will take you in the next few slides actually basically is on the key benefits of using fabric facade solutions into your building. The most important one we will start with is the design identity. Then we're going to go into the visual comfort and glare control, thermal comfort, and then the most important things sitting up recently is the fire performance and safety. So when we start with the design identities, the fashion factors. If we look at adding a design elements as a second skin, either in a straight or a 3D dimensional, you can see how fabric structure can transform and change actually your building features. If we take this as a good example, the B-55 Airbus in Toulouse, France, it's a few-story building where facade elements has introduced in a 3D shape to provide an identity to the building, yet providing an excellent visibilities from inside to outside. It also helped to reduce the energy loads. But also, if we take another example, because of the mechanical properties of the woven structures of the fabric we provide, it can help you actually in going high. This is a very good examples in Germany with wrapping up buildings up to 250 meter height. Simple but elite and chic by providing a front face of an existing building. What we see here is a 3D shape actually of the front side of an existing building with fabrics. Second factors in fashion actually is the LED lighting and projections. And if we look at the identities, changing identities in fabric skin between daylight and nighttime, you see different identities of the projects during the daytime, but the most significant feature and benefits you get at night is changing the identities by eliminating the light and getting the reflections from inside to outside. We take another good example of a small two aluminum box here in Netherlands during the daytime, but at night with the LED concealed the identities and distribute evenly the light in a different ways. This is another good examples in Germany. Okay, small but yet elite and chic. This is a hotel, a small hotel in France, in Austria, where you see how LED lighting can transform the entire building. You can still consider the projections. It's not only LED lighting, but also the fabric. It has an excellent illuminating skin to project screenings. The third one in the design identities or the fashion is printing. We have a fabric that has an excellent surface treatment to apply print. Take this as a good example here, where we still can customize either your branding or either special colors or special patterns actually into the fabric, and this goes durable and in long-term solution. The second key benefits actually in fabric facade is the visual comfort and glare control. If we take this office building in Vritz in Germany, with the support of a second skin PTFE fabrics, we transform the complete building into a different identities by protecting the entire building from the diesel, from the temperatures, and providing an excellent natural light into the building without harming the human eyes. It also improves the lighting quality and the visual comfort. And of course, this is something very important as what you see here in the gap. The natural air ventilation helps actually in reducing the final temperatures into the building. The third one is the thermal comfort and energy saving. And see, in this, as a good example here, what we see here is the difference between a classic interior and exterior ventilating system, where in these photos here, in this image, you see that's the blinds installed internally, while what we do in the facade system is applying the facade externally. By having this air gap in between the fabric and the glass, the airflow acting as a natural ventilating system to control the final temperature touching the glass. And as a result, there are so many case studies, but with the time limitations, we will go quickly on them. It helps actually to dramatically reduce the overall energy consumptions of the building. This is for a good example. The building by itself, without applying the second skin fabric, it consumes then around 68,000 kilowatt of an air conditioning loads. But when we apply actually the second skin fabric, it reduced the energy consumptions almost into half. A second good example or a good case study is the Silver Spa office in Los Angeles. This building has suffered a leak of energy consumptions prior to the 2005. The investor or the owner of this building decided to invest $200,000 by applying a second skin facade system. The saving has been significantly around $60,000 per year. So over the last 15 years in operation until 2020 with this case study, the owner has managed to save around $700,000 from the initial investments of $200,000. So the fabric helped actually to reduce the energy loads. What we can help you here in the group is we have a software to analyze the fabric based on the geographical locations of your project, based on the glazing system and the percentage of glass in your building. We stimulate different fabric solutions, and we can provide you with the solutions of the reductions in the annual consumptions of energy. The last one here in the benefits is the fire performance. We know fire now, there are different countries around the world, they introduce strict fire norms. Thus, in Serge Ferrari Group, we combine two leading technology under one roof. We have the PVC, we have the polyester coated PVC, and then we have the fiberglass coated PTFE, or Teflon. And both, they have a different kind of reactions to fire. The PVC is a fire retardant, while the PTFE is a non-combustible Class A fire resistance. The good things about the PTFE, since it's a non-combustible or a fire-resistant fabric, there are growing demands of using this lightweight fabric into the multi-story car park structures as alternatives to the metal mesh or the stainless steel mesh because of the weight, as what we see here in this as a good examples. We will show you actually the non-combustibilities material and how they react to fire in comparison to different fabrics in this video.
Until now, buildings with stringent fire safety requirements, such as high-rise buildings, schools, universities, in fact, any building where a concentrate of people are found, could only be built with expensive materials or specialized construction. With the first non-combustible, breathable facade membrane, Stamisol Safe 1, we have created an excellent solution for those wanting to implement a curtained, rear-ventilated facade with joints or open facings. This means that maximum fire safety for the entire building envelope is now possible, which includes the reliable prevention of fire spreading in the rear ventilated layer as well as toxic fumes. See it for yourself. The test resulted in no change of the product composition up to 300 degrees Celsius. With a resultant fire test taking a temperature up to 800 degrees Celsius without catching fire or giving substantial toxic fumes. You too can now rely on maximum fire safety for all of your facade projects.
So, if we combine all these benefits together, and we will find them very useful actually in renovations. If we look at Malaysia, if we look in Southeast Asia or across different parts of the world, there are so many good buildings, but old in terms of optical appearance or in terms of energy leak. The fastest way actually to pump a new life into those buildings by going into renovations, by introducing facade panels and transforming the old building into a new look building. This is not limited to low-rise building, but still can be implemented in a high-rise building, as what we see in this good example in Netherlands. Now, if we look at quickly, if we touch base, actually, the differences between macro and micro perforated mesh, and you can see in the good example in the micro perforated in the fabric compared to the macro mesh in the metal, you see clearly the visibility. Visibility is much clearer actually with the micro perforated mesh solutions produced in fabric compared to the metal, and you can see by yourself in this images here. So basically, what we can provide you here is a solution, is a long-term solution that has an excellent mechanical resistance, excellent resistance to the impact, either snow, hail, whatsoever, color fade resistance, long-term optical values, and of course, the most important one is the low maintenance and the cleaning ratios. We have long range of fabric to choose from. Please visit us outside in our booth to show you in details actually the solution, the fabric, and you can touch and feel the material itself. These are good examples of the non-combustibles material that we also have outside that you can see by yourself. You can see the visibilities from inside to outside in this non-combustible solution. The fabric is very flexible, so for architectural point of view, it's very it can boost your imaginations into and challenge the designs into using them in a so different application as in this good one in the expo, where around 3.5 kilometers of fabric covered as in a bird's shading elements. We will touch base the fiberglass fabrics. We produce in Serge Ferrari Group, we are the world leader producer of architectural PTFE fabrics. The fabric itself has been used actively since the 60s. The original 30 years design life has already been exceeded by an existing project, so that now you choose a material that has an excellent long life durability exceeding 40 years. The material has an excellent fire resistance, excellent dimensional stabilities, soiling behavior, absolute resistance to the UV, and that is the most important things. Just we touch base quickly here before we finish. Burj Al Arab as a good study, it's standing in right in the heart of Dubai, facing directly the deserts. And you know, with the direct contact of sands, and sandstorms is pretty common in that region, there is the fabric standing absolutely very well after 25 years without having any effect on the surface whatsoever. Yet the fabric is still performing well in reality. Another fabric, transparencies, is very important, but with the new technology we have, please visit us outside here. You will see a fabric that provides 50% light transmission, but yet has an excellent mechanical stabilities, where it allows you actually to go wide in spans. So basically, just finally, we will cover some of the projects here and there. If you go this year to Qatar, just keep your eyes open in all these magnificent projects of stadiums where fabric used in the facade and roof solutions, but also keep your eyes open in Al Jabr Twin Towers, 23 stories building, where all these non-combustibles mesh facade has been utilized. These is our different projects here and there, where basically it's a flexible fabric. You can boost your imagination, and it can be a structural solution to all your second skin structures. Sorry for the time. Time is running up, but you can find me outside in the booth. Come and ask for any questions. We're here actually to answer all your questions and inquiries. Cleaning is absolutely, it can be cleaned easily. It has an excellent self-cleaning properties when we talk about the PTFE fabrics. And these are very good examples how the projects can be maintained and well developed. Of course, we can support you with the system. Come and talk to us as well about the system. So basically, we provide you constructive solutions to enhance the face, to provide a pretty face, basically, a fashionable face, and it is a long-term service. It is a long life that can function and perform. Thank you for your attention. Cheers.
Thank you, Mohammed. So as he mentioned, they have a booth outside like all sponsors. You can ask any questions. You can see the product live at their booth. We're going to take a 20 minutes break. Just two things before the break. We are approved by LAM for 1 CPD point. Those architects wanting to take the LAM approval, there is a form which you need to fill up down at the registration. So if you go to the registration counter, while on your way out, if you fill up the form at the end of the day, you can submit the same and we'll submit it to LAM to credit it to your account. So we'll take a 20 minutes break. Can I just request the 4 speakers of this session to come on stage? Michael, Nicholas, Matthew, and Mohammed on stage. We'll take a small photo opportunity. So we will take a break for 20 minutes. I'll see you back at 11:37. Thank you. Yes. Can I have Joerg from Shuko on stage, please? Photographer is here. Yeah, okay. Just like this. Okay, we'll start with Michael first. Yeah. Michael, Joerg in the center. Give me Nicholas. Nicholas here. Who I have next? Mohammed is here. Ferrari, give me Ferrari. No, he's not there. Mathieu. You want to call Mathieu at the Vector Foil Tech booth? Give them the box, huh? Yeah. They can just There's a box.
Yeah, I will have it in the box. But
Timothy, are you around? Yeah. You want to test it once? Huh? No, Matthew is here. Yeah, next. Yeah.
Excuse me. Can I use my latest file? Is it possible? I sent it to email.
You just want to check the file, right?
Can I use my latest email? I just need it.
What happened?
Presentation? Yeah.
Okay, just download it and give it in the USB stick.
No, I just email it.
When did you email? Now?
A few minutes ago.
Few minutes ago. Did you email it to me also?
Yeah, but it's smaller. The other ones were always that's whole.
Thank you so much.
So, firstly, I would like to take this opportunity to thank the organizer, Zak Façades, that giving me opportunity to speak in front of everyone. Before starting the presentation, I would like to introduce myself. My name is Timothy, and I'm from Manhat Façade. I've been with Manhat for the last 16 years. So, and Manhat Façade is part of Manhat Group, and this is our sum of portfolio, mainly high-rise building. And in here is our portfolio from Manhat Façade, where we involve not only in high-rise, but also low-rise, and special iconic project, something like museum, airport, resort, and so on. Since couple weeks ago, we are experiencing very extremely hot weather, and there were heat waves in all over the world. This heat wave easily generate the fire incident, which was happened in many parts of Europe. And many cities in Europe and US recorded the highest temperature that ever happened in their history. This phenomenon not only happened in Europe, but also in our region. The Straits Times of Singapore recorded that Singapore can expect frequent heat waves in the coming years. And also the Star reported that it's going to be scorcher in KL till August. So the earth become warmer and means that the energy to maintain the comfort level of the tenants or building user will be higher. In this graphic show actually the energy consumption for the building, which is including the property and construction industry, is up to 36%, while the emission contribution is up to 37%, which is higher than other trades, something like a transportation or industry. So according to the world economy, green building is not just idea, and reducing a carbon output of the building and construction is essential if we are going to meet the Paris Agreement. So the question for us is, what can we do? As a facade stakeholder, this is also a question for us. So today what I'm going to explore is what, in terms of facade, is what we can do in the future. So our topic today will be the facade of the future. It's very interesting picture. I was requested by my daughter to accompany her to watch this movie, Doctor Strange. So one thing that struck me in this movie, there is an episode that they went to multiverse dimension, multiverse world, which is something that probably something like a vision. So what I found, this image is very interesting, that I was imagining that this could be the future of the facade. What is the future of facade? Is the integration of the landscape to the future, to the facade. So the facade, I'm imagining that the facade of the future will be predominantly more green facade, will be more greenery implemented in the facade. The last decades, green roof and green facade are steadily gaining importance and increasingly being widely applied. And the importance and application of green facade will continue to rise as the architects are designing the building by keeping the focus not only on the sustainable energy, but also habitability. This is one of the examples. The project in Europe now is the largest green facade project designed by Inghofen Architect, located in Düsseldorf, Germany. Another example is very successful example. This one have been built many years back, Park Royal in Singapore, and designed by Woha Architect from Singapore. This project was awarded Green Mark Platinum by 2012 and win a lot of awarded, something like a leading city hotel, leading green city hotel, thanks to the abundant greenery to the project, especially to the facade. This building is very good sample how they deal with the tropical climate. If you see in here, the floor above the swimming pool was lift up, so to provide a very high ceiling, so there is no hindrance for the wind to flow in to the swimming pool area. Another successful story is this project. We just completed this project during the pandemic. The Eden Singapore is the last development from Swire property from Hong Kong. In here, they designed by Heatherwick Studio from London, and in here you can see they have a hanging garden on every single floor. This image is the image from inside to the outside, with a full height sliding door and folding door. It's given the outdoor experience from the inside. I took this picture when it's just completed, so it's still very relatively very new. The large operable panel, either window or door, will be increasingly used in the future as well, especially after this pandemic. And this is a very common recently, and many clients, they request to have very large window and doors. In Malaysia, especially Kuala Lumpur, there are many successful stories for the building. One example is this building. And for me, Malaysia could be the pioneer in the green wall, and a lot of architects, and certainly led by Dr. Ken Young. This is the one project that designed by Dr. Ken Young, which we were involved in this project. So integrating landscape to the facade is quite simply building the wall that partially cover or completely covered by the landscape, which is grown from the soil or any organic medium. And there are few ways that we can see here. Grow from the ground, we call it ground-based system, or facade-bound system, or could be mixed. The second characteristic in the future is probably BIPV integration. This one is, we know about solar cell, probably. And the integration of solar energy technology in the building has been available for several decades, probably 20, 25 years back. And however, many buildings up to now still been done without any photovoltaic. As shown in this image, photovoltaic was effective negatively in the aesthetic. If you can see, this one is long time ago. Photo cell is dark, looks ugly, but thanks to the major research for the last decade, we can have a huge improvement in the photovoltaic in terms of the solar collection, energy efficiency, and on the other hand, the cost also dropping down significantly. One example is this building. This one is done by in South Korea, owned by Federation of Korean Industry, 50-story building. If you can see this one, the building unique skin help reduce internal heating and cooling load and collect energy through integrated photovoltaic panel. And they install the photovoltaic panel on the spandrel, on the two elevation, which is southeast and southwest. It's not on every single elevation is suitable for installation of solar cell. The design also allow the panel to be replaced as new technology can take advantage become available. You can see here, by angling the spandrel panels 30 degrees towards the sun, the amount of energy collected by photovoltaics will be maximized. And if you see the vision panel are angled 15 degrees toward the ground, so minimize the amount of direct sunlight and the glare as well. And the result is a unique folded exterior texture that both purposeful and visually distinctive. The benefit is reducing the glare and maximizing the highlight of indirect light. So this one, what we can see is there are three aims that have been successfully achieved. First is maximum access to the view, energy efficient strategy, and the last, energy generation technology. This building also features an expansive roof atrium garden that also have a custom photovoltaic. and ultimately produce more solar energy for the building. In Singapore, close to the Changi Airport, Tampines Grand comprises of 33,000 square meter commercial and office space, and Manha Façade was involved in this project. And we did designing, including the involvement or interfacing between solar cell and facade, roof, and the skylight. This Tampines Grand awarded BCA Grand Mark Platinum in 2008, and also could be the first project get award from LEED Gold Award in 2010. This building have a solar photovoltaic, and they can produce 110 kilowatt power and 6 kilowatt power from the roof and the facade. So the total energy that can be produced is 107. This could be our study case. Recently we were involved in this project, and currently it's under design. Sinarmas Tower, owned by Sinarmas Mining in Jakarta, designed by local architect Anggara Architect Team. And the client has intention to have innovative design in the project, especially in the facade. So hence they decided to have BIPV integration on the facade. The BIPV normally installed on the roof, but for this one it's not able to install the roof because the roof is very, very packed. There is no more space on the roof. So end up we have to install in the glass. So there are two options. First, we install in the spandrel at the typical area, and second, for the entire facade crown. In here, we did study together with AGC, which is later Marcus will do a presentation, and with China Southern Glass as well. So the first study that we did is we are conducting the area study because we have a very limited area, so we need to understand the extent of BIPV panel. In here, we can find that we can manage to have 6,800 square meter BIPV panel. The second that we have to study is the shadow analysis. This is very essential, particularly for the building in the city or the dense building area. The shadow from other building will be having impact on the efficiency for the BIPV. If you see, the red one is Sinarmas Tower, and the other one is a nearby building. So Sinarmas Tower is something like a baby surrounding by giant building actually. The third, what we do is we did irradiance analysis to understand the energy received from the sun over the certain area. In this study, we need to understand the applicability of the BIPV. Next, we study power generation analysis for every single area. In here, we can show you the study from level 3 to level 24 mezzanine. And in this slide is the study for the crown area. So for this, the last is investment analysis. This is study done by AGC to ensure that this project is feasible, because as the client, certainly they require a dollar and cents feasibility study. So for this project, the total power is 750 to 800 kilowatt pascal. If you compare to Tampines Grand, this one is 7 times more, because this one they use the recent technology. And by this one, they're reducing carbon dioxide emission more than 300 tons per year. This is equivalent to 7,000 trees and reducing many chemical output as well. So the last, probably, the characteristic of the facade in the future is now getting more using recycled facade material. Just last month, I was contacted by one of our architect friend in Singapore. They want to have this kind of solution for their competition. So yeah, we have some ideas, so we discuss. So this show the demand that recycled facade material is growing up. In here, probably one of the extreme example. One example in Czech Republic, the building is owned by furniture, and if you can see, they use unused chair as a sun shading. It's a very extreme example. I don't think this one can be used for the high-rise building, certainly. But I went to Bali, and I found in this building, Potato Head, Bali. If you never been to Bali, you should go there, probably. So the facade is very interesting. They use a natural material, but that most interesting for me is not the facade, but this sun shading. It's very unique. And I did research, I double checked with them, and I found that this one is made of plastic, actually. And the plastic come from garbage. So they found this one come from the garbage. And now I'm getting to know the producer, the fabricator. They have to do a lot of things before this one. Very interesting. But when we come, this one have not been produced massively. If you want to produce massively, there is opportunity, but we need to have a deeper research and development. Okay, so I hope that our presentation will provide the idea for you, and yeah, we don't be afraid to go for the less travel work. Thank you.
Thank you, Timothy. I think earlier days BIPV was used more because of subsidiaries and because of a norm, and it was less frequently used because it people felt it was ugly, there were not too many options. But today you'll hear from AGC later on what are the solutions they have for BIPV. And BIPV has gone beyond your photovoltaic cells. It comes in different colors and patterns and prints. They also have some very nice samples out at their booth, AGC, but you'll also be hearing from them in a presentation. And as Michael said in the morning, energy security. Every country is now looking for energy security. I think going forward, developers will also look at energy security for their buildings, and then integrating BIPV in buildings, which was earlier a fashion or probably a trend for green building or for your green star ratings or for your green building ratings. I think now will become more from an energy security point of view as you go forward. Technologies are advancing in BIPV. Players like AGC are really working hard on the same, and I'm sure going forward it's going to be a must of a solution, at least in spandrel areas and few other applications. There are also innovations in BIPV where you have a clear vision BIPV also. I'm sure these will also come into play in the future soon. Okay, moving next is interesting twist we have to this event. So we've got architects, consultants speaking. Now we have an investor talking. Nicholas spoke about the Hemen House tower earlier this morning, and we have the developer investor of this property, of this tower, Mr. Frankie Wong from Forebase Property. He's going to be talking about what this tower is about, what was his vision for this tower, what is the current solution they have on the facade, and his future plans. So I'd like to call upon Mr. Frankie Wong from Forebase Property. He's going to be talking about a quick short presentation on the Hemen House tower facade. So Mr. Frankie Wong.
Okay, good afternoon, everyone. I'm honored being invited here talking a little bit about my project, the facade to be exact. First of all, I'm not an architect or I'm not an engineer. I'm an investor and developer, and I'm going to present something from the user perspective about the facade. Okay, I'm from Hong Kong. I guess everyone knows how competitive in Hong Kong. When we're doing work in Hong Kong, when we doing anything in Hong Kong are also very competitive. Back to the, when we doing the design of this building, we are thinking how we can make this project something unique and special. Instead, since in KL City Center, there are lots of big building there, lots of landmark building. Our project is not tall, it's 170 meters nowadays, only a normal one, and our site is very tight, and not much we can do. So we're thinking something new and special in when we're doing this project. Okay, how we can make ourselves special for the, from the design point of view? Of course, we can do some very, to spend the budget to hire some very established, very famous ID, or to equip with some European or some good home appliances. But all these will go, say, 5 years or 10 years later, then people or the user may not be suitable for them, they will change. But one component is very, will go with the building, lasting forever. Then we will think about how to do it and make it special. This question goes to the another levels of discussion. How we do this with some good design, good for the environment, and the most important is the user and the buyers may enjoy longer than maybe not 5 years, 10 years, perhaps as long as the building exists, this component is still with them. So we think about this. Of course, we also have to think when the buyer or the user, when they consider to buy a project or property in KL, what will be the most important one? The location, of course, everybody knows. What other than the location, the people will think is important to them? As you see the photo here, is a drone photo that I took it myself back to a few years ago, that you see a lot of taller building, a special building, and then we come with the idea to use the best material. As long as I know, I'm not sure if there's any better one in the market, but we think this material can come with our building to make this building a very special and unique. Okay, so let me introduce a bit the project. This is our project. Actually, it's my first project in KL. My partner and I really like this city. We have some projects in Hong Kong, but we do the first project in KL. It's a 90 units or a dual key units. Come with the some parking lot. This parking lot, we also think of some special. All parking lots are equipped with all the EV chargers. I think back to the few years ago, that will be the first project in KL. All the parking lots are already EV chargers ready. So whenever you guys have an EV up from here to now or to next year, then you come to our project to do a charge easily, whether visitor parking or the public area parking. And we also think about how to make this project very unique. Okay, all these are some brief introduce of the project. But I guess the point, okay, back to this one. Go back down, okay. Okay, when I choose the facade material, I purposely fly to Germany to take a look of this factory and see how they making the material, how do they do the fabrications and all these works. So I know more about the products and how this product can deliver to our buyers and to enhance our project to make it more unique and stand out from the others. So back to this project. Our project is small, not a big one, but definitely we'll do it as a very unique and a boutique, beautiful one to make sure the facade together with our design concept, interior will be the very unique one. I hope that the next year, by the time it completed, every one of you can come to take a look and give us some comments and give us some feedbacks, and hopefully the next project can be do a much more better. Okay, as the topic is a facade, I think I'm not, as I mentioned, I'm not a professional or engineer to talk about more about the specifications and all the details and everything. So I would like to just give you some introduction from the developer or from the investor point of view, how we look the building. Is the overall facade is very important. So that's why we choose this high quality facade, good glass material to make it more look durable and can last for longer. So I'm looking forward to seeing more and more beautiful, unique and high quality facade in the KL city center. So that's about all I'm going to share with all of you. So perhaps I pass the time to the next speaker that can further elaborate more about the facade detail and share with all you. Thank you very much.
Thank you, Frankie. So I think the first time we met Frankie was when he visited our event in Hong Kong in 2018. Shuko were partners for that event over there. So this is something which Shuko should be extremely proud. You have a high-rise building with a Shuko curtain wall in Malaysia. So obviously Shuko stands for a particular quality, a standard, and I hope this will set a benchmark for Shuko for more projects here in the Malaysian region. So last few years was all about COVID, and one thing in COVID, apart from washing hands and wearing a mask, was opening your windows. So you need to ventilate. Now, how do you ventilate curtain wall? I think Joerg Schleusener, who's the pre-construction director at Shuko Southeast Asia, will talk to us about some clever ways of ventilating curtain wall facades and what Shuko has an offer and solutions for the same. So Joerg, over to you.
Thank you, Ahmed. Hello. Yep. Yeah, welcome also from my side, from Shuko's side. Good to be back and good to see so many people from our industry. Really great. Thank you for that. And actually, I'm with Shuko 4 years now, more than 4 years, and my first day on the 1st of August 2018 was the last ZAC in KL. So yeah, back to the roots. Yeah, now I think we are catching up. So Frankie was quicker, and I think I can also make it quicker so everybody can go for lunch earlier. I just want to give you a brief overview about what is possible in the facade, how to open with different kind of systems as a general overview, and what are the little, not problems, but issues we need to solve when doing that in terms of what we experienced in the last years. And is it that coming? Yeah, good. All right, so ventilation, big point. Of course, the classic one, the traditional one is the window. I will shortly explain or give you an overview. Swing doors is usually not considered as a ventilation, so that's just entrance doors. So I'm looking at sliding doors a little bit, how we can integrate this into a unitized or a stick system. Also then looking into fully integrated systems into the facade. There's several varieties. I'm just looking at one or two. And then, of course, which is also done in the Hammond House project with some automated systems. Basically a window with a motor to open, give natural ventilation, or also then more safety issues as a smoke vent when it needs to be then controlled or integrated into building maintenance. Okay, here we go. So, I mean, everybody knows the classic window system is not rocket science. So you have basically an outer frame and then the vent frame, and it's open as a top hung or a side hung or even a bottom hung window. So different possibilities, but also now in the terms of all the looking ahead, climate change and how to save energies and everything, we also think, I mean, thermal broken systems are also kind of a trend in the future. So everybody knows windows as a punched windows, as a classic ribbon windows or single windows and different things. So just the technical overview about the things, how to create a window, how to place it, and where are the classic one, gaskets and all the water tightness, air tightness features. So looking into a facade, we basically have two curtain wall system, main curtain wall system. One is the stick system and one is the unitized system. So a stick system is pretty straightforward because we can integrate it in front of it with the clamping into the, fixing it, holding the window and also fixing it by mechanical screws into the pressure cap and everything. So in terms of water and air tightness, no issues. You can have the gaskets running all around the windows like there's a glass or anything. So you can also integrate then a balcony glass, a balustrade glass in the front of it to achieve all the safety features and requirements, falling as a barrier if you open the window, if it's a full-sized window. That's basically then the detail for it. You have the mullion as a structure, the framing, and then clamp it and fix it into the mullion area. And then in front of it, you have the balcony glass, which is not full height, it's then just the balustrade up to what is the usual 1.1, 1.2 meters above. Oops, what did I press now? Yeah, okay, sorry. Good, so this is pretty straightforward, not a big deal. It's getting a little bit more tricky in a unitized system because we don't have these front part or the glass, the window is usually or sometimes located in a bit of a different area, and then also most of the time here in Southeast Asia you get these structural glaze system without capping, so you have to do a little bit more detailed work about how to fix it and how to integrate it without losing the air and water tightness, and then also giving the structure to the mullions and everything. So this is pretty much a standard solution, which actually was also used a similar system in the Hammond House in several areas. So this is, for example, a possible solution for a top hung window, opening outwards. With the whole hardware, and it's also really neat and nice integrated into the facade. This is basically the detail. What I would like to see, and this is also the experience, what we have is the interface part basically between the window frame and the mullion, which is really not a critical item, but we need to really look at the detail and also the workmanship later in the factory by the fabricator to make this properly and not losing any air or water tightness, because that's kind of a critical point on the window system. So these are more examples from the Hammond House, actually, from the project. So you get a bottom detail, the details. And I think, that's basically it for the windows. So I would like to switch to the topic with the sliding doors. Sliding doors is always a bit the tricky thing, how to integrate into a facade, because they have the track. So you're rolling the sliding vent from one side to the other, and you have to integrating it into the facade system is always a matter of to find the space and the room for it. So there are two possibilities. Either you put it totally in the back of the facade, so then it's all independent to the facade, but this means you're also losing room, and it's not, from a design and visual point of view, it's a bit, not so neat. So that's the classical sliding door panorama with a slim profile. So what we did is for a Thai project in Bangkok, we had the challenge, let's say, we have standing alone individual sliders, which is on the left side with the balcony. So the facade basically stopped. You got the niche with the balcony, and then in the back is the slider. And we try to, to introduce the same system because of the look and everything, don't be different, into the facade, which is then on the right side, or in the middle and the center side. And the challenge is then also to have one slider basically sliding behind the mullion, and then to guarantee the air and water tightness here. That was also a kind of a challenge, let's say. But we solved it, and I think it's a pretty neat design, and also with the balcony in front of it. So if you open it, you have the barrier. Nobody's falling out or anything. Then we come into the integrated system. It's really fully integrated system. We have several, there's several possibilities in the world, but what I like to show is we call it Ventolife, which is a fully integrated ventilation system, and also with, best is, I'll just start the video, which is hopefully coming. No, yes, it's coming. So in all these times with all the pollution and bad airs and everything, we came up with a solution to integrate. I mean, this is now a window system, but you can also integrate it in a sticker or unitized system. So this is a fully integrated system. A box basically can span the whole height, integrating all the filter systems and intake and exhaust and everything. So you have a whole floating, ventilating system which can be integrated. And this is now sticking out because the facade system is quite small, but if you put this into a unitized or a stick system, it's really flush with outside, inside, and it's really hard to see if you integrate it or combine it with some other features in the facade, which is pretty neat. We also looked at, of course, into the automation of a window. Basically, if it cannot be accessed manually, so you have to make it automated, or you integrate it into the building system as a natural ventilation, but also then a smoke vent. We came up with some ideas. The little information, let's put it this way, for all the developers and architects, especially the architects, if you have these automated system, and if you have the requirement to integrate the motors and all the electronic parts and everything, you need to allow a certain size of the profiles and the vent frames. So we cannot put this into very tiny profiles. So this might, I mean, this is the downside a little bit. So you can see on the right the vent frame, and then also the vent itself is quite deeper, quite more bulky, let's say. But yeah, you can't have with both, basically. That's basically it from our side. I mean, there are other different variations of windows and doors. I just want to give you a first heads up on everything. I mean, we are outside on the booth, and if you have any more questions, you can always ask us. I mean, just to summarize it, I mean, what our experience and what we need to be really careful is on the interfaces between the windows and the facade. When you do the ventilation system, we always recommend to include, especially in the windows, then a kind of restrictor or limited stay. That's a kind of safety issue. I know it's always extra cost, and sometimes people doesn't see the need of it or anything, but we really highly recommend that. And one little comment at the back on the automation system, if you have any smoke vents, we have the experience of, it's always also together with the consultants always, we need to have a certified, tested system for smoke vents, because I mean, it's not maybe the most essential, important feature then in a facade, but it's important to guarantee safe escape routes in a building when there's a fire and smoke, and get the people out. So it has to be really a certified and a tested system, not taking bits and parts together. This is really, really important in our point of view. That's basically it. And I want to thank you for your attention. And like I said, any more questions, please let us know.
Thank you, Joerg. So ventilation is going to be key as we progress going forward. One of the key design strategies to consider in designing a glass curtain wall. Okay, moving on to our next speaker. So it's our keynote presentation, international keynote. I don't know how many of you were present at the 2018 event. So we had 3 towers last time being discussed. We had the Oxley Tower and the Star Residences by Madame Lilian T of Veritas, and we had the KL118 by Nikki Drobis of Fender Castellitis. So this time we have something special for you. We have Mr. Mustafa Chehabeddine. He's a design principal in the London office of Cohn Pedersen Fox, otherwise known as KPF. He's going to be talking about the podium design of the Lot M project at KLCC, and also an insight on a super high-rise tower which should hopefully come up in the next few years, adding to the beautiful skyline of Kuala Lumpur. So Mr. Mustafa Chehabeddine from KPF London.
Thank you, everyone. I'll try to be quick because I'm between you and lunch, so. You have time? You're not ready with the food yet? Okay. So this is a very interesting project for us. It's the last big site in the KLCC precinct, and we've been working on it for a few years, so I thought it'd be good to kind of present it to you so you can have an idea about what we're doing. We are building a podium at the moment. It's under construction, and the building is basically an interface between an infrastructural project, which is the MRT station going adjacent to the site, and the park on the other side. So you're between two interesting infrastructural projects. One is about leisure, and one is about kind of function efficiency and also green energy, because as you get a better transportation system, use less cars, and it's more efficient. But the building had to exist because it had to be built before the MRT station is built, or at the same time, because of issues of disrupting an active rail. We've looked at ways of building a kind of a project that kind of takes a little bit of the context into its forming, but also that focuses on an element that's really important on this site, which is a cultural element. The front of the building is a gallery space that sits over a public land, and it has to cantilever over that public land. So the building have a very big cantilever built into it. It's around 60 meters. And so that cantilever is part of the logic of the building. So the concept was to almost create this series of ribbons that hold the building back and kind of tie it back in place. And that kind of brings into mind the idea of weaving and the kind of local craft. So we've done it in a way that you have these big ribbons, and also in a way that allows a series of public spaces to exist. As it is next to the park, a big terrace will exist on top of this this podium that allows a really nice viewing point for the Petronas Tower. But also we wanted to make sure that the building is really well crafted, and so we've articulated the facade in a way which we're going to show in a bit. But as you can see, the shadow that you see inside the building are these, see if you can use this, are these, the big truss that ties the building back to the lower level. And also you see some of the interfaces with the MRT with these big vents element that come out, that we had to kind of make sure they look like they're part of the building. Effectively, the building is a retail center with a cultural element in it. And what you see here is the plan of the building with entrances coming from all sides. So it was designed to almost feel like an extension of whatever is around it. So you enter it from many points. Doesn't have one main door. And what you see also in these big dark colors are the structure for the future tower that's going to come in down the line in the future. When you look at how the big structure was integrated, and that was really the big challenge. One of the challenges of this project was how do you cantilever an amount that is equal to all the land that's kind of outside the site, around 60 meters back to the front point, but also still create a big space that's good for gallery function. So the structure has to be kind of laid out in a certain way that allows that function to happen. So this is a view from the park, looking at the building, and you kind of seeing that the trusses, but you're also started to see the articulation of these ribbons. The front door of the building is on the lower level, and the interface with the station was kind of the triggering point of this project. But it also is kind of almost like a lifeline for this project, because that integration with the MRT entrances, some of them are actually flowing directly into the project, so that gives you the footfall that you need, but also links the MRT to Petronas and beyond all the buildings around it through some of these links on the lower level. So that is kind of a way of making this building really work in terms of a retail function. This just shows you some of the complication we had to deal with the big infrastructure next to the building. It had to be built at the same time, but it has to be also designed at the same time, because we had to pull some of the element of the MRT into the building, like entrances, exits, fire exits is a big thing. Long discussions about who closes first, what happens if the MRT is 24 hours, what happens if the building is 24 hours. So that all was integrated into the logic of the building. And this is just to explain that the site, which is made out of 3 lots, L, M, and N, is also a site for future towers. And if you look at around the KLCC precinct, the big lands are all gone. And there is an amount of area that's still available for the client. And so the idea was to create a building that allows in the future for a tower to exist. The future could be 5 years, could be 10 years, nobody knows, but it reserves the amount of area that's allowed around the precinct to exist in this building, and it end up with being a tower that could be high, or it could be higher or lower, but it's preserving that tower. And the idea of the tower was to create this series of petals that form a unified whole, slightly kind of twisting as it goes up. And to create a facade that's really green, that has enough shading in it, that reacts to the orientation that's in it. So some facade will be more solid than other, depending on the sun orientation. But like I said, this tower is a future element. It's not what we're talking about today. However, to preserve the ability to build a tower like that, you actually had to integrate an element of infrastructure into the building that allows this tower to come up in the future. So as we're building the podium, the core and the foundation and the columns of part of the tower will be built from day one. And those are some of these just examples of the piles that have been put on site over the last few years. So during COVID, the site was really active, and those elements have been built. As you can see in these images, obviously a big foundation for a big tower. At the podium itself is starting to come out of the ground. You probably can see it if you're driving around the site. The location of the tower on top of the podium in day one now is going to be this public space, the big terrace on top. That's part of kind of the idea of dragging people up through the mall, but also the gallery space is a big drag. As you noticed, KL doesn't have a lot of cultural elements, so that hopefully fills in a gap that's there in the city. The geometry of the building looks complicated, but we try to rationalize as much as possible. So first of all, it's a mirrored building. So in terms of setting out, the geometry is kind of two-sided. And then it's divided into these kind of few steps that deals with kind of the ribbon, the underside of the cantilever, which is over a public space, so it's also seen from below, and then it sets out kind of a series of other elements that makes up the rest of the building. And then we try to really rationalize the geometry, but also figure out how do you pass on information like this to the contractor to build something complicated like that. So complex geometry always kind of defies the the tradition of having to describe the building by having few sections and few plans. So what this is showing is kind of a series of coordinates. You can probably not see them, but a series of coordinates that's in space that allows you to connect the dots and start to draw the different element of the building. So just a way of being able to recreate this model by the contractors. And the facade itself then, since this is a facade conference, so we thought we focus a little bit on the facade. So the facade itself is divided into a number of facade types. We couldn't kind of come up with a simple unitized system, but what we've done is a semi-unitized system where you have an element of the facade be almost like a stick system and then a unitized system that then gets added to that. So it's a combination of things that allows it to happen. And some of these elevations shows what we're talking about in terms of the what you see here. These bands are these ribbons. Under them is the ground floor, which is the retail floor. Then you have the triangular facade on top, and then the second ribbon on top of that. And each one of those is a facade type, but they still follow the same logic, same module of what's happening below them. So they're using the same grid, and they're kind of the panel and the materials as we're developing them now are also borrowing from each other. So the same metal is used when we're able to do that. Obviously, a building like that will have a lot of technical requirement, and what we try to do is to hide as much as possible those requirements within the same language of the building. So some of these louvers that exist on top of that building are also designed to be part of these triangles that kind of wrap the top part of the facade, and that's what you see here in these elevations. We've also tried to deal with orientation by having frit on the facade, but also hide again element of infrastructure or element of technical areas like louvers here and the kind of mechanical rooms here, by creating this frit pattern that runs around the building, and it kind of densifies where we don't want to see through and opens up where you want to see through. So when you look at the gallery space here, the frit kind of makes way, and this is the corner of the building that overlooks the park, and then you have solid frit here, and then as you go to the orientation where the sun kind of hits the building, you add more frit here. And what you see on those elevations are this kind of frit unfolded to kind of unwrapped to show you what's happening around the building. And then we've also tried to integrate structure and facade in here, and what you're seeing are these vertical elements, and depending on some of them span double height spaces, because as the building kind of matures in the future, if the tower is built when it's built, some of the ground floor will become double height spaces. So some of those mullions had to go 2-floor high from day one to allow for ease of construction in the future. And we've developed this series of a language of mullions. Some of them are supported by steel elements like the one you see below, and some of them are wrapped in aluminium. We've also worked really hard on rationalizing the panels to make sure there is enough repetition, but also that the amount of twisting in the panel is reduced. And so when you look at this, the kind of brood geometry of the building will have around 39% flat panels as we rationalized. And by rationalizing, we've kind of played around with the gaps between the panels to allow the gaps to be a bit more flexible. So instead of insisting on, a millimeter tolerance, we made it 3 or 4 or 5 millimeter and allow the gap to vary, and that gives us double the amount of flatness in the panel. So that's a way of making the building more efficient and the construction easier. And you're seeing that here in this other view where the amount of double twist and single twisting, double curving and single curving panel shows. But also as we started to, as the construction started, we were also facing the reality of maybe the panel sizes and some of the elements that we thought we can get away with having bigger panel. We had to reduce the sizes, and by using the technology that we have, the computational technology, we've managed to almost re-panelize the whole building. To kind of stick to the right dimensions for the panel, especially the double curve panel, because those have a lot more restrictions in terms of how big some of the panels could go. And what you see here is a study that we did to convert most of the double curve panels to single curve panel from above to below, and we did that by reducing the size, but also allowing a little bit of tolerance in terms of how much the panel can kind of be proud of the adjacent panel. These are some of the images of the site. This is quite an old photo. It's a bit more developed now, but the kind of northern part of the site is built, and it's a top-down construction, so stuff is happening below ground at the same time as above ground. So while it looks that it is taking time to build, it's actually the fact that the basement is building at the same time. This is an image, and again, these are a few months old, so it's a bit more developed now, but that's in northern part of the site. You're seeing here the hall is that core we discussed for the future tower, and the cantilever element, which will cantilever over this road, is still not seen here. One really important component in building complicated buildings is to actually do these visual mock-ups, a series of facades that facade component that gets built so people can check, and it's always been done, but it's been done usually at a size that's equal to a panel or two panels. But what we've done here to make sure that the contractor get enough experience before he actually tested it on site is we have a comprehensive amount of mock-ups that we've asked for during the design, and it was part of the tender. And so these are, I think we have around 16 of them, and these are some of them here. You see building a component that sometimes are even 3 or 4 story high. And these are images of those mock-up as they are being prepared on an off-site, similar in KL and similar orientation, so you get the effect, but obviously they need a space for those to happen, and this is kind of just a view of the progress of these elements. Big panels, big glass panels, curved panels, twisted metal, all of that is really good to test it first before installation. So that's what this is about. Some of the images of the putting the elements together. So these are the first round of visual mock-ups that have been built and reviewed. So any one of those elements will have a number of kind of comments that come from us and from other consultants that then gets picked up and amended before it goes on site. And those are the later ones. Again, just showing you that the amount of information we're getting out of building these, especially with complex geometry building, is really it cannot be underestimated. Just because as you learn, you're actually adapting your factories, your processing line to what the building needs, and by the time these elements get to the site, hopefully the enough knowledge have been built to get it right day one. This is separate from the performance mock-ups, obviously, that are done for performance purposes. Those are some more images of these, and I think there is a quick video here that just shows those. I mean, this is a bit more recent, it's a couple of months old. They still have built a few more of those. But as you can see, all the different facade types are coming together, and that knowledge is building up. Clearly, it's working, because as more mock-up are built, the later ones are looking much better than the earlier ones. And that includes, obviously, doors and ceilings and facades, but also roofs, like you see with this one here. So this is hopefully what the building would look like in the future. You're looking at the entrance there, which in the future could turn into the entrance of the tower when it's built. But for now, that will be one of the main entrances into the retail center. Thank you very much.
Thank you, Mustafa, for that excellent presentation. So hopefully we should have another super tall tower in the skies of Kuala Lumpur if all goes well. Okay, next we have a panel discussion. Just going to take a couple of minutes to get the arrangement done. Just repeating what I said earlier. So this conference is approved by LAM for one CPD point. Those architects willing to claim that point can fill up a form which is available at the registration counter below where you entered. You can fill up the form when you're leaving, and we'll have that submitted to LAM to get the points credited. I'd like to thank our event partners. Again, as I mentioned, it's a 2-year delayed event due to the pandemic, so they've been extremely patient, supportive of the delay, and they're here to meet all of you, so please do drop by their booths during the networking breaks. You never know, your next project might be a solution from them, or you're already working with them, so it's just good to say hello. Post the lunch, we have a couple of other interesting topics. So all this from the morning has been on future of facades, it's been on sustainability, embodied carbon. I think another crucial factor is fire safety in facades. We've got a couple of very interesting presentations. Malaysia has recently updated their fire code, so you have that and a little bit more in the next 2 sessions. I think we're almost ready for the panel discussion, so I'd like to call upon the panelists on stage one by one, starting with Ms. Sitinor Susanna Yazid. She's the head of design at NRY Architects. Ms. AJ Azlina Jamaluddin, she's the head of planning, design and sustainability at SP Setia. Mr. Andrew Browning, who's a director at Kirk Australia, is a leading architecture firm based out of Brisbane. Mr. Azril Amir Jafar, who's a director at Veritas Architects. Ms. Shin Lin Kok, who's a partner at Facade Network. And our event and our panel moderator, Mr. Hans Wiesmeis. I hope I got that right. He's the Director of Sustainability at Turner & Townsend. So Hans is going to be moderating this panel discussion on the influence of design in the performance of building envelopes. How can the design impact the parameters of the building envelope? Benefits of passive design strategies, local material procurement, and net zero carbon, and how can this trend be implemented in Malaysia? Over to you, Hans.
Thank you very much. Audience, very welcome. I know that the next session is lunch, so we try to keep it relatively short. Let me start with a brief introduction, and then I'll hand over to the panel later on. Under the Paris Agreement, 192 countries have adopted climate goals and the commitment to reduce global greenhouse emissions to reach a less than 2 degrees increase in temperature compared to pre-industrial levels, with the commitment to work to 1.5 degrees. This would mean that, according to our best science, that we have to reach net zero early in the second half of this century, meaning a transformation of economies and societies. Up to date, 138 countries have committed to net zero pledges, combining for 83% of all greenhouse gas emissions. But yet, a recent report from the United Nations actually told us that we are not on track at all. If we continue this way, we are going to reach 2.7 degrees increase in temperature. And as the world grapples on how to decarbonize societies and economies to really reach these goals, I want to use the expertise of this panel here to really look into how buildings and facades contribute to this. Buildings contribute roughly 38% of CO2 emissions. And here, the focus will be on how facade, how passive design actually can contribute to a better performing building? What materials to use? What challenges that we actually see? How do we put this forward? I'll keep the time relatively short and some opportunity for questions at the end. So do take the opportunity to ask the panelists some questions here. So let me get started with the first question. Susanna, could you share with me first on how and to which extent passive design strategies actually contribute to a high performance building in your experience?
Test. Yeah. If we are talking about this passive design, right? So we are looking at something that we didn't really use the mechanical and all that. So it's passive and it's cost effective. And the way we are orientate the building, and how we strategize the orientation of the building, the positions of the windows and all that. So it will helpful in terms of the to strategize our sustainability of environment, building and energy efficiency to the building itself. So it's, I think, one of the, for example, if we are designing a hotels, the prioritize will be the views. So if we are having a lot of views, and definitely we have a lot of glass, and how we are going to tackle on the efficiencies of the glaring and the heating into the building and all that. So it's going to be difficult at the same time. So, but at the same time, the passive design strategy is also very important to tackle. Okay. Okay, sorry. So the program of the brief of the intended program is very important for us to actually to understand how we design and positions our windows and all that. That's what I meant. And if we are designing, like what I said, is a hotels, then we would want to have some connectivity between the indoor and outdoor as much as possible. So it's going to be a lot of glass and all that. But it's different than if we are designing something like office. Probably it's going to be a daily routine activities. So it's not going to be a view per se, like we have the connectivity between indoor and outdoor so much. But it's more like a comfort levels on the temperatures and acoustic and all that, yeah.
Thank you. Asriel, I know you've worked on a well-known high-performance building, Lamont Picanes, double platinum for both LEED and for GBI. Can you share a bit in your experience on what role the facade and the design has played in really getting this building to that high-performance level?
I think, yeah, first of all, as Azina mentioned, well, the passive design is very important. You know, it is about, oh, sorry, Susanna, sorry, I got your name wrong. Okay, right, yeah, the passive design is very important. First of all, the space planning, how you orientate the spaces. There is the paramount in designing a building, and the facade is, I think, kind of secondary. It gives the identity to the building. And then in Pekinese building, for example, the facade treatment on different orientation is different. That creates certain aesthetic quality of the external look of the building. And then at the same time, we try to relate that to the local cultural element of the look of the place. For example, we use in tackling the glaring issue of the tropical facade. We use the geometric pattern layers outside that relate back to the culture of the place. At the same time, increase the high performance of the building. Building envelope. Yeah, that's Yeah, that's one of the elements there.
Very good, thank you. Andrew, I'm going to ask you a question as an architect, right? I'm using here the framework of the Blue Ocean strategy. Which elements should we, from a design perspective, should we introduce, increase, reduce, or eliminate to really, push that that design forward?
Yeah, good question, and a potentially very long answer there, Hans.
We got some time.
Where do you start? I think from our perspective, the way we approach addressing those issues is a first principles approach. And so what the other panelists have mentioned before about how you think about the building in its place in the greater context in the city, and then also as the building itself, it's what the role of the building is, what its function is, how it performs. It's sort of where you start from and how you think about what you want to achieve there. We always want to push the passive side of the design in attaining those principles. So increasing building resilience so that the materials you use are naturally inherently low maintenance, resilient in that sense. They perform well thermally. They have a low embodied carbon in them, so that the carbon footprint is reduced, the embodied energy is reduced. So starting from that point, you're dealing with orientations of buildings. You're dealing with where you have solid walls, where you have roof overhangs, that type of thing. So that's sort of the real starting point we come from. And understanding the building in its context is very important, I guess. And this might not be answering the question, but sort of elaborating further on what was just mentioned earlier is, understanding the macroclimate and the microclimate is a very important starting point. And there's a building we did in Singapore at NTU, which there was a lot of research done in that, and the whole form of the building was guided by how we can capture the benign breezes in the tropics. So, I mean, everyone here, when you walk around KL, you'll notice, you know where it's comfortable to walk around and where it's not. So if you walk down the old stretch of Jalan Ampang where there's the rain trees and there's shades and it's a certain orientation, it's very pleasant. You turn around the corner and walk up Jalan Sultan Ismail and it's certainly not that pleasant at all. You've got no shade, you're not getting the breezes. So the whole form of that building was driven by computational studies, like technology, that was done by Neapoly, that actually gave us the actual form of the building, the shape of the building, the curve of the building, that allowed us to maximise the benign breezes to, make 30% naturally ventilated floor plate. So we're interested in where we can reduce reliance on mechanical systems, probably coming back to the question, and using the natural climatic, or optimising, pacifying, negating the harshness of the local climatic conditions to get away from mechanical reliance on systems. So, that building also has to deal with wind-driven rain. So it's a very complex fine-grained screening that allows the breeze to pass through but breaks the pressure up enough so that the wind-driven rain doesn't come in. But what it resulted in is 35% of the floor plate, which is common space for people to gather, is naturally ventilated and works, is very comfortable. So probably haven't answered the question too much there, but I guess fundamentally in principles to get there, it's emphasising on how we can optimise passive mechanisms and get away from sort of more complex initiatives and complex technology. In terms of carbon neutrality, finding materials that themselves are carbon neutral or move that way, and you don't have to, go down a complex path to offset that carbon footprint, which you do with many materials.
Thank you, Andrew. You mentioned microclimate, climatic conditions, and then AJ, I know you've worked in different parts of the world.
Yes.
And building on this, can you share with me how the different climatic conditions or the microclimates actually play a role in this and how this gets incorporated in the design as well as the facade?
Well, design, as much as it's very subjective, right? Design, there's no right or wrong. So as much as it is subjective, it is also contextual. So in designing facades, for example, designing something in Kuala Lumpur may be different from designing something in the Middle East. So you have to understand the extreme of the forces, the external forces that will affect the design of the facade. Again, like I mentioned, different parts of the world, you have to understand what factors have to be taken into account. The climate factors, the wind, the sunlight path, the shadowing effect, and everything else. So in a way, from a developer perspective, yeah, we do a lot of design reviews. So we always look, in my line of work, we look for these 4 Ps, I would like to call it 4 Ps, when we review a facade design. So first, it's got to be performance. Over and above everything else, it's got to be performance, right? The functionality of it and as well as the sustainability of it. Second is the price. It's got to be affordable. You know, there's no, I mean, we don't all have deep pockets, even though we are developers, but we don't all have deep pockets. Yeah. So that's got to be a factor to be considered. The third P would be prefabrication. In other words, ease of construction. With you mentioned earlier, right? Construction contributes to what, 38% of GHG. So we must find ways how to reduce these carbon emissions as much as we can. So that's the third P. The last and but not least P is, of course, the post-occupancy. So that's where the ease of maintenance, the durability. You know, when we build buildings, it has to last. I mean, we'd like for it to last a lifetime, right? But typically, it will last about, what, 80, 100 years? Or even longer, that would be best. Yeah, so that's my take on passive design. And
thank you.
There's also the wellness aspect about buildings too, like health and well-being.
Absolutely.
So that's embedded in the UN sustainability. Now it's about the well rating. So the wellness and health of the people that use the buildings.
Yeah, I'd like to refer to, there was one speaker earlier, I think it was Nicholas Ling from Konzepte, on the value of when you design something, you must begin it with the end in mind, right? So when you build buildings, who are going to be the occupiers later on in the building is the human. So you have to have that human factor from the onset. You're building this for human, so they have to feel that they belong, they have to feel safe, they have to feel protected in that whatever, you know, architecture masterpiece that you.
Another thing something just came up into my mind is the building is something that not static. You know, you build and it will grow. You know, it can evolve. For example, the element of landscaping. This is something that you talk about how to reduce the carbon footprint. Don't forget, trees are the good absorber of CO2. This is something that, you know, we should play a lot of emphasis in the landscaping. It relates to your microclimate question as well, because this is very important element and how you integrate the landscaping to the experience, the wellness, and how the building evolve over time as well.
Yep. Thank you. Shinlin, I want to ask you a question as well. We talked about health, well-being, the 4 pillars. In your experience, how has the customer or the developer's experience actually has changed over the years? Where did the priorities came from and where are the priorities now? What are they looking at and how does that actually change over the years and where do you see this going in the near future?
Yeah, let's compare pre-pandemic and post-pandemic. And we will say that post-pandemic, we have a lot of constraints, for example, like material, shortage of material, the height of construction material prices, the labels, and so forth have created a lot of issues to the construction industry and the building industry. And I also can say that it actually sway away the priority as for now with, like AJ has mentioned about the pillar, the performance, of course, the price, and so forth. I would say that the leadership, the governance, and the capitals, they are very important in moving forward in the sustainability way. For example, now I think most of the developers are worried about the return of investment most of the time, whether it can sell, what kind of market to it. But most of the time, like how to strike a balance between the profitability and sustainability. Yeah, maybe AJ can share with us some of your thoughts.
Well, it's really a big issue for us because somebody has got to pay, right? All this sustainability, all this innovation that comes with it. I would say that, yeah, we always have to strike that balance. It's a call that we will have to make, whether is it sustainability we're after or is it price. But at the end of the day, I believe it should be a collective effort in a way. We can't have the best of everything. Something's got to give. So yeah, it's always that balance of profitability and sustainability. So something has got to give, something has got to be compromised. Yeah.
Let me interrupt a little bit here, right? So I of course understand there must be a balance between things. But in my opening remark, I basically said, look, we are far behind the greenhouse gas emissions.
Mm-hmm.
And we are not hitting the targets that we are committed to. Yet we are still striking a balance about profit and sustainability. Looking for that balance, well, actually, the balance is not even there.
Yeah.
How do we convince developers, people to really, adjust that balance? Anybody who wants to answer?
Coming from the Australian experience and probably from Europe, a lot of it comes out of legislation, so it has to have a strong will and drive power to do it. But I think stepping outside of that, it's got to really come from first principles. So you can't take a type of development that's thought of in the status quo and think you're going to be able to make that a carbon neutral building or a sustainable building without it being a very expensive process. So, if you're going to do an office tower that's got a 1,500 square metre floor plate, you're not going to get natural light into the core. So all those sort of passive things that you think about, what helps a building, its materiality, its natural light, natural ventilation, its construction. So it's so how do you deal with all of those things from first principles? So. It is a collective experience because the developer has to be on board about scale of building. So not necessarily thinking about I'm going to build the biggest thing because that's going to give me my biggest yield and outcome, because that in itself makes it difficult to embed sustainability into the project. And just being bold, like adopting construction. I mean, there's getting away from standard construction. Methodology, new materials
I think probably it is about the whole industry-wide. It has to be, holistically. It is about ecosystem of the industry. That's something that you cannot just one party pushing for the agenda and try to think change will happen. But it is about the whole collective, as you said. Effort by the whole industry. For example, when GBI was started in 2009, I mean the building material to be certified green building material was not readily available. But when there's some take up over the years, I think you have more options and the price comes down and you achieve the balance as what the developers want to have.
Everyone is looking at the affordable alternative.
Yep.
Way.
Economy. At the end of the day, it's about economy, part of it.
Well, it's always when it's something novel, something that is just starting out, it will take time. right? Because the perception, the acceptance level, it will take time to happen. So I think we are already moving in that direction, but how long it will take, you know.
I think maybe waste reduction is also a sustainable approach. Yeah, once you standardize the thing and you have the system, even the opening size according to the stock size, probably that way we can reduce some waste. I understand that like Michael has talked about the recyclable, aluminium is recyclable, glass is recyclable, but it consumes energy to recycle as well.
Sure.
So if we can optimize the material, then we reduce the waste. Yeah, from there we can go towards sustainability.
Yeah, so it's a total ecosystem. It's not just one, you know, one segment of construction or property. It has to be a collective effort.
Correct. It must be a combined
Everybody
effort.
must be on the same page. Yeah, that we're trying to save the planet, right?
I recently read that every 2 minutes, the energy reaching the Earth from the sun is the equivalent of the whole annual energy equivalent by humanity in a year. So every 2 minutes of the sun equates to 1 year, which makes me think about technology and how this could be harnessed, these kind of things. Actually, we've seen quite a lot of technology improvement. And Susanna, I actually want to ask you, in terms of technology improvements that you have seen over the years, what have you seen and what have you implemented, and how did it actually contribute to better performing buildings, whether it be in energy or health or well-being, any of these things?
Because the projects that I've done before is mostly we are pursuing for the LEED certifications. So, and then the specification that we have our facade specialists to actually advise us on the specification that we need to follow in order to meet the criteria requirements. So what we have, I think what we have is quite standard details that we're using DGUs and all that. So, but I'm personally interested with this PTFE, the one that just now we listened to. It's kind of organic. You can play with all that. That is one of the innovations and things that I thought it's playful. You know, you can go with whatever shape, organics and all that. But I haven't got personally experience with using that innovation yet. So another thing that I think this is not really a new thing. It's a kinetic facade. So it can movable, you know, I think it's kind of fun for, as an architect, you know, you see the building can move according to the sound path and all that. So, but I never experienced with that yet, but I thought that is something that interests me in terms of the innovations that I thought that quite interesting to other architects as well.
I see the sparkle in your eyes when talking about these things. So I want to ask you guys as well, right, in terms of technology or materials or new things, what really excites you, and what do you think is really going to make a difference in the next 5 to 10 years?
I think I must say this, you know. I must take this opportunity to say this.
Go ahead.
In this forum, there are a lot of experts here. Because, well, we talk about the solar panel. And then, you know, about the renewable energy, the solar panel, and some other aspects of renewable energy, people harvesting the wind power, you know, to generate electricity and all that. But, well, the energy that we have in the country, in Malaysia, tropical country, is the heat. You know, if you can harvest that is specifically for our country, humid, heat, and if you can harvest that is where, you know, when we talk about renewable energy, this is, I think, the important, efficient source of energy that, you know, we can utilize for our usage. I think this is something, probably technology that we need to develop and make it affordable for our building industry.
One area that our company, our practice in Australia for the last few years, and now it's getting traction here in Malaysia, is the use of timber technology.
Yep.
And it's very exciting in terms of reaching, you know, the zero carbon footprint goals that we have. Like, if you look at what we generally build in now, concrete and steel and metal products, you know, the extraction of the raw material, the fabrication, the manufacture. It's incredibly, you know, energy draining. And even if you can recycle, that itself is a very exhaustive process. The pollutants that come out of it all, it's difficult to work with those materials and reach this carbon neutrality. Where the use of timber, you know, we talk about those materials in a linear way. They're like their life cycle path. Where timber is circular, it reaches full evolution. The trees grow, you harvest them, you make the timber products, you plant trees straight away. So it's continually dealing with the carbon issue. So in Australia, we've been able to have some good clients where we've been able to develop technology. Firstly, using glulam and introducing that into facade systems. So using it as a structural facade element that then the aluminium glazing systems become part of. And also we're using what we call CLT, which is cross-laminated timber in buildings now for flooring and for wall panelling. And just the value on that's pretty amazing as well. Like that monolithic wall panel inherently has a greater thermal rating than say any sort of glazing or a glaze system, or you'd have to put a lot of effort into the glazing system to do it. So when you combine that with that system with glazing, there's a lot of benefits. And also the construction systems that you do, it's generated out of BIM, so it's all digitally prefabricated. You know, the scale of the projects is less, so you can't go and do mega TRX 118 sort of things. You're smaller, fine-grained buildings, which I think is good to address the other things we were talking about health and well-being before, and getting landscape in. But you can sort of reduce construction programs by more than 50%. Sites are safer, you're reducing wet trades, you're reducing pollutants, waste, all this sort of thing. And your tolerances for when you want to bring in facade systems like glazing are all they're pretty minuscule. So like, you know, when you build now, you've got to build it, you've got to go measure it, then deal with the tolerances. When you use these systems, the tolerances are built in, so you can be prefabricating your glazing systems while you're putting your structure up. So, you know, we've developed a couple of buildings in Australia. They're small, mind you, smaller buildings. They're not big towers or anything. But in Malaysia now, we're working on what would be the single largest roof span building using this technology. So we sort of see that as very exciting moving forward. How you and Malaysia, you know, does have a burgeoning plantation timber industry. So you know that's what's interesting us at the moment.
Thanks. Shinlin, I want to ask you as well, what are the better practices that you have actually seen implemented in Malaysia, especially around low carbon or waste reduction, and how mature are these developments, as well as the mindset of the people that are implementing this?
Yeah, one of the issue here is a lot of people would think that standardizations will limit the creativity, but you look at Lego, the bricks, they have standard sizes, and yet you can create a very good piece out of the Lego bricks. And we would think that to reduce the waste, like we will have to go towards standardizations. For example, you would design the opening according to the stock size of the glass and the length of the aluminium and so forth. And while you reduce the waste, you increase the productivity because you can automate it, the standardized system and so forth, where we're experiencing labor shortages and so forth. Then we will be more effective and more sustainable, because I have seen a lot of contractors, some of them are here, that they are facing labor shortage, and we believe that to control the quality, you have to start from the factory. And during the fabrications, like AJ was talking about, the prefabricated, then you reduce the on-site the labor and the installations where you have better control in the factory. I would think the prefabricated and standardizations is a way forward for the sustainability in facade, particularly.
Yeah, I would agree to that actually, because I was just having a conversation earlier with Shinlin. We have to move forward with prefabrication or automation and things and so on and so forth. Technology and innovation is moving at a very, very fast pace. But property and construction is always lagging behind, you know, because because of the amount of funding and investment that's involved. But that's not an excuse, I would think. We really, really have to put our heads together, think of how we, the future of construction. Drones, finding supervision, construction supervision using drones. There was one, I was browsing through internet, they were already, I can't remember which company, but there was this already one idea or innovation where you are doing construction supervision work remotely. So there's this man, using a robot like those in the forklifts in manufacturing, and remotely, supervising the work because through drones and artificial intelligence and so on and so forth. Yeah, so that's something that's exciting that I would look forward to. Yeah.
Yeah, it's quite common in Australia now. On the construction side, you have the cameras set up so you can watch the contractor can't get on the phone and say, "Oh, the concrete truck's stuck in traffic."
Exactly.
Oh, there it is.
But in Australia, you need a license to fly a drone, I remember.
This is just the camera set up on site. We try to do it here, get the clients to set up just fixed cameras on the site. So you can survey the site always. It's just good to see what's going on. But all these things, what we want to see change will ultimately be market driven. So what we were saying about wastage, about labour costs, like that's what's driven it in Australia. The cost of labour is incredibly expensive. The way projects are financed, you have to do them in a certain time. You have to get them done quick. So I think Malaysia's catching up. It's not financially viable to do things status quo
that proved the issue of labour shortage was proven when during the pandemic. Almost every construction site was, despite the lockdown, but it was also the case of the issue of labour shortage, which we still have till now. Yeah.
Before we move to the last set of questions, I want to open up to the audience. If there's anybody who has any questions to any of our panelists, I think this would be a good opportunity to ask any questions. I know it's time for lunch very soon, so I don't expect many questions. But if there's anybody, please raise your hand, and we are happy to take any questions. As expected.
I think half of them are gone.
Give us food.
Take the opportunity to ask. If not, then I'll ask one more question to the panelists here, and then I guess we break for lunch.
Maybe you can summarize last closing comments from everyone, and then we can.
All right, we'll go through the last closing summary of everyone. Let's start there. Aslina, why don't we start? Susanna, why don't we start with you?
Yeah, I think for net zero by the time of 2050, 2030, that's target from the KL, right? The whole world. So honestly, net zero by zero, I don't think it's achievable, but it's best we have some sort of a target. So all the stakeholders need to play their roles and all that to actually achieve the things. But we are trying, I guess all of us will try our best to hit the targets that everybody are looking for the environment sake. So I guess we as architects and some of the developers and all that will play a role as much as we can to actually to achieve the low carbon building or net zero as much as possible. So. Yeah.
Thank you. AJ, your 30 seconds insights.
Okay, if there's one maybe point of takeaway that I'd like all of you to take away from this session today, if there's only one that you can think of or pursue further, it's innovation. I think we have to keep innovating if we are to catch up with the technology and advancement in this world. That's the saying, be crazy, because it's the crazy ones who actually change the world, right? Because if you've seen all these amazing products and innovation that they have displayed today, right? So that all came from that, that spark, that inspiration, the innovation to do something different, to add value. Yeah, so that's another, add value, always be adding value. Yeah,
Thank you. Andrew, your pearls of wisdom.
Well, we're all in it together. That's the, if we don't do it, we're all going to suffer the same, repercussions of everything. Look, it's as much what we try to do as architects or our profession is to inherently embed where we can the principles to facilitate this moving forward. And passive design gets you so far, but it's wonderful to see that there's this amazing technology there to come in and get us there where we need it. So yeah, thank you for having us. That's
all right. That's real.
Right. Yes, as we all know, global warming is real. Climate change is real. And let's use the material prudently, use the resources prudently, plant more trees. I think, well, this is try to incorporate a lot more landscaping and trees within our projects and do whatever that we can to mitigate all these challenges that we are having.
Thank you.
Yeah, continue from Azrael. I would like to talk about less is more. From the renowned architect, German-born American architect, Miss Van der Rohe. Yeah. So how can we optimize the resources and make the most out of it? Like we reduce waste, and then we can achieve a higher performance with the optimum material and resources that we have.
Thank you. Thank you guys for this exciting story. I think the time for action is now, and the time for lunch is also pretty much now. So
half
thank
of
you
the vlog gone.
Exactly. Thank you very much for your attention. I hope you enjoyed it.
Yeah. Can I request all of you to please be seated, the panelists? As our panel rightly said, it's a time for collaboration. This is the time now. We've been talking about climate change as an excuse all these years, but it is real now. I think all of them have acknowledged that. So I think it's time for us to work together. AJ mentioned about drone inspection. We have a presentation later on by BFG where one part they will be talking about how they are inspecting facades with drone. It's happening right here in Malaysia. So that's going to be an interesting talk later on. So we're going to take a 40-minute lunch break. So we will be back here by 2:10. So can I request all of you to be back here by 2:10. Can I call Joerg from Schuko on stage? We will take a photo with our panelists, and can I request for Timothy and Mustafa, if you're still around, to come on stage for a photo. Okay, see you all at 2:10. So Joerg, let's start. Yes. So can we have one? I have Shin here first. Shin, yeah, just go at the center. Can I request all the other panelists to come here so that here on the photo? Yes. All of you can come here. Just give me anything. Hans, anything. Right. Guys, if you can just come this side. You can just come this side.
For me, please. Yeah.
How, madam? change to the standalone, holding screen. Holding screen. Yeah, doing it. 1 second. Aditi, give me the Shuko one. Isn't Satya? Amma. Okay, no problem. Vitranga, no problem. No problem. Okay. Seri. Okay, bye. Seri, okay, bye. By the background. ZLG Design. He's going to be talking on a project which he did a few years ago here in Malaysia. It's called Point 92. He's going to be talking about the concrete facade of the project. We've not had presentations on concrete since this morning, so it's going to be a refreshing change to see a facade in a very unique and different material. So I'd like to call upon Mr. Huat Lim on stage, please. Mr. Lim.
Thank you very much. Say again?
You can walk and talk.
Okay. So I'm so fortunate that you guys have had your lunch. I'll get a more pleasant reception, I hope. I'm going to be quite brief because I think everyone had a long day. I suggest that the presentation be kept very, very short because I think a lot of what I'm going to talk about is more to do with the concept of resilience, which I think is a very interesting phenomenon when you talk about facade designs. I think we all know about our aluminum and glazing and the fact that with global warming and so-called crisis in materials, I thought it would be very refreshing to look at how we can embrace resilience in building envelope design. Without further ado, I'd like to thank Zak for inviting me. Okay, so I must give credit to a lot of people who have made the project possible. We are in the industry. I think we all understand that the architect can only go so far, the consultants can only go so far. Without the contractors, we won't have a building. So I run this through so that we do want to give due credit to the builders who are very, very important. In this presentation, in fact, I would like to stress more on the nature of how the concrete wall in Point 92 has been constructed. It's a very quick overview of for those who are international delegates. I think the location is very challenging because it has a very steep slope down to the highway, and we are coming from the top of the slope into the site, and then at a drop of about 15 meters after that. So one of the first things that we have decided for the facade is, for those of you who are very familiar, and I think everyone here are experts with facade design and building envelope, is that we decided that in the tropics, yes, it is a good practice to put the cores on the hot side. We took that decision very early on that this is going to be a point block. The services are going to be kept inside. We really want to celebrate the building envelope no matter what. In other words, yeah, we're in a tropic, we have the hot side and all of that. We got glare, we got solar penetration, but we're going to take that challenge. And we decided from day one, this is going to be a central core building. The building envelope is given the full reign. So you can see the typology of the plan is that you have a standard 78% efficiency on the lettable floor area. We have a central core, which means that the two firefighting stairs are embedded within the core, and the splay in respect of cutting away the plot ratio limitations on the project. The reason we splayed the facade is because we wanted the building to be kept very, very tall, and the splay was in order to meet the criteria for maximum plot ratio. And you can see the cutouts, some of the cutouts here. Okay, so this cutout here is in order to deal with the limitations in the plot ratio. There, the splay, and here, the splay as well. And then also, we got a cutout here for the terrace. So all in all, the strategy for the project was a central core, and then we had this brief from the client, which was very, very interesting. He said, we want this project to be iconic. We want it to be manageable in terms of costs. We want it to be iconic in the sense that it needs to be identifiable. It needs to have its own branding. It has to have a position on its own. So we play around with a lot of these facades and say, you know, it can be any of these. And to my mind, I think any of these facades would work well for the project. So how did we end up doing what we did for Point 92 was a bit of history to it, because we felt that the concrete in this part of the world is I think, rather commonplace, and I think we take it to the level where we felt that you don't have to precast concrete. You can actually build very good concrete forms, and you can deliver very high quality facade in concrete without prefabricating it off-site. So how does that work? So this is this lecture is about talking about how you can actually do in situ work and not lose faith in the fact that the quality is going to be overwhelming. So Point 92 is actually a brand, a positioning that we took from the site, which is 0.92 acres, and we managed to get something like 190,000 square feet of lettable space. Point 92 was also changed later, the name. The owner is now OBYU. It's an oil and gas company. Where we started out, like I said before, is the plot ratio was one of the limitations. It's 3.8. We wanted the building to have prominence, so it had to be taller than it would not have been so tall if we didn't have the splay and the cutouts. Basically, we preserved the GFA limitations, but we made the proportions more attractive. One of the things that we also played around with was the idea of the breezeway, which I think a sense of workplace, because one of the projects, I would say, concept is the sense of arrival, because workplace for us is about arriving. It's about going to work. The sense of arrival sometimes is not there. For most people who come to work, actually, you lose that experience of arriving at your workplace. And so Point 92 celebrates the fact that when you arrive, there's a breezeway, that you're not rushed into going into your workplace. Okay, so the section actually demonstrates the fact that there's a breezeway at the bottom there. It's a bit difficult with the pointer, but just give me a sec. Okay, so here's the breezeway. And then, like I said before, we're on the top side, and then when it runs down, the car park is all inside this void beyond the slope. This is the cutout that deals with the problem of the GFA. That's a cutout, and then the rest is just your standard floors, lettable area of about 12,000 square feet on each floor plate. So why do we call it the durian? So this is the, we architects, we have this thing called the Le Corbusier. It's one of our heroes. Concrete is celebrated in the 50s, and even as early as in the 40s, I think concrete was a very big thing. And we felt that the comeback would be in the form of something more expressive. So the facade actually have got 4 or 5 different, I would say, concepts. This is the durian concept. This is the part where we played around with something that's more organic, more played out in terms of the fact that it's, shall I say, it's not standard. It is more, there's a human element to the facade, which is called the durian. So these lights actually bring in visibility into one corner of the block. And then we have the ribbon. This is what you saw earlier in the opening slide. The ribbon is actually a series of openings for aluminum and glazing. We have double glazing, we also have tempered glass, we have laminated glass. We have a range of different types of glazing because for each facade, for each face, the spec, we changed the spec. So this building actually has up to 5 different glazing specs. They all look the same, but they have different performance spec, acoustically as well as whether it be laminated or air insulated glazing. So the inspiration came from the Braille system, so the way we derived this was based on the, so actually, if you understood Braille, the opening actually would read 0.92. And then we have the bidding envelope, which runs on the 4 sides. Like I said, the display is something very significant for us, where the durian is, display here. You can see the display is done on 2 different angles, one which is facing up and one which is facing down. The other part of the facade you can see is the vertical planting element here and here. Sorry about the pointer, it's a bit sluggish. And then everything else you see here is very interesting, which I can't show you in today's lecture, but everything here is actually marine plywood. It is very deep, set very deep into the plan, something like 4.5 meters, and its marine plywood is actually taken from a local source in Ipoh, and it is of export quality. We actually export all our marine plywood to the marine industry in the US. So a little bit, I don't have many side photographs actually. This project has been archived for some time, but you can see that the way that we would build the facade is they create a platform here, a stage. So actually the scaffolding is very limited. This scaffolding is actually is only to create a painting schedule for some of the elements which are on the edge, but everything else here is built off the facade, off the face. You can see in the drawings later on, a very interesting construction methodology for this facade. Basically, they don't have scaffolding from the ground. The scaffolding is only limited to where you need to cast the concrete. And here you can see the Braille windows being organized from the inside. The opening area is 42% because we wanted a GBI rating for the project. So it was very easy for us to straight away comply with the requirements in terms of opening area. The OTTV value was immediately achieved for the project, specifying that the glazing will not take up more than 42% of the facade bidding envelope. So some of the very simple detailing for the durian area, you can see here the marine plywood on this side. You can see some traces of it. And then all the concrete, actually you see here on the facade, everything that you see here is actually off form, meaning that it's not touched, it's not painted. I don't remember if they even seal it. Actually, the form itself will deliver that, and then it is immediately, it's retained in that state for up to now. It has never been painted again. So a lot of people ask me, like, is this precast concrete? The answer is no, it's actually, everything you see there is formed on site. So the way we did it was Argilia concrete and Arbox cement, which are, the technology that we had at the time was that they had this very fluid, high, or shall I say, very low viscosity concrete. It's almost like water. It's as liquid as water, actually. When you pour it, it will be able to find its way into very difficult corners like that. You can see here, the concrete had to find its way around the windows. So this is something very interesting in terms of specifying concrete. I think they called it Argilia concrete at the time, the different brands, but obviously this is the one that allows you to put the nozzle very deep into the formwork, and then you lift the nozzle very slowly at a specific rate, so you allow the concrete to reach every part of the form. So it's going to be a bit boring for me to read through this, but basically what we had was there was a strategy for how this thing is going to be built. And the nature of the cement is that because there will be some discoloration and different color to the white, so what we did was we had a strategy with the contractor to cast every 4-meter bay in random sequence so that some of the forms will go to the north side and then you bring the same one up. So basically when you randomize it, the whole white tonality is actually dispersed or made less obvious in terms of coloration and color differences. So apologize for like the text, but basically it's very interesting read because the whole concept was to find a strategy in how you can make the whole thing look very, very uniform. And also we eliminate the need for scaffolding. So in this drawing, you can see, for most of you who are already very technically based, basically the strategy was to build a platform outside of the facade. And the clue or the key to making this work very well for us was the fact that the formwork, if I use the cursor again, is casted between the slabs. So it goes up like 1.5 meters, and then it goes down 1.5 meters. So basically the idea is that where the facade and the slab connect, it is one pour. So the pour is not arrested at the slab level, but above and below the slab level. These are all the boring parts, very technical. But I think it'd be interesting in terms of sequencing of concrete because most people would cast and pour and stop the formwork at the slab level, but we didn't do that because we wanted a very uniform and uninterrupted concrete flow at this junction here. So the nozzle is put up somewhere here, and it goes all the way down to the bottom, past the slab. So it looks to me that the way that you would do this is in order that you can achieve a very high render quality and facial quality and the formwork specification. We use metal forms, and it's got a taco-ply lining, and then we spec 3 grades of concrete, which is the F1, F2, and F3. So basically, a lot of the work went into writing a very good manual for casting the concrete. Just a very quick review. I know this looks quite nasty with all the stains and everything, but I think the acid wash will need to be done regularly. You acid wash the concrete. But there are no so-called fixings on the facade in terms of like precasting. You get a lot of these notches. Everything here is in situ, and then once it's taken off, you never have to go back to retouch the concrete. And then finally, what we have is the different classes of finish that we specify. I know that this is all looking like a lot of text, and I don't have pretty images to show you guys, but it's very important that some of the best construction work that you can achieve is when you write very good specifications and a method statement. This is what I'd like to share with you this afternoon, actually. I hope I haven't kept everyone. So what I'd like to do is play a very short video after this to see the whole concept of this thing called the off-form concrete.
How does one connect people with nature? People with people, and people with their working environment. Perhaps it's a balancing act between simplicity and refinement, concrete and glass, social values and property values, human nature and the nature of business. Point 92 moved away from the typical glass box buildings on many levels and for many reasons. White concrete replaced glass curtain walls and reduced the cost by half. Simple local materials like marine plywood created an outstanding office building that is environmentally friendly energy efficient, and suited to the local climate. "600 trees green the surroundings and ingeniously connected people and nature within a working environment. Point 92 is a testament that office buildings can be responsible, sustainable, and economical, yet distinctive and appealing. A successful model that is relevant to the secondary cities of the world. It has attracted blue-chip multinational corporations despite being on the outskirts of the city center. And it has been awarded top honors in Malaysia, Asia, and on the global stage.
Thank you, Mr. Lim. I think a very different project from what we saw today. Very British kind of architecture with a lot of use of concrete in it. In the UK, they use concrete a lot. They're using UHPC, which is another cladding material, nothing but ultra high performance concrete, which are used in bridges now to develop facades over there with punched windows, mainly for embodied carbon reasons. But this is something which was done a few years here in Malaysia. I'm sure this kind of architecture is also appreciated, and I think going forward, more opaque structures are going to be the norms given the tight regulations and the climate change and other stuff. So thank you, Mr. Lim, for that excellent project and presentation. Okay, so moving on next, we are going back to BIPV. Let me just get... our next presenter is from AGC's Smart Glass division, Marcus Tan. He's going to be talking about what can be done with BIPV now. BIPV, as I said, is no more black and ugly. You've got prints, you've got colors, you've got different sizes now available. Marcus is going to give us an insight of what AGC has developed with BIPV over the past few years. So Marcus, over to you.
Thank you, Ahmed. So, good day everyone. My name is Marcus Tan from AGC for Smart Glass Products in Asia Pacific region. Today, I'm going to share with you on the topic of leading innovative energy generating facade with building integrated photovoltaic, BIPV. In this topic, I'm going to share on the clean energy trend, benefits of having sun-watt BIPV, how our range of product installed on the different applications on the building. First, a short introduction about AGC Group. AGC is founded in year 1907, and for BIPV, we started in the year 2000. More than 55,000 of employees are employed worldwide, and 3 main regions, America, Europe, Japan, and Asia. We are world-leading manufacturing companies in terms of glass, chemicals, electronics, ceramics, and others, and a total net for year 2021 of US 15 billion. Our region of HQ is in Singapore, with offices in other Asia-Pacific countries. At AGC, we set for our long-term goals of aiming to achieve net zero emissions through our products and innovative technology. Next, we look into the clean energy trend towards carbon neutrality, how the world has evolved towards clean, renewable energy. First, let's look at the World Green Building Sustainability Development Goals. There are many reasons that you can see from the infographic that benefit all of us. The green building can improve people's health and well-being, contribute to the climate resilient infrastructure, and importantly helps to combat climate change. So by year 2030, the World Green Building Committee called for existing buildings to reduce their energy consumption and eliminate emissions as fast as practical. New developments and the major renovations are to be built highly efficient, powered by renewables, with maximum reductions in carbon emissions. Let's look at the renewable energy in Southeast Asia region. Quoted by the Datuk Sira Mahadi, he says that all future developments in KL, be it commercial or residential, must rely on 30% of renewable energy. He says that going green was one way to reduce consumer financial burden. In the long run, switching to renewable energy is better and help reduce electricity consumption. In Indonesia, there are plans for expanding renewable energies across the country and intentions to see 20% or 23% of its energy supply by modern renewables like solar by 2025. Thailand also looking forward to getting a target of 30% of the renewable energy of the country's total energy mix by 2036. And also in Singapore, plans for the future of Singapore energies switch to neutral solar, low carbon alternatives like hydrogen as well. And also, Singapore has plans to deploy 2 gigawatts of solar by 2030. As we move towards renewable solar energy, we should also reduce the need to encroach land, waterways for solar farms, substations, and transmission grids. We can do this with the introductions of on-site renewable energy that will generate within the building itself for a greater environment sustainability. With the ability to produce on-site renewable energy, we have increased reliable, sustainability, and also enhanced energy efficiency. This also will have the ability to act as an emergency power source in the event of a natural disaster. In order to produce on-site renewable energy, most of us will think about solar panels on the rooftop. But we know that there are limited space or areas on the rooftop on most high-rise buildings. They have the HVAC equipments, ventilation fans, cooling towers, M&E ducts, etc. Therefore, why are we only focusing on roof area? How about other areas of the building, like the facade, skylight, balustrade, walkway? Today, I'm here to present BIPV, Building Integrated Photovoltaic, as an on-site renewable energy source. With BIPV, we are able to integrate solar cells into architectural glass with a variety of applications and solutions, highly customizable, and also contribute to the net zero energy. Unlike conventional solar panels, BIPV has good transparency, allow visible light transmission into the building. It has improved durability against moisture, and also properties that enables UV reductions of up to 99.9% and OTTV reductions. Ability to customize the panel size, we can assist you to have unlimited design options and maximize the energy efficiency according to your needs. Similar to conventional glass, it can process to an IGU or DGU unit and provide better thermal acoustic insulations. And of course, being the manufacturer, the warranty comes from AGC itself. We have received many queries or many inquiries saying that those solar panels is not pleasant looking, and thus they want something that can see through at the visual area. And they love to have something that matches to the visual area of a building. Best, they also want to make the solar cell disappear while still able to harvest the solar energy from the sun. It will be perfect for them. And so, AGC has come up with the solutions. We have two range of products, transparent and opaque solutions. Transparent solutions like the visual square and visual stripe that allows lights to penetrate in and at the same time also harvest the solar energy. Opaque products, the stop ray active, Alight active, and Lacobel T active give you options with the different colors and patterns without compromise on the aesthetic overview of the facade. Next, I will share with you more information on each of the products. First is the Vision Square product. It's a good transparency solutions which allow visible light transmission with square solar cells embedded between the interlayer and two pieces of glass. The beautiful point is AGC can customize the dimension, thickness, and size of the panels to different designs, shapes for different specs and requirements. The position of the solar cells can also be customized to make the most of the natural light and create a see-through effect. We are offering mono or bifacial cells. Bifacial cells meaning to say two side solar cells to harvest energy on two elevations. Application-wise, it's ideal for noise barrier and also as a second skin, canopy, and roof. On the right is actually a project reference in France, Monaco. It's a classic solution that adds a skylight canopy that provides some shades while also allowing light to penetrate through. This is another project reference in Hikari building done in France as well. Vision Square is used as an application for double skin to cover part of the facade. It's the first positive energy building in Europe that comprises of office, retails, and apartments. As you can see from the center picture, the solar cells are positioned on the top and bottom of the glass facade, but not on the visual area. This is customized so as to enjoy the view while also harvest solar energy to offset the energy usage by the building. Another project in Japan, Tokyo University of Agriculture. In these applications, bifacial cells was used to generate electricity for both east and west elevations. During the morning, the BIPV will harvest energy from the east, and during afternoon, the west side of the solar power. Furthermore, the position of the solar cells are customized on the bottom half of the panel, and the top part of the panel still enables public to enjoy the visual to the wonderful view of the city. There are projects where visual squares are installed as a canopy. On the left is a project located in Thailand, Lamphun province close to Chiang Mai. Vision Square acts as a source of renewable energy while providing natural light. The spacing of the solar cells are also customized to enhance visible light transmission. Depending on the day, you also create square designs on the wall area with the solar cell shadow. On the right is a use in Dhaka Nawa Gateway train station. It has the ability to harvest solar energy, shades the various weather conditions, and also provide adequate day lighting. Another project in Japan using BIPV as pedestrian walkway shelter, and also as a noise barrier on highways in Japan. Unlimited applications, variety of solutions for Vision Square. Next product is the visual stripe. It can be applied on the visual area, looking like a bamboo blind when viewed closely. However, from a distance away, you're actually unable to see the stripe clearly. In Japan, it's called sudare, which means bamboo blinds. Power output is about around 50 to 60 watt peak per meter square. If compared with Vision Square, it is considered low. However, the trade-off is actually the high transparency it can provide. You can see on the picture from the right photos, AGC Kajima plant, a net zero energy building project completed in December 2018. It gives you high transparency using the monocrystallized cells, laser cut cells, while maintaining the aesthetic appeal of the facade of the building. Actually, conventional PV are used on the rooftop. However, in order to meet the net zero energy building, more energy harvest is needed. Therefore, Vision Stripe is the next best option to install at the window area. Another project reference is the Kirin Beer office in Yokohama, Japan. Similar application is applied on the window area where high transparency is appreciated. On top of the building, you also use conventional solar to harvest solar energy. However, more energy is also needed to generate for the building usage. You can see that from the close-up, it actually still enables the person to enjoy the full view of the greenery outside. One project referenced in Penang, Malaysia, an office industrial building. Visual stripe is actually used at the reception and pantry area. Looking like a blind, it's still able to harvest solar energy and without blocking the wonderful view. Next is this stop reactive. It's an opaque spandrel and cladding glass solutions that embeds photovoltaic cells concealed behind a stop ray visual coating. It perfectly matches the AGC range or stop ray visual coating of the window, delivering aesthetic superb project while ensuring optimal energy generated. A heated glass with black enamel is used to enhance the color when viewed from the outside. This is a rendering image from the glass visualizer software configuration, providing rendering images of multiple views and weathering conditions. We use stop reactive installed at the spandrel area with stop ray S40 at the visual area. View from front or from an angle, sunny or cloudy, you can see the color matching is almost the same, therefore doesn't compromise on the aesthetic view of the building. Another rendering image using Visual 50T on the visual area and stop reactive at the spandrel area. On visual aesthetic, it provides an excellent match with the visual area. Next opaque solution is the ArtLight Active. It's designed for architects, designers who use their freedom to create any visual design styles and patterns that they like. The graphic can visually communicate information with topographic and colors in the form of solar panel. It's fully customized in terms of size, colors, designs. Comes with 3 different types of density of print, optimal, medium, and basic. The optimal gives you high power output. However, the color printing is more spread out, and thus the resolutions of the image is lesser. The basic on the right gives you a better resolutions, however, lesser power output compared with the optimal type. One project reference is the Tor Park in Belgium. At first look, you were taught that the light bulb design is just there to enhance the look of the building only. You will not know it is actually also harvesting energy and provide power to the building. It seamlessly also integrates to be part of the design of the building itself. Another project reference is this Shell Technology Center in Netherlands. You can see from the 8 different design logos on the top of the building. It blends in with the building seamlessly, probably without any knowledge, we're taught that it's just a logo or design. However, it's also an energy generating design that also offsets the energy used on the building itself. Lacobel T Active is the last of our range of opaque products. It's a highly effective product that gives you an output from the range of 100 to 160 watt peak per meter square and a smooth, uniform, matte or glossy finish based on the proven leading technology paint. Application-wise, it can be installed on the cladding, spandrel, and roofing. This is one project reference in Norway. Lacobel T Active is used on the facade, integrated to the cladding on the wall. Another project in France, Lacobel T Active is also installed on the roof of the French Ministry of Defense building. The architect designed BIPV to be installed as an optical light roof with angular sections to generate solar energy. Finally, I would like to share with you on an ongoing project in Malaysia, the UNI KL project, Sustainable Energy Living Lab. Located in UNI KL Gombak-based institute, the 3-story academic net zero building plus will house teaching and learning facilities as well as research lab for sustainable energy studies. First zero energy building project in Malaysia, total area of about 1,100 square meters, system capacity 182 kilowatt peak with about 550 modules. Total is going to be on site at the roof with the logo of using ArtLight Active and also the facade using Visual Square and also the glass roof. To summarize, we have 5 products. Visual Square, to harvest energy with creative positioning cell. The common square solar cells embedded with 2 pieces of glass, allowing lights penetrate through, creating shadows and shades. Visual Stripe, a bamboo light blinds used on the visual area. Stop ray additive used on the spandrel area, providing same aesthetic look on the visual glass area. Light additive, unlimited design for logos, patterns, shapes, and colors. And also Lacobel T additive, a uniform color on the cladding itself. So total 5 different products for any designs and new things that you would like to design on the building itself. Our team will be able to assist in the design stage with data such as the solar path simulations, solar integrations data based on different applications and evaluations. Energy generating properties like the module efficiency, power output, energy property specifications to help you on your glass specifications. And also, we'll be able to provide the glass performance like the SC value, U value, and also other light properties for you to put on your facade specifications for your building. We are also having ability to provide expertise advice. We have local presence in Southeast Asia region, technical assistance, and good track record with all these project reference, and will give your potential on-site renewable energy project a peace of mind. With this, I end my presentation. Thank you for your time, and if you have any query or like to have more information, feel free to contact us, or you can find us at the booth outside. Thank you.
Thank you, Marcus. So as I said, BIPV is not ugly. It is still becoming better year by year. There are also very transparent solutions for BIPV. So it's evolving. It's a material. It's a solution which people are adopting more frequently. Just give me 1 second before I call our next speaker. I'll just reload the presentation. So our next presenter is a facade consultant, very well known globally, Mr. Mathieu Meur. He's the director of TP Façade. He's going to be talking on fire performance of facades, mainly from a testing perspective. I was informed by him that Malaysia has recently upgraded their fire laws, and he's going to be giving some insight on what these tests are and what they mean for the construction industry. Mr. Mathieu Meur.
Good afternoon. In recent years, we've had a lot of fire events involving facades. We're all very familiar with Grenfell Tower, in particular in 2017. There's been an incident nearer in To Quan Road in Singapore, and in 2018 it was the EPF building. A lot of these incidents, and there's been countless others, I mean hundreds and hundreds of others. One of the most infamous is the Torch in Dubai, which caught fire twice in a row, which is quite nice for a building called the Torch. So I thought that it would be interesting to look at the testing of facades and the design of facades from a fire safety point of view, and what sort of measures, what sort of testing, and what sort of design strategies can be implemented to make the facade safe from a fire point of view. I'm starting with a quick overview of applicable standards. These are the standards that you see most commonly applied on buildings in the region. They vary a little bit from place to place. We'll dive in the next section. There are plenty of other standards. I've come across Russian standards, I've come across Canadian standards and others. But these are the ones that you will come across more often in this part of the world. And we'll look at them one by one, just so that we're familiar with what they do and what they don't do, more importantly. One of those that you sometimes come across, you will see a fire report or a fire test report, and you see this ASTM E84. It is good for testing panels or materials. And what it tests for primarily is flame spread, as you can see, and smoke development, but not much else, really. And it doesn't test the system, more importantly. We'll look at why this is important in a short while. BS 476, parts 6 and 7, I think everyone here should be very, very familiar with. These are tests, very venerable tests. They've been around since the 50s, I believe. Barely updated since that time. Very minor changes, and we typically look, in most countries that use BS 476, we're looking at what is called class 0, and again in a short while I'll dive into what that means. EN 13501-1 is a more recent addition to the lineup of fire tests. It is now, it's obviously applicable in Europe, and it's now also applicable in some countries in Asia, including Singapore, for instance. And this is more of a system test. So you test, a material test, but it tests also for flaming droplets, which the other standards we saw before do not test for. And if you have certain materials that may melt and catch fire, and you have flaming droplets that fall, that could be dangerous to people on the ground. So this is slightly more comprehensive than what we've seen before, whether it's BS 476 or ASTM E84. Another one that you see quite commonly on materials that come from the US is this ASTM E119. This is probably one of the easiest tests to pass, so it just looks good in a certificate. So here I've got my fire test certificate, but at the end of the day it doesn't mean very much because it's a super easy test to pass. NFPA 285, this is a whole system test. So in this type of test, you basically make a full height assembly, 2-story talls, there's an opening, there's gas that is lit at the base through the opening, and you measure the propagation of the fire, and you see how far up it goes. It's a 30-minute test. It's pretty difficult to pass. This is a system test rather than a material test, as I mentioned. And then BS 8414, which a lot of you in Malaysia would now be familiar with. We'll talk about it in a minute. Again, system test. The test basically describes how you do a full scale, again, 2-story test of a facade system, but it stops short of giving passing criteria. And we'll see that in Malaysia, there are passing criteria that are actually slightly more onerous compared to other countries, which is, I feel, a good thing. For those who have just woken up after lunch, there's a spelling mistake here. It's not 6,000 degrees, it's 600 degrees. I'm just making sure who's actually still who's not sleeping and who's sleeping. So this is a quick summary. I think in this one slide you get like a good snapshot of which test does what. And what you'll find interesting is that not one single test actually delivers the full spectrum, whether it's for materials or for systems. So you always need a combination of a minimum of 2 sets of standards, 2 sets of tests to actually cover the full range of performance requirements. Now, I'm going to dive a little bit into the test requirements in Malaysia, Singapore, and UAE. I think a lot of us work in those 3 countries or have worked in those 3 countries. You must be, those who obviously deal with the fire department and the fire code, you know it's extremely complex. There's hundreds and hundreds of clauses. Sometimes they even contradict each other. So I've really focused on the absolute bare minimum given the limited time I have today. So in Malaysia, the main change that has occurred in recent years is basically the addition of this BS 8414 test, which, as I mentioned before, is a full-scale test. And one of the additional passing criteria that doesn't, other than flame spread and temperature, maximum temperature rise and things like that, one of the requirements is to limit the size and the distance at which debris can fall off the facade and potentially injure people on the ground. So there is this additional requirement, which is actually quite interesting to have. And of course, there's the BS 476 part 6 and 7. Part 6 measures the fire growth or the fire spread on the surface, while, part 7, so part 6 is on the left, part 7 is on the right. Part 7 looks at the lateral spread of flame. So obviously, for a material to be acceptable, it needs to limit the amount of flame spread over its surface and laterally. Now, in Singapore, it's interesting because there's also been quite a lot of changes. Very recently, these were implemented in 2019. And this idea of the fire separation between floors is something that has existed in Malaysia for a very long time, at least as long as I've been practicing, but has been added into the Singapore Fire Code only recently, and it has some pretty drastic implications. The idea, obviously, is you want to stop the fire spreading from one floor to the other, maybe coming out of a window, breaking through, and passing over. And what it means is that, and this applies only to residential building, but it's extremely onerous because it means that the spandrel area needs to have either 1.5 meter some sort of fire-rated, 1 hour fire-rated separation, which is clearly unacceptable given the floor-to-floor height in residential development, or it needs to have some form of horizontal protrusion, which is what is currently the general practice on most residential developments in Singapore. So if you're watching out this space in the next 1 or 2 years, all the residential developments being completed in Singapore will all have something like this sticking out at every floor. One of the new changes, and this is something that is indirect in some sense, it's a requirement to break cavities. And it's something that a lot of contractors have not caught on in Singapore, a lot of designers have not caught on, subdividing cavities. In Malaysia, it's not specified like that. Instead, there's this requirement to pass BS 8414. And in some sense, to pass BS 8414, you would need a subdivision of cavities and have some form of fire stops within the cavities to pass it. So different ways of achieving similar results. Composite panels, the infamous ones that have been blamed or responsible for a number of very bad fires in recent years. There are specific requirements in terms of performance of the core material, which I believe is actually a mistake. The core is never exposed, and you actually miss out the surface spread of flame by not testing the actual cladding material on the surface. So I think it's actually a mistake to test on the core itself. In UAE, I keep it short, but UAE has been one of the first in, let's say, the broader region to implement full-scale testing of all facade systems. And they are a little bit open. You know, you can pick and choose between four different testing standards, but there is a very specific requirement for GFRC that you cannot use NFPA 285 to test GFRC for some reason. Perhaps it's because GFRC sometimes with fire content, with the water content remaining in the material, tends to break up and have small explosions and scattering of debris. I'm not quite sure why they did it this way, but anyway, it's a particularity of the requirements in Dubai. Now, just a few, for the designers in the room, I just wanted to share a few case studies related to fire and some takeaway points. There's 10 minutes, 10 points. The first one is on the combustibility of products. For a very, very long time, the fire standards, the fire codes in different countries have focused on the combustibility of products to determine the acceptability of a material. And what we've seen is, of course, when the material is not in line with this requirement, you have pretty bad fires that spread violently from floor to floor. We've had the address downtown before in Dubai. We've had the Grenfell Tower in London, which One was because of the cladding, the other one was the cladding, and potentially there were many other problems with Grenfell. I won't go into too much detail, but flammable insulation, flammable cladding were the prime contributors. But this is a counterexample. This is the Windsor building in Madrid, which was solid aluminum, not flammable, but because of the design of the system, it still burned down all the way through. And this brings me to lesson number 2, is that you need the combustibility of materials and the combustibility of the system. And this is where the full-scale testing is absolutely essential. And this is something that has been, as I mentioned before, implemented recently in Malaysia. This is, for those who are familiar with him, this is the Serim test lab. And this is a test that's ongoing for one of our projects in KL in the TRX area. So, interestingly, the fire test actually failed the first time. It led to reformulation of the GRC, and it passed the second time. So it was actually worthwhile doing the test to find that out and to tweak the material to make it work the second time. The next one is that even if you seal cavities, you test the system, you test a lot of things, the spread of flame on the surface is something that needs to be considered. And sometimes you have cavity barriers, you have other things that stop the passage of fire, but the fire may actually flow and spread over the surface of the cladding and then enter back the building through a window, for example, or some form of unprotected opening. And this is why I was mentioning just now that the requirement in Singapore to test composite panels without the surface sheet is probably a mistake, at least I believe it is. The other one is the envelope geometry. You know, we've seen some very interesting buildings throughout the day today and some interesting geometries. One of the things we want to be very careful with is any form of chimney or any form of overhangs that may catch fire and allow the fire to move upward. This was an example in the Middle East, in Dubai, where kitchen exhaust, actually a lot of oil, there was a spark, it flamed, and it went all the way through in a matter of just a few minutes because of this chimney effect. Another example of this Torre del Moro in Milan, where basically you had large horizontal cavities, large horizontal voids or plenums, if you want, and this allowed the fire to travel horizontally, find the edge, which was not separated because it was beyond the building line, go up and then spread back. So eventually the whole building eventually caught fire. Fire stops, so this is Grenfell being reclad. And one of the things that was found out was that the design of the fire stop, you know, it's something we all do, we all see, we all know about, but it was not done properly, it was not designed properly, it was not installed properly, and it basically allowed the fire to bypass the fire stops in the cavity and spread from floor to floor to floor. And this was, again, one of the contributing factors to why Grenfell was such a bad fire and such a bad situation. But you can see a counterexample here where with vertical fire stops, unoccupied spaces actually burnt. So this is again the project in Milan. The fire burnt and stopped when it met the vertical fire stop, which is good. So it burnt over unoccupied spaces and then stopped when it got to occupied spaces, which is fine. And one of the important things which is mentioned in the previous slide, but I think visually it's more important to see on this video, is that fire stops should be designed to be retained in place in case of fire. And also throughout the life of the facade. The facade may move inward, outward, and we don't want the fire stop to drop, and then of course it's not performing its function anymore. One of the interesting changes in the fire code in Singapore, for instance, is the requirement to meet ASTM E2307, which includes this cyclic testing, this movement testing of the fire stop to make sure that it stays in place throughout the lifespan of the building. The other thing is the cavity width and height do matter. They do have an influence on the performance of a building in case of fire. And in this case, this is actually pretty recent. This was in Surabaya just a few months back, not very long ago, I think in May. Very large cavities are much harder to protect than small cavities. Potentially what should have been done there was break the cavity into smaller parts to prevent a very large amount of heat, very large amount of flames to build up within the cavities and basically burnt everything down in their passage. Another one, even if you've done everything, you've followed the code, you've checked everything on shop drawings, it's always essential to follow that up on site by checking the contractor workmanship. And I'm just going to share some of the typical problems you will see, the typical faults you may see with the installation of fire breaks, fire seals. These are some classic mistakes where gaps remain, for example, if you look at the photo on the right, gaps remain in front of the bracket, for instance. So you have a nice seal on the left and right of the bracket, but the fire is able to pass through that gap in front of the bracket. The photo in the middle, on the left, basically you can see the application of the fire stop. The liquid fire seal was not done very well. It's basically peeling off and not adhering, not remaining in place. Again, gaps, missing insulation, missing flashings or smoke seals. These are all pretty common application problems or workmanship problems that you may see on site. The next one, and this is probably less important if you're doing projects in the middle of a town or a city like KL or Singapore, or where you have access immediately to fire services. If you're slightly outside town or maybe even within town, but if a fire occurs at peak hour, the time that it will take for the firemen to reach the place is very important. Access on ground for the fire trucks to be able to access the different parts of the facade is important. If not, you could actually end up having a lot of problems with your building. In this particular video, it went a little bit fast, but what happened was, this was in Mumbai, the project was just finished, the fire started on the 13th floor, and the fire truck could only reach the 12th floor. The fire broke 18 pieces of glass, the firemen broke 120. So, because they just couldn't reach, they were trying to reach above, and they basically broke 10 times more or 7 times more panels than the fire itself. So the design of the fire prevention or the fire stops, like what you see here, actually worked very, very well. And you can see how violent a fire can be. The mullions are melted, the transoms have disappeared, the glass obviously has broken because of the extreme temperatures, but it didn't spread to the 14th floor above. So actually the design worked very, very well. And one of the last things I wanted to mention is the insurance and property valuation aspect, which is in a lot of countries. Now what's happening is there's been so many fires involving the facades that the insurance for your property will sometime ask you or ask the developer, show me proof or give me a report showing that your facade complies with regulation and is safe. And so risk assessment report is required for this purpose. Thank you very much.
Thank you, Mr. Mathieu. Again, very important topic. He can go hours and hours on the same, but due to the paucity of time, he was bang on with his 10 points. A lot to ponder. Our next presenter is Mr. Sreenivas Narayanan. He's the Technical Director for Middle East Asia Pacific at SideRise, taking this concept of fire safety in facades forward. He's going to be talking on the solutions his company has, SideRise, which is basically cavity barriers for curtain walls and rear ventilated cladding. So over to you, Srini.
Check. I want to start with a disclaimer. I have not spoken to Mathieu Meur before this presentation. We have not spoken for the last 1 week or 1 month. Probably I met him 3 months back, so my presentation is going to overlap. And I also want to thank him that he has set the audience very well. And I'm just going to take it forward. Last but not the least, for the audience, it's a lucky day that it's going to be 40 minutes of full fire continuously. So I hope I can cover what Mathieu has said and give a manufacturer's perspective. Okay, just one slide of history. We celebrated our 50 years in business, incorporated in 1972. So for the last 50 years, what we have been doing is products related to fire, thermal, and acoustic compartment. Acoustics for the facade, which is our primary business, primary products to the market, though we have other products which are more towards acoustics for OEM products, like we do products like acoustic enclosures for Triumph motorbikes, for example. So there are lots of OEM products that we do outside what we do for facade, which we'll not cover today. But one more slide. On the left, you see we are represented in a global market. So projects where we have completed, countries where we have already done projects, or countries where we have already doing projects. We have 3 offices. So we have a Singapore branch office for Asia Pacific, with Dubai and UK being our manufacturing plant. So enough said. I wanted to go one step back to what Mathieu covered. Is whenever we are designing a building, we have something called as a fire strategy. Okay, there are codes in international market where if you have a smoke detection system or an active sprinkler system, you don't have to do a passive fire protection. So which I find it very weird. So it's important that the triangle is completed. So passive fire protection is equally important as an active system, so that the building is protected, the asset is protected, and the occupants are given enough time for evacuation. So said that, Mathieu has covered the reaction to fire very well about 13501, but I would like to touch another subject, which is a resistance to fire. So when we install a cavity barrier or a perimeter barrier, irrespective of the manufacturers, it has to be tested for resistance to fire. So it has to resist smoke, heat, toxic gases, flames from one compartment to another compartment. As simple as that. So that is what we have to test to. So 13501-1 is reaction to fire, and -2 is resistance to fire. So again, another terminology that we can use, reaction to fire is always like you get A1, class A2, B, but resistance to fire is always termed as in minutes. So 30 minutes, 60 minutes, 90 minutes, 120 minutes. So it's a different terminology. One of the common points or common mistakes that we do in a market is like fire-rated ACP, for example. So there is only a reaction to fire product where you get a reaction saying that this is a classification, but you cannot get a rating for a material unless it is tested as a system or installed as a system. So why do we use rock wool, or why everybody use stone wool, for example? The reason is it has the best fire resistance property, because when we do the rock wool by itself, the raw material is melted at 2000 degrees to make it a liquid and then made into fibers. So it has a very high temperature resistance, long-term thermal resistance, another factor, water repellency. So if you take a stone and dip it in water and remove it, only the outside layer will get wet. It also has a dimensional stability, and very good sound absorption. One of the images which I wanted to focus on the left side is the Welsh Dragon. We are a Welsh company. So we cut our material using a CNC machine to do a Welsh Dragon. It's basically to show that if the material has the right combination or the right recipe, you can get a good dimensional stability on a rock wool also. Another point which I wanted to cover, which Mathieu covered, was in relation to movement characteristics. So the orientation of the mineral wools are very important so that it accommodates the movement of wind load, positive load, negative load, thermal movement. So the product which is installed in that void should have that kind of a characteristics or accommodate that kind of a movement. So that is why pre-cycling of the products are required, which was also covered earlier. So I'll split my next 15 minutes into two. One is for a perimeter barrier application for curtain walls, and then an external facade arrangement for cavity barriers. Where is this is located? As we all know, it's the void between the floor slab and the curtain walling by itself. So that's the void that has to be filled. There are other passive fire protection requirements on a building, like through penetration for MEP joints or construction joints. So these are also important, and as a civil, but it falls under the civil scope for the building. But the void between the floor slab and the external facade it generally falls under the scope of facade contractors. What does the UBBL say, which is a very important point? It says that we have to test a product to BS 476 Part 20. The standard by itself was developed in 1950s or 1953 to be more precise, but is it the right standard? So it's an opportunity that we all work together to understand what the current conditions are, because in 1950s, what we tested, or what BS 476 is to test the product between two concrete floor slabs. It is not to test between a concrete floor slab and an external facade. It is very static. It does not accommodate any movement. You don't test the product for movement. You don't test the performance of the facade. So it's very important that we move towards an harmonized standard which can be tested with the correct arrangement that we would be installing on the project sites. So again, another point where the internal spread of fire is very important. So that is why, it has to be stopped, as that is the primary function of a perimeter fire stop. And also you have the leapfrog effect, where a fire can break and come back inside. One of the slides on the previous presentation was said about leapfrog. Again, that height of 1.5 meters is very important, or 915 is important, or an extension of a balcony or a concrete floor is important, so that the fire does not, once it breaks the vision area, it should not come back inside. That's the primary requirement. And there has been research where it says that the reason why we say 915 is within 60 minutes, if it's less than 915, the fire can come back inside within 60 minutes. So that is why it's 915 is kept as a minimum requirement. So we spoke about harmonized standards. So we move into EN standards and ASTM standards which have been developed, where we use a curtain wall arrangement. We use a non-fire rated curtain wall. And then today, we can also use a unitized curtain wall, because most of the project we install is unitized, and we have been testing for stick curtain wall doesn't make any purpose, because the movement requirements or the way the facade is installed itself is different. So we have the opportunity to test with unitized curtain walls as well. So an image from a 2307 test. So it's again a large scale test, something similar to an NFPA 285, but it uses a non-fire rated curtain wall. You have a thermal insulation, you have the spandrel, and you install a perimeter barrier between the floor slab and the spandrel. A very interesting image. This test was done in Dubai in Thomas Bell-Wright. My friends in the lab, what they did was before the test started, they went and stuck a paper to say this is the test number and this is the standard they are testing on the spandrel where the temperature is going to be more than 1100 degrees. So an image after 3 hours shows that the paper is still intact and there was no transfer of heat through the spandrel as well. Another test, which is more towards European norms, a closed furnace test, where it is pressurized condition. So you test again with a non-fire rated curtain wall and test for the largest gap possible or the lowest gap. Both has to be tested. Movement characteristics, which very much covered very well by Mathieu on the previous presentation. So we need to cycle the product before we can test it. So what we do is we cycle the product for example, as a manufacturer, we chose 10%, and the gap is 250 mm, for example. We compress 25 mm, relax it 50 mm, and compress 25 mm. So this is one cycle. And this cycle is done 500 times at a speed of 30 cycles per minute. So we have various systems in the market. So the steel part, the steel system is not tested. Even a BS476 doesn't comply. But it's also the two-part systems which very well comply, which are tested. And you have a single-part system as what we offer, where everything is as a quality management system done in the factory. The installation of a two-part system is like you cut the insulation, rotate it 90 degrees, compress it as per the manufacturer's requirement, and then do a smoke seal on top. But what we have done is we have eliminated the human interference on the project site, so everything is done at the factory. So you just have to cut the material and install it. So we have eliminated the human error factor. So as a quality management system, we are able to give you comply with the legal requirements, for example, for every specific country, test to the standards, certification by third party, and also provide a COCs. For example, Singapore requires a third party COC, etc. So we are able to provide those documents. We move into cavity barriers, which is on the external facades. I thought I would be showing videos and frightening people, but Mathieu showed more images than me. But the middle one is very interesting because geometry of the building is very important on how the fire spreads. So you can see that the fire started on a podium level, and the fire has spread to the roof within 2 minutes. For example, it has already spread around 5 floors, where we have just, the slide has been on just for 40 seconds. So because of the geometry of the building, it's very important for us to understand that the spread of fire is going to be faster. So it's very important that we compartmentalize. We provide a cavity barriers. We compartmentalize so that we understand how to protect these kind of assets. Again, a list of projects where we have come across, or in recent years we have heard about fires. There are around 15 projects here. Sadly, most of them are in UAE, but more and 80% of these fires that you see here on the list is going to be related to claddings or external facades. You will not see much of these kind of fire spread in a curtain walling building. So what do we follow? If we don't have a code, then we refer back to something called as an approved document B, which is the UK document on construction of the buildings. It says how to where to install cavity barriers, where is horizontal needed, where is vertical needed. So the document is very clear. This is an extract from an NHBC document where also they say the vertical distance between two cavity barriers should be limited to 6 meters. But if you take an approved document, it's 20 meters. So it's very important that we understand the regulations. And if we don't have a regulation, we have to, as we are constructing for the future, we should refer to some document that can give us some supporting evidence on how to build it today. So irrespective of the type of the cladding, stone, terracotta, we use GRC. In one of the projects, we have used Korean as an example for doing a large-scale system test. So it's very important that irrespective of the cladding type, it needs to be tested so that a large-scale system test is where you get a result to say whether the system can pass or not. So two different products. One is non-ventilated and segmented into ventilated. Ventilated are more towards rain screen principles that we have, where we need circulation of air. Am I on the right slide? Yes. So circulation of air is very important. But on the left side, when you see if there is a fire, there is a ventilation of 25 mm, which has an intumescent strip which will expand when it comes in contact with fire. This expands with temperature. So probably 104, I mean, not probably, it expands at 140 degrees and closes the void. It's very important that for us to understand that the cavity barrier will perform only until the cladding is in place. Once the cladding is gone, then the cavity barrier will make no purpose. So it reduces the speed in which the fire will travel within a chimney. That's the principles of it. I'm based in Dubai. The UAE Fire and Life Safety Code is something which is very detailed in relation to external facade assemblies. It clearly tells what is the type of building and what is the cladding you have to use. So on the left, you have claddings where type of the building, it says that you have to use a minimum of A2 category for the panels, but you have to do a large-scale system test. You can do NFPA, BS8414, or an FM test or an ISO test. But on the left, if it's a low-rise, mid-rise, warehouse, or any other industrial types, you can use Class B, which is very well defined. But still, you have to do a large-scale system test, irrespective of the product classification. So an extract of the test has an experience. What we have is 258 tests as on 7th of June. People ask, why have you done so many tests? Because we have partnered with so many different types of products, so many different types of manufacturers, so many different types of constructions. So it's just various combinations that we have tested and we have partnered with. You can see Malaysia is important where we are today. So we would have done around 16 large-scale system tests in Malaysia in the laboratory here in Sirim, where different types of manufacturers we have partnered and different types of void we have tested. Third-party certifications, we have, these are very important where it goes through a process where they come to our factory, audit the factory, inspect the factory, sample the materials, and then it is tested. So it's very important to refer to a third-party certificate, because if you are referring to a test report, it means that you are going to refer only for that test, but you don't know if the same material is being supplied to you on projects. So that's why a third-party certificate is very important. So you have, every manufacturer chooses a preferable or an active third-party certification bodies. So few of them that are listed here are around 5. Yes, so 5 different third-party certifications that we are able to offer. Complying to the regional requirement is very important. So compliance to Bomba's regulations are important. Getting the product approved by the local authority is important. So what you see here is the first 2 slides that has shown that the products are approved by Bomba for the particular performance. But you also have a system performance where a system manufacturer who has tested to 8414 would include the cavity barriers part of their system and get a Bomba certificate. So it's very important that we refer back to what certifications the manufacturers have. Where we support is starting from a concept design. It's very important that we are able to give bespoke site solutions where we are having different types of constructions that we might use, or a geometry of the project. We might have a bull nose which is running vertical to the full height. So it's all important that we are able to support and compartmentalize. Once we supply, we give installation supports for every single project. We do inspections, which are all through digital, and we provide a warranty as of once the project classifies our requirements. So an extract from the inspection app, which is available on Apple and Google Play stores. Just few projects. Canary Wharf is very where it all started. We have the Expo 2020 where around 27 different pavilions were done, different types of buildings. We have KAFD in Saudi where there were around 37 different buildings which utilized side rise. And then this is a view from our Dubai office where we're overlooking the business bay, so business district, where the projects we have done. Last two slides, sorry. Coming into Malaysia, we are currently doing the 118 in the mall for cladding. We have completed the cavity barriers. We have recently partnered with the manufacturers, so we did a large-scale system test and did the project for cavity barriers on Affin Bank. The one on the top is the Dubai Uptown Tower, which is a newest tall tower, Amazon headquarters. One of the interesting points is, I don't want to offend any Liverpool fans, but I'm a Liverpool fan, but we didn't do well. But all the Premier League playing stadiums in the UK have been done. So every Premier League stadium is unique, and we were able to support in relation to facades. And as Mathieu said, these are just not numbers. We have around 25 different standards, and these are resistance to fire and very few reaction to fire. So every country has requirements. China has different, Korea has different, UAE has different, India has different. So it's very important that we work through the country's requirements, and we are able to provide you with sitting in Malaysia, if you're designing a project for India or for Australia, we are able to support you with the documents for that particular region. So happy to assist, and you have my contact, but we'll see you out. If you have any questions, I would be very happy to answer. Thank you.
Thank you, Sreenivas. Thank you, Sreenivas. So I think out of the 258 test side rises done, Sreenivas has been involved in more than 160 of them personally. So your go-to man to ask about testing your facade systems. Okay, moving next, you need to coat every facade. So you have options of liquid coatings and powder coatings. But today, Franck Derouen, who's the Global Architectural Director for Axalta, which does both, will be talking about their powder coating solutions. Frank's based out of Dubai. He's been very instrumental in pushing standards for powder coatings in the form of Qualicoat globally. So Franck will be talking to us about their powder coating solutions for the architectural market. So Franck Derouen, please.
Okay, thank you very much. Good afternoon, ladies and gentlemen. I'm very honored and impressed to be here with you today. Yes, so I'm going to talk now about finishing and more specifically about powder coating. Okay, so first of all, I am representing Axalta coating system. Axalta coating system is not necessarily well known as a brand, but we have more than 150 years history in the coating industry. We are a global company, public company, American origin, and we are listed on the New York Stock Exchange. When it comes to powder coating, we are a true global company. We have factories on all continents, 16 factories, and we are probably the first. It's not easy to have a clear idea, but probably one of the first in this industry, because we started more than 60 years ago now. Number 2 in the world, or let's say most famous product brand is Alesta powder coatings, but we are now developing new technologies with new brands like Plascoat or Upsite, and I'm going to talk about that later. So I always like to start my presentation by why powder coating. Okay, so we all talk about powder coating. I'm going to focus during my presentation about the sustainability aspect of powder coating, because it is now something that is interesting for everyone. And sustainability has been the key factor of growth of powder coating since the beginning, actually. Why? Because when we talk about powder coating versus liquid, here are the main differences. Powder coating is only powder. Liquid, when you buy 1 tin of liquid paint, actually you buy only 50% of paint. The remaining 50% is solvent, and solvent goes in the air right after the paint has been applied. Whereas when we sell 1 kilogram of powder coating to our customers, I mean, they can use this 1 kilogram. There is nothing else than powder coating. So this is the first aspect. Sustainability, no solvents and very efficient. The second aspect of sustainability, in a nutshell, is the cost of application and cost of energy. Liquid coating is at least a 3 coat system, primer plus 2 coat finishing, which require usually 1 or more, more often 2 bakings. So it's a long process, 3 coat plus 2 bakings. Powder coating is only 1 coat and 1 baking. Okay, so obviously the cost of energy is much lesser with powder coating than with liquid coatings. Okay, this is a summary. So there is no VOCs, as I said, so 1 coat system. Also powder coating can be recycled. When our applicator spray powder on an aluminum profile, for example, the powder that has not been sprayed on the profile can be reclaimed and reintroduced into the process. Okay? And the last aspect that I'm going to really to develop later on is the durability. Durability is obviously sustainability. If the building is durable, if the finishing is durable, then the maintenance or the recoating, the renovation will occur later. So again, this is about saving energy, saving cost, being more sustainable. We can use powder coating on many parts of the building, cladding, we can use on windows, we can use on paneling, we can use on doors, we can use powder coating on handrails, even inside the building, especially office building, the partitioning is usually powder coated, and the signage. Okay, architectural powder coating. We always differentiate powder coating and architectural powder coating because architectural powder coating must comply with specifications and standards. Okay, again, durability is key, and here is an example of track record, durable track record. Durability comes with track record, obviously. And this is the Torre Akbar Tower in Barcelona, designed by Jean Nouvel. It's quite an old tower now. It's an iconic tower in Barcelona. And it's almost 20 years old now. And for this building, 27 colors were developed. You probably noticed in the specification always talking about Florida durability, Florida resistance, or Florida exposure. Why Florida? Because Florida is a place in the world that combines humidity, UV exposure, and high temperatures, a bit like Malaysia. And it's a cycle. It's exactly like Malaysia. The thing is that the Americans invented the concept a bit earlier. And now, Florida is really the universal testing method for assessing coatings, but not only coatings, can be also roof tiles, glass, everything. And we send, paint manufacturers send panels to Florida to be assessed. So it goes on a stand, and it's exposed to the sun, and we measure the gloss and the color variation on a regular basis. Okay. So this is not connected to warranty. Okay, when we talk about I mean, 2-year resistance in Florida doesn't mean that after 2 years the products will collapse. No. It is just that one product or products comply with a certain level or reach a certain level of performance after 2, 3, 5 years in Florida. Standards, European and international standards. So these are the main international standards for coatings. The first one, probably the most famous and the eldest, is the AMA standards. It comes from the USA. So there are 3 levels of specification, also based on Florida exposure. AMA 2603 for 1 year Florida exposure, AMA 2604 for 5 years Florida exposure, and AMA 2605 for 5 years. Okay. One very popular international standard also is Qualicoat. Qualicoat comes from Europe originally, but it's growing now outside Europe. Like AMA, there are 3 levels of specification, but a bit different. We have the class 1 for 1 year Florida specification. Class 2 is 3-year Florida specifications, and class 3 is 5-year Florida specifications. Then there is a German standard which is quite popular in Central Europe and in Germany. It's named GSB, also based on Florida exposure, 4 classes. And the last one is EN. EN is a very, let's say, low-profile standard. It's really a minimum specification. I would not really recommend to use this standard, but it exists and we can see it in the specifications. It's EN 12206, and actually it replaced the famous BS 6496, which will probably now be reintroduced as the UK left Europe. But it's a minimum level of specifications. And powder coating manufacturers, as Axalta, usually offer products for each type of specification, standard durability. So within Axalta, we have Alesta AP for 1 year Florida specifications. Super durability, we have Alesta SD for 3 and 5 year specifications. And for 10-year specification, 10-year Florida specification, Alesta EDs, usually based on fluorocarbon technology. It's not on polyester like the other 2 specifications, but it's based on another chemistry, fluorocarbon. When we talk about durability, obviously, we have to talk about warranty, because I would say valuing durability is also giving something valuable to our customers and to you customers, and this is warranty. So it's important to offer good warranties, and again, it's connected to sustainability. Okay, so for example, for super durable product lines, Alesta SD, it's possible to get within Axalta up to 25 years warranty, depending, of course, on a lot of parameters, the building location, the country, the exposure, the distance with the seaside, but it's up to 25 years in, let's say, normal environment. Of course, we have to make sure that it's not only about the coating itself, but it's also about the application. It doesn't make any sense to sell a high-end products if we cannot control or let's say have a good application and a good quality during the application process. So this is the reason why we approve our applicators. So we assess our applicators on a regular basis. Okay, we deliver a 1-year approval certificate to these applicators, and the warranty is available only from those approved applicators. So the warranty covers the color variation, okay, the gloss retention, but also the coating's integrity, like cracking, checking, and adhesion of the building. It also warranty compliance to a specification. When you decide on a coating, it's also important to check the yearly liability reductions, because sometimes, I mean, there is like a depreciation of the coating year by year, and after the first year, the liability is 100%, and after the warranty period, or at the end of the warranty, it can go down to 20 or 15%. Okay, within Axalta, it's a flat liability, so it's 100% during the whole warranty period, which is also for I would say very interesting for our customers. So again, there is a full process. Again, it's not about supplying a high quality powder coating. It's about securing the whole application process until the end. Okay, so usually, okay, the process when consultants or fabricators wants to have the warranty, first of all, is to obviously define the project, to identify the approved applicator. Okay, ask us for a project assessment, and based on this assessment, we will be able to commit to give a warranty. Okay, but this will not give the warranty, because we have then to assess the whole application process. So during the coating of the project, during the application, I mean, we will take samples, we will test the samples, and only when you are sure that the product was applied properly, we will be able to deliver a warranty certificate. So finishing, obviously, is also colors, aesthetic, cosmetic, and we can offer a wide range of colors. Okay, we all know the RAL color cards or the RAL color palettes, but within the RAL products, we can have various glosses like high gloss, semi-gloss, matte, fine texture. We can even develop specific colors and develop collections, because aesthetic is also about fashion, about trends. Like for the car industry, I mean, you can see year after year new colors, new finishes, new appearance coming in the streets. That's the same for the building industry. There is also a trend, there is also fashion, and we have to make sure that our products will appeal to architects and designers. And we also develop additional technologies. Again, on sustainability, Alesta Cool, it's very relevant for hot countries. There's a lot of thinking about how to reduce the heat island effect in the cities. The heat island is coming from, let's say, the accumulation of heat in the city centers that makes the temperature of the city centers much higher than outside the cities. So if it's much higher, it means that people will spend more energy in air conditioning. That's a direct impact. So there are coatings that reduce the heat island effects. This is named, I would say, cool coatings, or Alesta Cool. And it's particularly interesting for dark colors. Everybody knows that dark colors absorb the heat. So we develop, let's say, products that makes the dark colors less critical, and it's basically perform as good as light colors. We also have, especially in Europe, these are new technologies I'm going to talk. It's not yet introduced in this region. This is powder coating for coil coating. Coil coating usually use liquid coating for the finishing. So in Europe, they started to use powder coating for coil. This is one track record. This is an opera building in Paris that was, let's say, finished or decorated using this Alesta speed coil coating technology. The other trend is powder coating for steel, because usually we talk about powder coating for aluminum, but steel is not a big topic in terms of, I would say, area to coat, to finish, but it's a big topic in terms of corrosion. So it's usually a headache for our customers, because aluminum is quite secured in terms of durability and anti-corrosion. Steel is more critical, so we develop powder coating for steel that give basically a similar finish as powder coating for aluminum with similar durability. Okay, and we can also give warranties on these products. This is named Plascoat. It gives outstanding anti-corrosion properties on steel. So it's particularly interesting for handrails, steelworks like the car pack, let's say grids on podiums, light poles, structural steel in general. Colors, we all talk about colors, so they are now, this is something that we developed in the recent years, so specific websites, so architects and designers can order directly sample panels from the web, and we send those sample panels to the architects. So they don't need to call us and ask for a panel. It's directly accessible to anyone on the web. It's named Colorit. Okay, we'll finish. I have 1 good minute to finish on track records, because again, back to the beginning of my presentation, sustainability is important, so, but we have to prove that we are sustainable. And it all comes to durability. This is a project in Dubai. Actually, this is festivals. It's more than a project. It's a neighborhood, festival city. So we supplied Alesta SD in 2006. So it's three hotels: the Intercontinental Hotel, Crown Plaza, and Festival Tower. This tower, the facade is almost finished now. This is the Mohammed VI Tower, so it's happening now, 2002. This will be the highest building in Africa. It's in Morocco, Rabat. Also, Alesta SD super durable. In Kuala Lumpur, Exchange 106, also protected and decorated with Alesta SD. Menara TSLO, another building in Kuala Lumpur. HSBC building. The Manor, also in Kuala Lumpur, 2022, new building, Alesta SD. La Marseillaise Tower that was awarded, that's why I'm showing it. It's a John Well building in Marseille, in France. In Australia, Medibank. Also Alesta SD. Zlota Tower in Poland. This is the highest residential tower in Europe. And Schiphol City Hall in Belgium. This this is a cool building, actually. I mean, this was powder coated with Alesta SD Cool. And last one, this is a bridge powder coated with Plascoat for steel, powder coating for steel in Brisbane in Australia. So all what you see in white, basically the whole bridge was powder coated with this Plascoat thermoplastic powder for steel. Thank you very much. I extended a few seconds. I hope it's okay. So if you have questions, I will be happy to answer on our table stand outside after the conference. Thank you very much.
Thank you, Frank. So you can check their range and their colors at their booth outside. Okay, moving on to the next one. The next important component of a facade is sealants. Jayrold Bautista from Dow will be talking about carbon neutrality of sealants. Again, carbon has been mentioned a lot, and they, as a sealant solution provider, will be talking to you about what they have to ensure facades are carbon neutral from a silicon point of view. So, Jayrold.
Thank you. All right. Hello. Hello, good afternoon. Yeah, okay, just checking that the audio is working. Hello, good afternoon, everyone. I'm Jayrold Bautista. I'm going to be talking about Dow's carbon neutral silicone sealants for facade. And I think before I start my presentation, I would just like to introduce our company, just in case you're not familiar with us. So we're Dow, and we are a global company. We produce a lot of products. We are in different markets and different segments. We have good presence in Kuala Lumpur, in Malaysia overall. In fact, if you look at the silicone sealants, that buildings with significant silicone sealants that has been used or significant for Malaysia in general. So we are the silicone sealants for the facade used for the Penrose Tower. And I think now we are also the silicone sealants used for the facades for the KL118. So we're very happy and we're very proud for those two at one time. Penrose Tower, one time the tallest tower in Malaysia. We are the silicone sealants used for that. And now KL118 will be again the tallest tower, and we are also the silicone sealants of choice for the facade for that particular building. So as I have mentioned, that probably some of you are not familiar with the brand Dow presenting in Zak, but we used to be Dow Corning. And Dow Corning, if you're familiar with Dow Corning, we are 50% owned by Dow, 50% owned by Corning. And Corning, like the one that manufactures your glass for your cell phones, Gorilla Glass. We used to be owned by that company, independent of Dow. But in 2016, we were 100% owned by Dow. So that gives us more access to more products, more chemistries aside from silicones. So that's a brief introduction of our company. Now, I'm going to start with this one, zero. So what's zero? What I hope it's not. First off, I hope that's not the energy level that you have now. I know that you've been listening, you've been sitting down the whole day, but I do hope that you still have the energy for the rest of the presentation this afternoon. And I also do hope that it's not the salary increase rate that you're going to get from your bosses when you talk about your salary next time, all right? But what I do hope it is, as we are all pushing for it, is the net zero carbon emissions by 2050. So this morning we've seen an introduction. Michael has presented all of this target, and one of those that by 2050 we will have a net zero carbon emissions. One of the very interesting thing on that presentation was the intermediate year, 2030. And in 2030, what it says that we should be cutting our carbon dioxide emissions already by 50%. If you look at it, 2050 is what? 28 years from now? It still kind of looks, it's still a bit far, right? But when you talk about 2030, that is literally 8 years from now. And that's gonna come very fast, right? 2020, we had the pandemic. 2022, you see each other again or say, hey, that was already, 2019 probably is the last time that we saw each other. and then we just say, hey, that's 3 years has gone that very quickly. And 2030, starting from now, 8 years, it looks like, yeah, we still have enough time, but if you look at it, how long do you design a project? How long do you specify things for your projects, and how long do you construct a project? So what we're trying to say is we should start thinking about carbon neutrality and all of our push for net zero now instead of talking about it for later. Now, with that being said, we in the building sector has a very big responsibility. Why? 39% of the global emissions are related to the building sector. If we break down that 39%, 28% relates to the operational carbon for building, and we pretty much have done a very good job in managing that operational carbon. There's been a lot of legislation, there has been a lot of building rating systems that talks about operational carbon. But if we want to be truly net zero, we cannot ignore this 11%. This 11% is the embodied carbon of our building. This relates to the materials, the products that we use, and the construction of our buildings ourselves. Now, if you look at this this carbon, right? Operational carbon, you can keep on improving that. Embodied carbon, once you have done that, that's it. It's locked in your building. So that's why there's also but really there should be a lot of importance being put on embodied carbon as well. We will not have a truly net zero carbon emissions building if we don't tackle embodied carbon. So with that being said, this is Dow's journey toward carbon neutral silicones. Dow, as a company ourselves, we have very aggressive carbon dioxide emissions target as a company, and then at the same time, from an applications point of view, for our silicones, we also have very aggressive target. That's why we're launching these carbon neutral silicones. One of the things that I would like you to focus on here is this small pie chart. This small pie chart here shows you where the embodied carbon is coming from in silicones production. 66%, that big orange part there, 66% of the silicone production comes from the production of silicon metal. Silicon metal is a raw material required for producing silicone sealants. So silicon, without the letter E, is different from silicone, the end product. Silicon is just a raw material of silicone. And the most intensive, energy-intensive process is that extraction. Why? Because silicone comes from sand. Sand is SiO2. For you to get that Si from sand, you need to have lots of energy, lots of heat. And because of that, 2/3 of the embodied carbon for silicones comes from that. Dow is in a unique position because we are back integrated. We are the only silicones company that owns the end-to-end process of our silicone production. From raw material extraction for silicon metal to producing the silicon metal up until to the finishing plant where we will have our silicone sealants. Some company, let's just say this is A, B, C, D, E process. Some may only have the D and E, C, D, and E. We have the A, B, C, D, and E. What does that give us? A lot of control on the process that we have to reduce our CO2 emissions. What you're seeing here is our efforts to reduce our CO2 emissions. We are using renewable energies, we're using clean energy, we're using solar, we're using hydropower. Aside from that, we are also using all of these audited materials to ensure that our carbon emissions go down. Now, we are aware that right now there are really some processes that are not technically feasible for you to be able to reduce your emissions by 100%. The remaining CO2 emissions, we offset. With that being said, I can say whatever I want here probably and say, yeah, that's nothing, right? Because what is it? These are words. But we want to make sure that what we are sharing is something that's credible. So we have a market-trusted carbon neutrality claim via PAS 2060. PAS 2060 is a BSI standard that provides a platform for carbon neutrality claims. There are 4 main parts there. 1, accounting, carbon accounting via ISO 14040 and 14044. You calculate your carbon, your embodied carbon, and then you know now your carbon dioxide emissions that you have to reduce. The second part of the process, reduce it, right? Look for opportunities to reduce your carbon dioxide emission. Once you've identified those opportunities, the third part, you implement those opportunities. And then once you've done implementing, there will be some parts that will not be 100% carbon dioxide emissions. You offset what is remaining. Then you do all this process all over and over again until you reach to a point that you maximize your carbon dioxide emissions and you have the lowest offset that you can have. Now, to make it credible, as I mentioned, there will be a third-party company or third-party institution that will check that process and later on will give you that PAS 2060 certification. Now, what is this? It's a certified sustainable building. You're gonna get your rating system globally. So this carbon neutral silicone sealants is available globally. And part of the service that we're gonna provide is to ensure that there's benefits to you. So what if it's carbon neutral silicone, right? At the end of the day, you ask yourself that. So this is gonna help you get some points, more points regarding or in connection to your green building rating system. Of course, globally, there are different global green building rating systems, but we will be here to help you and make sure that you get extra points for that. So we have this LCAs. We have LCAs for this. You can have a copy of those LCAs if you would like to. You'll be able to get some EPDs based out of these LCAs. And of course, it just depends on the different product category rules that you'd like to implement, but those information is available to be used. So with that, we are launching this carbon neutral silicones. It's the first carbon neutral silicones globally for facades. It's for structural glazing, it's for insulated glazing, and it's also for weather sealing. All of those components that you use silicones for in your facades. So as I mentioned a while ago, when you have that building, you have your products, you have your construction, you have that embodied carbon locked in. So that's why it is very important to select your materials very well during the specification, during the purchasing of those products. Because once you buy it, that's it. If you want to change your product and when it's already built, you just add more embodied carbon. So please do have a check on the specification. And if you want to reach that net zero by 2050, we gotta act now. So if you look at this, we're actually talking about embodied carbon on this first phase of that construction. After that, we have operational carbon. Silicones have already been contributing to make sure that we have good operational carbon. And then after that, embodied carbon, you talk about reuse, you talk about recycle of materials as well. So, with that being said, there are two typical facade systems that you'll see, SSG and captive system, structurally glazed system and captive system. Structurally glazed, you use silicone sealants to bond the glass to the facade. Captive systems, you have those aluminum capture and use of gaskets to put the glass or to bond the glass to the frame. We've done some studies on SSG and captive system as how it will affect, aside from the embodied carbon itself, the other materials that you use for your facade system. So for example, one of the key things now that you'll probably always hear is the thermal performance of our facade. Because if you have a thermally efficient facade, then that means you will use lesser energy for the operations of your building. So what we've seen in our study is that with structurally glazed system, you'll be able to design it in such a way that you'll have 10 to 25% more or better efficiency thermally than captive systems. Aside from this, we've also checked up material usage. So material efficiency is key as well. Why? If you will use lesser material, That means you have lesser embodied carbon. It's a very easy thing to understand, a very easy concept to understand. So if you have an SSG system and a captive system applied with the same loading, the same sizes, the same everything, you can have around a savings of around up to 15% on aluminum weight if you're using a structurally glazed system versus a captive system. So what does it give you? Savings on aluminum, lesser embodied carbon for your building as well. Aside from that, SSG or silicone sealants has always been known for its durability. We've always been asked, what's the service life of your sealant? We always say 50 plus years. And the next question they ask us, can you give us a 50 plus years warranty? No, that's not how it works. But we have projects that are 50 years old. The first project, or we are the only silicones company that has a 50-year-old project reference for structural glazing systems for buildings. So that's why we are confident on the 50 plus years performance of our facade. Aside from that, we also can make your systems, window systems, for example, more efficient, as we are able to make sure that you have lesser framing material, for example, for your PVCs or even for your aluminum. It's because we are able to transfer loadings through the structural sealant from the glass to the frame. Now, let's quantify what I'm trying to say. This is an example. So the carbon footprint for silicone sealant, let's say per kilogram, is you're looking at around 8 to 12 kilogram of CO2 per kilogram of silicone. That's the embodied carbon of the material. And we have this example wherein you're going to have 0.57 ml per square meter, or 570 ml per square meter of IG sealant, 280 ml of structural sealant, and you will have 410 ml of weather seal. A total of around, you're looking at around 20 kilogram of CO2 per square meter of facade. Now, it looks like small, right, if you look at that number. But if, let's say, you have 30,000 square meter of facade area, you're looking at around 600 tons of CO2. Using a carbon-neutral silicone facade or silicone product, you don't have that 600 ton of embodied carbon in your building. Next is that, as I have mentioned, using SSG system, it gives you the opportunity to have lesser aluminum for your buildings. So here's an example. So the embodied carbon of aluminum is around 15 to 17 kilograms of CO2 per kilograms of aluminum. And if, let's say, you are using a captive facade, an SSG facade, the captive facade, you'll probably use around 12 to 14 kilograms of aluminum for a 1.3 by 3 meter unit, curtain wall unit. SSG facade, that's going to be 10 to 11 kilograms of aluminum per square meter. If you translate that to the embodied carbon of the aluminum per square meter, you're looking at 240 kilograms of embodied carbon per square meter and up to 190 kilograms of carbon per square meter for your SSG. There's a big difference. Around 1,000 tons of CO2 is saved just because you're using an SSG system. Reuse and recycle will always be a question. So right now, typically the ones that are being targeted for reuse and recycle are the glass and the aluminum. Being silicone is that small area in that facade. But what it means, silicones enables for glass and aluminum is that you can have the glass and your aluminum repurposed without destroying them. The good thing about silicone sealants is that they're very good to resist wind loads, earthquake loads, live loads, but they're very easy to cut. So that when you want to reuse your facade, let's say you have a glass here, you want to reuse it somewhere else, or you want to refurbish your facade, you can easily cut the silicone sealants, which again saves you that embodied carbon in your buildings. And so, just a recap, I'm ending my presentation. I'm giving some time for Zach. So this is available. We have now this carbon-neutral silicone sealants for structural glazing, for insulated glazing, and for weather sealing. It's a global service, so if you have projects somewhere else, aside from KL, this is also applicable. We have a PAS20 certificate to make sure that this is a trusted and verified carbon neutrality claim. And also, we are contributing to not just country, regional, but global target, as this embodied carbon or this net zero target by 2050 is a global target. We can support receipts of additional green building rating points, as I've mentioned and as I've shown a while ago. And aside from this, silicones have always shown a very good carbon balance from its production and durability and its building use as well. And lastly, when you design with structural glazing, you can design with less embodied carbon, up to around 15%, comparing an SSG system to a captive system. So with that, thank you, and thank you for your time.
Thank you, Jayrold. We'll take a break now. We'll come back in 20 minutes. It's 4:20 now, so by 4:22, by 4:40, if I can have you all back, I will be grateful. We've got snacks, we've got tea, coffee, and then we have the last session, 2 interesting presentations from BFG Hilti, and then important panel discussion on value engineering, which seems to be a very popular topic now. Thank you.
So good afternoon, everyone. So it's already 4:30, and then I'm Caleb here from BFG Façade Consultant. I believe you guys have gone through a long day and been very exhausted. So I will just be throwing some very simple, interesting, and bite-sized topic for you guys so that it is easy to digest. Okay, so let's get started. So what I'm going to talk about is the reliability and safety of the facades. Okay, let's start by defining what is reliability and what is safety. So reliability, we are talking about the quality of being trustworthy and performing consistently well. While the safety, we talk about the condition of being protected from the danger, risk, or injury. Okay, so in this chart, you can see that most of the common facade performance failure, it comes from the weather tightness. When we talk about weather tightness, it will be talking about air leakage and also water leakage. Okay, so the second one after the weather tightness would be the load tolerance. So what we mean by that is that most of the design, it doesn't capture all the necessary load implications. And then, of course, we have the thermals and also daylight and sound factors as well. Okay, so let's start with talking about the safety of facades. So safety of facades, I would like to categorize into 3 things: the structural integrity, public safety, and as well as the fire safety. So for structural integrity, very obvious, we talk about the failures of the structural supports. So in recent years, we saw that there's a lot of falling of the cladding panels. We can see that there's stone cladding which is dislodged and fallen from the building. It could actually cause dangers to the public occupants and the general publics. So when we talk about public safety, I would like to separate out public safety from the structural integrity, because when we talk about public safety, we actually talk about how the design actually affects the safety of the general publics instead of structural integrity. Okay, so we talk about we have fallen objects because of the design considerations in the detailing, and then in compliance of the safety glass, you can see that on the right image, we have students in Kota Damansara. It actually dies due to the large piece of glass from the breakage of anneal glass. So this is some kind of incorrect selections of material, where it actually caused some death. And it's actually pierced through in neck, and then having the head split into 2, head and the body split into 2. And then we have climb hazard and failure of barrier. We actually cause the general publics and occupants to have the possibility to climb through and having the chance to fall from height. Yep. Okay, so for facade fire, I believe that today you guys have gone through a lot of speech about facade fires, especially the one from Mathieu, DP Facades. So I will not be covering too much on the fire facade anymore. So just to go through some incidents that happens throughout the years, which is the Grenfell Towers, the Address Downtown Hotel, and also the one from Milan. So basically, most of it is because on the incorrect selections of the materials, and as well as the design of it. Okay, so let's now talk about the reliability of facade performance. When we talk about the reliability, we talk about one of them is the facade, weather tightness. So it would mean the air tightness and as well as the water tightness. So most of these two items is actually coming from degradation of sealants and gasket, allowing the water and air leakage to come in, and it's actually escalated in the air conditioning costs. So next we have the insulations, more towards thermal and acoustic, and also aesthetic. This one we can see that we have quite a few good examples in Malaysia, where we have deteriorated coatings from the high-rise and towers, and then glass discoloration and glass condensations. Then we have corrosions. So basically corrosion protection is very important, especially in structural steels. But then in the usual practice that we see in Malaysia, we can see that most of the steels is actually corroded, and then they are not using the correct specifications of the steels that's suitable for the weather. And then we have the operation of the ironmongery. So throughout the times, the degradation of the ironmongery actually will hinder the operations of the ironmongery. So this is just a very simple chart to show that the performance of the facade, it will degrade over time. However, with periodic maintenance and inspections, we actually can reduce or slow down the performance degradation. However, I have something that I like to say is that an easy clean shirt, it will never, we still have to clean it, even though it is an easy clean shirt. Now we talk about the design process. How do we achieve facade reliability and safety through design process? Okay, so one of the key principles, design philosophies that we practice is early informed decisions. So early informed decisions is actually allowed the project teams to drive better facade delivery process and better business decisions, rather than verifying poor designs after they are locked in. So how we can make these early informed decisions is through risk assessment. It's actually quite a common practice, especially in overseas. So through risk assessment, we can avoid risks where possible, and then we can evaluate those risks that cannot be avoided, and then put in place appropriate measures to control them at source. So, okay, then let's go to the next one, the design principles. So this is something that we always practice in our companies. My boss he always telling me to kiss facades, kiss my facade designs, to ask me to keep it simple, stupid, so that everyone can follow. So first thing, we design to maximize repetitions. Why? Because we don't want to confuse our workers. Second, we design to keep complex works in factory. Now it's okay to confuse your workers because it is in a controlled environment. It's easier to monitor their work quality. The third one, design with site tolerance and adjustment. Because in Malaysia, our main constructors is always out. It will never be correct. So the fourth one, design the installation with minimal risky access. So imagine maneuver 300 kg panel from a swinging cradle. It's actually not an easy task. It's a very dangerous task to do, so we try to minimize this kind of risky access. Then finally, we have design with future repair works needed. So, because Murphy said so. So anything that will go wrong, it will go wrong. So let's talk about our projects in BFG in Singapore. So it is the Jewel Changi. So basically in Jewel Changi, we have 6,000 steel knots, 18,000 steel beams, and 9,000 triangular glass pieces. So all the knots are actually controlling the different geometry and angles of the structures. We actually put more process in terms of designing the knots. So how do we turn the steel blocks into the knots is through a CNC process. So surprisingly, the fabrication tolerance from the CNC is actually goes, in these modern days, it goes up to 0.002 mm. basically there's no error from the fabrication. So what we try to keep it simple, applying the concept of the keys, is that we have beams with 90-degree straight and fabricated in Singapore. So most of our design process are put into the knots itself. Then we deliver the knots and the beam to the site. Then having one of 3 beams connected to the knots, hoist it up to the correct positions, and then just ask the worker to do the bolt tightening to the required torque value, and then that's it. And then we can proceed with the glazing, the gasket, and installation of the sealants. Then you will have the glass dome. So the photos here is just showing that the workers are installing the piping that delivers the water for the waterfall. Then they do the depropping of the framework, and then now we have a very beautiful Changi Airport with a waterfall in the middle. So what I'm trying to highlight here is that we try to move all the design thoughts into the complicated process into the design process, and then makes the site work more simple. So let's talk about achieve reliable quality facade through safe work environment. So in BFG, fortunately, we can say that we are the first consultant and also the first project in Malaysia to apply this concept where we install the unitized facade panels from the internal of the buildings, having the safety screen on the external. So in this kind of safe work environment, you can see that on the image on the bottom, they can actually do their installation works in a very safe and confident manners. So in result, it increased the efficiency and as well as the quality of the works. Also, from consultant perspective, we are also able to do our inspections and also our water tests easily. Okay. So achieve reliable and safe facade through continuing process improvement. So this is just a very simple diagram to show that first we have to plan it, and then identify the issues, then we do the recommended solutions, then we check if there's any defects, then we just implement and fix it. So how do we do that? So we have in these modern days, we have 3 great tools that can actually help us to do this very easy. So the first one is through BIM model. So BIM model is basically for us to coordinate. And then we have drone facade inspections where we use the AI algorithm to detect the defects and also infrared photos to detect the leakage. Then finally, we have the 3D printing. So basically, we're actually practicing this right now in our office where we test the workability of the extrusion through 3D printing. Okay, this is one of our projects where we actually use BIM model to coordinate the maintenance access system. So basically, as you can see from this image itself, you can have an overview of how the whole maintenance system strategy works. So it's able to coordinate with different trades of parties like M&E, architecture, and also structures very easily. And then we are able to do this confidently. So this is one of few diagrams that we created for the maintenance access. Okay, then let's talk about drone inspections. So in BFG, we are also deploying drone inspections as well to do the inspections at areas where it is difficult to access. So just some images to show that how do we do the planning of it, and then takes the photo to see what kind of defects that we can detect through the drone image at the joint area. Okay, so finally we talk about something interesting and lacking in Malaysia. Okay, so authority regulations in Malaysia that is related to facade is only UBBL, CIDB Act, which we commonly known as ACTA 520, Relevant Building Acts, City Council Regulations, DBKL Guidelines, Malaysia Standards, and BOMBA requirements. So when the local regulations and codes are not sufficient to cover the design and construction of the facade works, international codes are generally adopted. Okay, so generally what I want to say is that facade is classified as secondary structural elements that are not part of the primary structure system. Although that facade systems, they actually consist of structural elements that provide lateral and vertical resistance to the wind, safety barriers, seismic, and also other actions. However, in Malaysia, facade structural engineering is not actually mandatory for submissions purpose, for endorsement and submission purpose. Okay, so just have a look at other countries. So in Australia, they actually, in their National Construction Code, in the Part B01 and BP 1.3, they actually put a strong emphasis on the glass where there's possibility of human impacts. And then looks at our neighbor country, in Singapore, the building control regulations actually requires PE endorsement and submission as well for the fixing and framing details of any external cladding and safety barriers against falling from a height. One more thing to add on, furthermore, in Singapore, in January 2022, buildings that are more than 20 years are actually to be inspected every 7 years. It is actually being implemented January 2022, and then building owners have to appoint a competent person to inspect the facade. And then who is the competent persons? It's actually someone that is professional engineers or registered architects who possess the certificate in facade inspections. This certificate in facade inspections, we could get it from the course that they actually do it by BCA. So in Malaysia, who is the qualified professionals to ensure the structural integrity of facade are properly designed, engineered, and built? If no, among all the stakeholders, who is responsible when facade structural failures occurs? Is it the architects, or structural engineers, or facade contractors, or the developers? Who are the ones that going to take the responsibility? There's one, okay, when something happens, this is what we always do in Malaysia. Everyone can be a Tai Chi master. That's our, I don't have any answer to these questions because we don't have that answer. Yeah. Thank you.
Thank you, Caleb. Interesting presentation. Good finish to your talk. Okay, moving on next, our last presentation for today. We have Jason Lee, who's talking about the innovative solutions Hilti has. Jason's been in the industry for quite some long time. He has experience in the glass, sealant, a lot of other building materials. He's now with Hilti as the regional head of facades for Southeast Asia. Over to you, Jason.
All right, good afternoon, everybody. So I'm Jason. So many of you have known me previously from my previous jobs as well, from Saint-Gobain Glass as well as Tramco CBG. And now today I'm representing Hilti as a regional facade segment manager. So today I'm actually talking to you regarding on the Hilti innovative solutions for facades. So to begin with, let me just talk a bit more about who Hilti is. So we are founded in 1941 in Liechtenstein. So if you do not know where Liechtenstein is, it's actually somewhere near Switzerland. It's a small town of about 30,000 populations. And that's where now, for us, Hilti today, we have more than 28,000 employees, as well as it's operated in more than 120 countries. The good thing about Hilti is we are actually working as a direct sales approach, meaning that when you deal with Hilti, you are not dealing with a distributor or anybody else, but Hilti ourselves. So which means that if you have any issues, if you have any inquiries, you have any problems that you face, feel free to look out for us and we will be able to provide you with the most professional and specialized approach and solutions. So what we do today is we have full support and solutions in all project stage. We work very closely in design or in the building stage itself. We work with architects, consultants, engineers, contractors, as well as helping you with the inspections to ensure that the products that you use from Hilti are being used and applied in the most correct way. So for example, if you were to work on the design itself, feel free to look for our facade engineers, which will be able to work with you closely with our Profit software that can do all the calculations and design that is required for your project. And we will be there to provide you with engineering support as well as training programs for your staff to ensure that you guys can be very competent in using our software as well as our products. And when it comes to our products itself, as you know, Hilti is very well known for our tools, right? So the tools that is being used as such is the most durable tools, and that's where Huat is always being known for. So we do have all the different tools from positioning to drilling to coring and to everything fastening that we have, and as well as all the facades materials that you require in terms of brackets, fastening, and such. So we have casting channels, anchors, as well as sealing of gaps, which is our fire stop systems that can be used for edge or slab application for facades. And lastly, we do not just leave you there, but we also provide you with the necessary inspections, including pull-out tests, including inspections to see that all your applicators will be able to do it correctly. So now let me just go through the three main pillars of what we are doing for facades and how we can actually optimize in terms of the facade solutions. So what we are going through today is casting channels, adaptive torque control modules for post-installed anchors, as well as fire stops, which is the edge of set application, as well as cavity barriers. Before I start with the casting channel, just let me show you one video on one of the most iconic projects in Dubai. From here you can see that this is one Zabil project. It is located in Dubai, UAE. It has a mixed use of two towers of 50 and 60 stories high. Main consultant is WSP. Facade contractor is actually Al Aba Aluminium, which is one of the biggest contractor arm in Dubai. They have the project challenges like different panels up to 3.6 meters as well as 4.25 meters, which if you all know is really huge. And it has horizontal and longitudinal loads of up to 20 kilonewtons. And what we have for proposed solutions is to use our hack channels, which is the casting channels, and optimizing 4 sizes for casting, working hand in hand with the consultants, and to work with them where to use which type of casting channels for the project. And with that, we are able to provide with quick installation with just some pre-planning for this project itself. Next, I would like to talk about the Nida Park project that is in Turkey, which is 3 towers, about 30 to 40 plus stories high, and consultant is CWG. Similar project references of high wind load up to 60 kilonewton, with horizontal and longitudinal loads, as well as a design of slab to curtain wall of up to 30 cm distance. And with this itself, the proposed solutions and benefits, we actually use one type of head casting channel and one edge of, we call it the head edge, which is used for the corners of the slab itself, and they actually overlaps each other without having to weld onto the casting channel itself. That provides you with the necessary integrity of the casting channel. So let me just go through 2 of our main products for casting channel. So first one will be our HEC TCRS. We call it TCRS basically meaning temperature controlled roll form shaping casting channel. All right. So you can see that the shape of the casting is actually very unique. It is not the usual rectangular shape that you see. It's actually innovative V-form for higher performance. Being the V-form shape itself is able to tap into a bigger cone itself. As you can see the breakout of the shear stress that you have from the picture on the left. All right, and that actually gives it a higher performance in terms of shear. And we have tested all our channels based on ETAs, and we have passed on the EOTA TR047 as well as EC2-4. And I understand that even for Malaysia, EC2-4, it will start to become more and more popular and will be much of a regulations in the months to come. And having said, basically it has static and quasi-static resistance in terms of tension and shear, as well as fire-rated resistance and fatigue resistance in tension. And lastly, for this product itself, we managed to get the EPD, which is the Environmental Product Declaration in terms of green product. So we have carbon emissions topics earlier today, and now we have this EPD product for casting channels. Because it's a temperature controlled channel, it uses less amount of energy to get this form into this V shape itself. Next, we do have our usual hot roll channels, which most consultants has actually specified. So for hot roll channels, we have high static tensions, shear and shear steel values that allows higher performance compared to our peers. And with that, we also have all the ETA approvals for 2D and 3D loads, as well as fatigue tests and fire ETA fire test. And we also provided some end caps. It comes with end caps so that it actually provides you with easier and faster installations when it comes to site conditions. Next, I would like to talk a bit on the adaptive torque control module on our post-install anchors. So I have two project references here as well. One is the YDA residence in Turkey, and it's a mixed-use towers of about 20 to 40 stories. Consultant is Axis, and for this project, seismic calculation is actually needed. It comes with high horizontal and longitudinal loads of up to 25 kilonewtons, and in terms of the material used, it can either be GI or stainless steel. So our proposed solution was to use our HUT HST3. Later, I will show you the physical item of this product that comes with seismic approvals. And provided solutions with this is to use our M12 GI compared to the M16 stainless steel. And this actually allows them to have some cost savings in terms of the installation process itself, as well as the material cost itself. Next will be Bonavat Crescent, which is in Dubai, UAE. 2 towers, 47 plus stories, floors, and 25 floors. And consultant is actually Inhabit. It's a very fast-track project, and with horizontal longitudinal nodes of about 3 kilonewtons. We use HIC3 expansion anchors, and it's actually one of the best solutions for cracked concrete itself. And frankly speaking, cracked concrete has becoming more and more in the topic for most of the facades use itself, partly because, as you know, that over the age of the building, concrete is going to crack. All right? So that's where we actually have these cracked concrete solutions in terms of expansion anchors. And with our HIC3, because of the loading, it also provides you with design optimizations to reduce the number of fixations required. So this is the HIC3 product itself. All right? It comes with variable endowment depths as well as high loads, and we have all the necessary approvals for ETA, seismic, C1, C2, as well as fire approvals. However, we are not just here to sell you anchors. We are providing you with the full solutions that comes with it, with the tools necessary to provide you with the right application itself. I think for installers themselves and project managers, you are always troubled by people who are not doing it correctly, which means you may have exerted less torque or more torque that resulted that the performance of the anchors do not perform. So what we do today is that we actually have our adaptive torque module. If you can have a look at our booth, we actually have the physical set there to give you an idea of what it is. And what it does is that it provides you with the exact installation torque pertaining to the specific anchor itself. And it reduces the dependence on the quality applicator. Frankly speaking, my daughter of 10 years old can actually do this torque as well. All right? I will show you a video on this. So this is the product itself.
Simply use the module to scan the anchor box. The tool will set itself up for that anchor. Then set your bolt and pull the trigger. The module controls the tool and stops it at the optimal setting. It can also provide immediate feedback once the anchor is set, allowing you to document installations for easy quality assurance.
So you can see from here, any one of us today here can just put your tool on your anchor and just press the button. And when it's done, a green light will flash, meaning that it has been done in proper order. And for project managers or directors, you just have to bring out this tool and bring to your office, plug it to your computer, and you will know how many anchors has been set for the day and how many problems you face or everything has been done. And which also means with all the anchors set with the correct installation method, correct installation torque, you actually can reduce in terms of the inspection time required. Next, I would like to talk a bit on the engineering judgments in terms of the edge of slab applications. A lot of times when we come to edge of slabs, which means on the fire stop itself, we have many standards in the market. For Singapore, we work strictly on ASTM E2307s. Some of the Southeast Asian markets works on the EN 1364-4. And these are the two main test standards that is readily used. So I would like to talk a bit more on the test standards. So for the curtain wall assembly for the ASTM E2307, it actually comes with the full configuration itself. So it's a 2-story test standards compared to the EN, which is only 1 story, which is on the level 2. And ASTM actually provide you with movement and cyclical requirements, which also means that it takes into considerations of the facade movements over the period and the lifespan of the building. However, this is not mandated by EN 1364-4. And with that, if you look at the ASTM E2307 test itself, it comes with internal and external burners, which means if there's a fire breakout internally, there are chances where the fire broke out of the window and comes back in, which we really call the leapfrog effect. As for EN standards, it's only either internal or external burner itself. And that is why EN 1364-4 alone is actually not enough. And we will need to have a EAD 350141-00-1106 that has to be covered under the ETA. And this will provide the necessary movements, smoke, and water tightness for this project, for the use of the fire stop. So for HUT, we always believe not just on the product, but also the applicator as well, because a good product has to come with good application in order for the product to be successful. So we have 4 key steps to ensure the proper design and installation. Number 1, we look into the design. So we actually provide engineering judgments and proposals according to the requirements of our projects. So talk to us and our specification engineers that can actually provide you with the necessary support on this. And when it comes to the installation, we will always provide you with proper training so that we will go to site to work with your workers to actually provide them with the proper training so that they know how to install our product. And we also have approved applicators, which call HAFSC, which is HUT accredited fire stop specialty contractors, which have fully trained by us and has been working with us for many projects. So this ensures the quality of the installations. So not only that, quality control is also important, which means ongoing inspection checks, proper records and documentation is necessary. And lastly, we will always have a third-party inspections so that there is no conflict of interest on this to ensure that your product is installed, in proper order. So for HUT, we actually have 2 products just for the edge of slab applications. The most usual product that we use is the acrylic-based product, which is the CFS SPWB. WB stands for water-based. And we have another one, which is the CFS SPSIL, which is standing for silicon-based product. A lot of times when we come to fire stop, edge of slab applications, the most pain point that we face is what if it rains and the sealant has not cured. So water-based product, throughout, whether it's it for us or our competitors, will take days for it to cure. And that is why we have this silicon-based product that will be rain resistant within 1 to 2 hours and fully cured within 5 hours. And with that, it actually assists you to reduce costs in terms of protection covers and as well as the man labor to apply the protection covers and such. Both products has been tested according to ASTM E2307 as well as EN 1364-4. And we have done more than 1,000 tests regarding on all these fire stop products. And this actually achieved more than 25% in terms of movement capability based on ETEC 026-3. And we also have one of the highest T ratings, which is both integrity and insulations on the fire test. And it can span on uncommon gaps, widths, diagonal gaps, as well as unique architectural design. Lastly, for this product itself, we also be able to achieve zero spandrel. As you know, facade these days, we want to have fully vision glass so that spandrels are no longer in fashion, I would say. So for this product itself, we actually be able to achieve zero spandrel with proper test of HI, BPF120-11. So with that, we have all the test report that's required for gyrospandrel applications for edge of step as well. Lastly, let me just talk a bit on the ventilated facades, which is one of the most in thing in Malaysia, partly because BS 8414 standard has been implemented by Bomba due to fire that broke out in February 2018, and as well as other fires that broke out around the regions. All right. So for this ventilator facades, I believe you already know, it's actually for vertical open gaps between exterior facades as well as building envelope. There has to be an approved cavity barrier using intermittent fire stopping to be installed between floor joints. This is to prevent fire from migrating upwards to the next level. So it's something like a vertical compartmentalization, in fact. And using intermittent fire stopping materials, it allows the product to expand when in contact with fire. And expand is not to expand a bit, but it's more than 100 times of its original size. And that successfully will actually break the fire to prevent it from spreading upwards. And we have the specific product, which is our CP674 for ventilated facades applications. And this has been tested based on BS 476 Part 20, together with ACP, which is aluminum composite panel, for BS 8414. And it can come out to 60 minutes integrity, as well as 30 minutes in terms of insulations. It provides good moisture resistance, as well as age-resistant tests to be done to simulate 30 years of wetting and drying process. All right? So this actually ensures the success of the product to be used in the building for more than 30 years. So in summary, I would just like to provide you with a deeper understanding of what HUT has. We actually provide an integrated approach as a full solution provider. We do not just sell tools, we do not just sell anchors, we do not just sell fire stop, but it's a one-stop solutions in terms of hardware, which is casting channels, post-install anchors, as well as fire stop. And with that, it comes with the necessary tools and innovative ideas, innovative solutions that can be used in your facade applications. And we do have software, which is our Profits Engineering software, that can provide you with the necessary calculations that you can use for your projects. And you can also check out with us for your project requirements and needs, and we'll be there to support you. And next, we also have asset management. And this is something unique for HUT, which means that you can actually loan HUT equipment or allow us to manage your assets, which is our tools as well. So you may have 4 or 5 projects running in the regions, and you do not know whether it has been laying around or it has been used. And we do have all these on-track systems that is connected both software, hardware, as well as all the services together. And lastly, in terms of services, we have all the engineering support that you require, all from HUT, as well as job site support and trainings required. And lastly, thank you for the presentation. I would like to just introduce my team in Malaysia, which is on the facade team today. So we have Eric, which is our area sales manager, Mavis Desmond, which is our facade specialist, as well as Vincent, which is our specification engineer for facades. And they are all specialized just in facades. Thank you.
Thank you, Jason. As you heard from his presentation, LD is truly an innovative company. They have lots of solutions. Somehow, in some project or the other, some solutions of theirs is applied. Okay, now moving to the last segment of this event, which is the panel discussion. I'd like to call upon the panelists on stage one by one. Can I have the slide changed, please? The panel discussion slide. Okay. I'd like to invite first Ms. Serena Hijaz on stage. We're happy to have her once again. Last time she contributed her expertise on a sustainability discussion. This time is on value engineering. So Ms. Serena Hijaz from Hijaz Architects. I'd like to call upon Yukid Chong, who's the Director for Project Management for Turner & Townsend, on stage, please. Mr. Roger Paulin, who's the Senior Project Manager at RPM. Andrew Shaw, who's the Director for BFG Consulting. Don't go by his photo over here. I don't know, it's a college photo. He's grown his hair. And of course, our dynamic moderator, who I was able to convince to moderate this panel, Sean Moon. Sean is heading up the facade engineering team for Arup here in Malaysia. So over to you, Sean.
Wow, thanks for having us today. I get the center seat. Okay, thank you, Kit. Thank you, Serena, Rogers, and Andrew for joining us today. Yeah,
thank you. Happy to be here.
Okay, let's kickstart our topic today because the time is short. And facade value engineering. Nowadays, we can see the price trends of raw materials are surging. Yeah, and leading to higher construction costs in the industry. So be it a building owner, contractors, or designer like Andrew or all of us, we are looking the way in lowering the construction costs. So one approach in reducing the construction costs is through value engineering. So people often spoke about value engineering, and I believe each of us perceive it differently. Can you please share your view? What is value engineering, and what is cost reductions or extortions from your own experience and perspective?
All right, I'm happy to take this question first. Value engineering, generally, most people think of cost reduction first. Cost, of course, is important, but there's various aspects you need to look at. I think there's three main aspects. Firstly, cost. There's also time, how to do the construction or the installation in the shortest time possible. And of course, I think everyone here has encountered the supply chain disruption in recent years. So that's a very significant aspect we need to manage. And of course, there's buildability. Buildability in terms of the efficiency of installation, the practicalness of the design, whether it's easy to install, whether it's good for the occupants as well as the building manager for maintenance, and lastly, but more importantly, safety. And I'm sure a few of the speakers have already mentioned today on public safety, fire safety. So yeah, these three main aspects for value engineering: cost, time, and buildability. On the cost reduction, I would say that's possibly the last option that you have. Most of the time, that happens when there's a scope creep, right? The client increases additional scope of works, or most of the time during tender stage, right? When the tender returns come back and it's extremely high, it's exceeded the budget, you have no time to relook at the design again. Therefore, you have no other choice but to do the cost reduction or cost extortion. So that's one thing you want to try to avoid. Do value engineering earlier, make it from the start, identify the potential risks, put in sufficient mitigation measures, and then you're ready, right?
Okay. Right. Are you guys agreed with what UK was saying?
Well, we're just keeping to definitions at this point, right? So we're not here to argue just yet.
Okay.
We can.
So you could touch on cost, time, and buildability, and a little bit on the maintenance. So from point of view of all, if you would like to implement facade value engineering, when do we start? And on which stage the client often get the maximum amount of returns from facade value engineering?
I think from the design point of view, I prefer that it's actually done right at the beginning. This way we're all pretty clear. I kind of asked a question to UKID the other day, and I said, do you know what is the percentage of facade to a building ratio? Because as an architect, I sometimes have to defend the design. And so in terms of a holistic way, I'm asking, we all know MAP is 30%, civil and structural is 30%, architecture and building is 40%. But no one actually says how much is the building skin. And the building skin is your first line of defense. One other area that wasn't spoken before about value engineering is areas of value add. We have to talk about the thermal performance, the OTTV, things like that, which are all tied up to sustainability. But coming back to the costs, I would rather as a designer know right from the beginning. We didn't used to have to do the value engineering at the beginning before we kickstart, but I prefer that it's actually done right then, because then we can manage the design beforehand. Yeah.
Okay. Speaking from a point of view from client side, so what do you think about that, Roger?
From a client's point of view, I think it's important that it be early so that we can address some of the issues that the client has. Some clients have certain sustainability issues which they're concerned about, or they want to meet certain criteria such as health and well-being of their staff, which should be addressed within the facade. And out of curiosity, you mentioned yesterday about the percentage. It's around 15%.
15% is
15,
for the facade?
which is and quite a lot in many respects. But with 15%, I think there's a bit of room to play. And I mean, if you're able to add value in terms of sustainability, in terms of energy consumption, lighting reduction in terms of use of energy for lighting, introducing certain technologies such as dimmers and whatnot, there can be a lot of cost savings, and we've addressed it on a few projects that I've worked on representing the client. So it's to me it's important that the client be informed from the start as to how to best address. If there is a cost increase, there may be a value to it, and the value engineering may be more cost, but it'll be more beneficial at the end with their health and safety, with their employees' well-being, as well as cost energy and energy consumption and savings.
So Jayrold, you bring a very good point that you're coming in from a perspective from the client tenants buildings. Means at the end of the day, the building will be used by clients. So you're able to realize the benefits over the long times once the project is handed over. But what about Andrew? Do you anything to add on this?
Yeah, of course, like as what Roger mentioned, it heavily depends on when we talk about value engineering, are we looking at talk about the whole building, the whole life time frame of the building. If there's an owner-tenant building, they're going to own it, they're going to occupy in it, they want the comfort, they want the well-being of their own staff, and then there is a value added to the corporate image. So that is a part they will, most of the time they were happy to invest because they will foresee it in long-term return. Yeah, and then in the short-term, emphasize as like build this, sell it, take the profit. So the terms of value engineering will be much shortened into the construction periods, and then where is the return of investment. So when we talk about value engineering, always is like value to which guy, and then when is the return of investment. I think that is always the key things when we advise a client on how to make a good judgment on what is the value engineering and to whose interest.
Yeah, that's correct. I believe everyone has a different objective based on the timeline, stages of the projects. No doubt that imposing facade value engineering at the early stage of the project will give significant amount of returns to the client. However, imposing facade value engineering exercise during the very beginning of the projects, we're also limiting innovations in designing a distinctive and peculiar buildings. So just like limiting an artist to paint in 2 colors. So I would like to hear from you, Serena. What's your view as a designer?
You know, just to talk about cost just now, a high-performance building will have maybe up to 15%. You know, a pure curtain glass building going down, triple glazing, double glazing, you know, I've done the double layers, I've done the single layers, all the rest of it. Yeah, it's up at about 15%, but it can go down to 10%, and I think 10% and not below 10% is the rock bottom. But, you know, coming from the architect's point of view, I usually look across the entire board, not just in terms of the facade. Of course, I want to defend the look and the feel of the building and the performance of the building. And what was mentioned before, I think just to clarify, when we talk about sustainability, it's about health and well-being of daylight. That means the amount of daylight, it's showing you that you have the return of investment on daylight. We can't put a money on it, but we can tell you that people like to work inside that building. The thermal performance and all the rest of it. So usually how we approach is we go down to structures and MAP as well. So, you know, if you're going to be cutting, I've cut a building that was only so much long by, you know, 1 bay, another bay, because the MAP price went up. The structure went up. So I started cutting the building and getting more efficient to a point that I said, I'm the most efficient I can be and keeping the concept. So you've got to look across the board. I'm not just going to attack the facade the look and feel. And I'm not just skin deep, we're looking at the overall performance of the building. So I think, you know, everyone has this idea the architect's just going to defend the design, but we look at it as in terms of much more holistic.
Yeah, I'd like to add on to that. I think now with inflation, prices have really gone up beyond expectations. I remember a project that we started just pre-pandemic. Of course, you know, with the uncertainty, clients stopped. Now they start again this year, and the cost has gone up about 25%. So with this, and it's still ongoing, we need to prepare ourselves. So if you start value engineering much earlier, you have come up with different types of design solutions so that you're ready for the unexpected. If I may give you a little case study, we did a logistics warehouse project in Indonesia. It's a simple project. However, you know, it comes with the challenges. When we did the initial feasibility, it was projected about 15 months, and the client said, no, I want to chop it down to 11 months. You know, 4 months is quite a lot for a short project like that, as well as the cost. You know, he needs us to cut about 20% or so. So it's a huge challenge. So it was not just looking in terms of the changing of the materials or the specs, but looking into how it's constructed. So ultimately, the design team and ourselves came up with a solution using a racking clad method. So racking, basically the warehouse has these racking shelves, and we use the racking to be the structure as well as the external wall. So then you can just add on the cladding directly on the racking material itself. So that helps a lot. As you can imagine, we save a lot of time as well as the cost. So things like that. Of course, this is different compared to your iconic high-rises. However, the approach is still similar.
This has been during time, cost, aesthetic side of the things. So in my understanding, most of the architects tend not to value engineer any of the facade. Obviously, facade is the face of the buildings. To a certain extent, value engineering will somehow change it later, hopefully, on the aesthetic side of the things. So I wish to understand from each panelist to what extent you would accept and what you would not. Where is the limit? Especially when we do facade value engineering, the cost benefits from the value engineering goes to the client. Anything
to start on that one? If you're looking at value engineering from an employer's point of view or a client's point of view, I think what's really critical is to have certain constraints. You were mentioning about constraints about using two colors. I mean, people who were colorblind were great painters, Monet, Degas. You know, these are all, they had very, very strong constraints and limitations. I find that as an architect, when there are limitations, then you have to become more creative. And with the limitations, it provides you with maybe opportunities you would have never thought of before. And maybe the limitation is budget, maybe it's orientation, maybe it's being in a confined area within a downtown core, trying to build a building which has character. It's difficult sometimes because you're being overwhelmed by the others. So it's, to me, limitations and constraints can be value added in itself.
Cool. But speaking from PM point of view, when you're managing the value engineering process, whereby the benefits goes to the client, so what is your limits? What would you accept, what you would not?
I think value engineering has to be a team effort. Of course, client makes the final decision and approval, but the design team, the PM, all of us has to come up with a reasonable solution, right? Address all the challenges, concerns from the client, and tell them, okay, if you want to achieve this value, this is what you're gonna get, right? And if you're happy to just extend your budget a little bit more, then you have the next alternative. So you gotta be open to the client and tell them, these are the facts, right? We're not magicians, and yeah, that's what we gotta do. Right?
I mean, in terms of a design, sometimes we start with a competition and an idea and a concept, right? I remember this story in my first job when they were talking about the Foster's Tower for HSBC in Hong Kong. And, from the design to the completion, there were changes. Same thing when we did Celcom Tower here. We ended up having to flatten out some of the design, shall we say. So ideas were sort of maintained, but you can't have the in and out because it's all surface area. So you had to flatten out certain things. So there's a point where you can lose some of the concept. You try to hold on as much as you can, but you understand, obviously, there's a value engineering that has to happen, or else you won't be able to build the building. But there's that balance. You're trying to keep that, of course.
And talk about this value engineering in facade industry. I always found that is actually the most interesting and fun things in terms of our facade industry. Because unlike other trends, MME structure is more as generate how much per ton of steel, how much per meter square of a concrete. But in our industry, facade is a trade that delves in the details. So in discussion of the value engineering, we are in the consultant project management level. So we always look at the big pictures of how much per meter square. But if you slice the pie of facade, when we talk about how much per meter square, it's more in the system and the materials. But the beauty of facade engineering, because of a big chunk of facade costs actually come from the procurement strategy, the fabrication, and your buildability. So for the smart contractors, if you are able to manage these three parts of procurement, fabrication, and construction buildability properly, there's actually a lot of value engineering money you can save. However, it leads to a second part of my point, because you're asking about how much is the money returned to the clients. And I would say that is the secret of the trades in how you manage your parts of procurement, fabrication, and construction. And it does not easily reflected in the saving that you need to return back into the client's pocket.
Okay, just put it back a little bit on where is the limit. So I heard Srina say that to a certain extent, she's willing to sacrifice a little bit on the aesthetics to maximize to flatten the design a little bit. So from the point of view of each of the panelists, the performance is something that they will never give way, especially on safety, fire, and even from the earlier presentations, we can see a lot of incidents happens on the fire side. So I think value engineering should really look at the safety side of the thing as well. Shouldn't be jeopardized of the performance of the building. So facade value engineering is a continual process, and we may bring it on to the next stage of the projects. So would you mind tell me more about your experience? Have you ever encountered the facade options proposed by the contractors? Is a cost reductions, extortions, instead of a value engineering? How you handle the situation, especially when the big portions of the saving is given back to the client and is very attractive. Any takers?
Tricky
one. All the time, right?
Yes, no. The contractor will say you can make savings this way. We change the performance of the facade paint. And then we have an issue of a building that's 20 years later, which was up there before, having issues of, the skin sort of looking like it's dripping down. There's a limit. I think as a liability, we're not facade engineers, but we know the liability of the building, and there's a limit to the performance that we're basically going to say it's okay. But if the client decides they want to do it, then we'll basically say it's your decision, but the liability aspect of it is there.
I'll let you address your question a little bit differently. For facade engineering, let's say the contractor is awarded within budget, and the contractor proposes to the client, look, if I can make this kind of savings, that would be for my benefit. So for the client side, there's no issue, right? Because they've awarded contract within budget, and if the savings are given the contractor, it becomes a initiative for them, right? It becomes an additional bonus for them to push harder. And sometimes an established developer should look into it, not just in terms of financial returns, but also better workmanship, better quality, maintenance, as well as just overall execution of the work. It becomes better. So we got to look at various aspects besides the financial returns.
Okay, cool. So yeah, I think handling this situation is really tough. I think especially as a facade consultants, when the contractor is proposing a big chunks of saving to the client, is meaning telling you you're not doing a good job. So on your point of view, Andrew, have you ever encountered these situations where your design was tendered out when the contractors come back with a great amount of savings and telling the client that, yeah, we can give this amount of saving if you adopt our design?
Yes, in a way, I do appreciate that. Okay, not being said like being a consultant, not happy for us to change the design. Like I said, the beauty of facade industry is like what we want to look at is to achieve the performance and the aesthetic. So the journey, it can be different, and then we can have a lot of smart choice. And being a consultant, yes, we love and proud of our design, but there were always, I was happy with this kind of like open discussion with contractor, because they always can be able to bring in some new idea, and then their smarter way to fabricate and strategy of procurement. Like today is a good example, because like facade, other than other trades, is like we are quite an international trade. Today we have a lot of like friends from overseas, different suppliers. So we have actually very wide options of what we can buy, and then to achieve the performance and requirement that we can do. Yeah.
And also very important to engage the contractors earlier, right? So that during the design process, you get their feedback. And for established developers, if they have many projects in the pipeline, it's probably good to look at it as a whole rather than one single project, so that you can try and find a trusted partner, to deliver well. And these guys will probably obviously be happy because they know your pipeline, and they can perhaps plan ahead. In terms of supply, they can perhaps focus more on your projects, give you more priority compared to their other clients. So it's a win-win situation.
I think value engineering facades really required good skills and capabilities, and with the help of all the advanced digital technologies that able to help us to chunk out the ideas as soon as possible. So I'll say it's a black art. I mean, to manage the value engineering process, you probably need to understand the fundamental of design, the material fabrication limits, and also familiar with the constructability, like what UK was mentioned earlier, and with the help of the advanced digital tool in churning out design, really. If not, without those advanced digital technologies, using the traditional way, it will be taking forever to come up with that kind of calculations to justify the change. So moving forward, we have start hearing decarbonizations from suppliers like Dow saying on that, and then hearing from all over the world the embodied carbons and operation carbon reductions. So codes and methodologies for embodied carbon start to being established. So what is your view in specifying embodied carbon targets on the facade? Will the embodied carbons be considered as a set of performance requirements in the futures and become a key parameters in facade value engineering exercise?
I think it's about starting now. Before it was green building requirements on the building facade, for example, as part of the specification. Last week I was asked, what are the ESG specifications on the, this is not facade, but earthworks. Before we start the work, what are now different from the green building specification, which most of us are familiar with already, that we've all added into our specifications. Now it's ESG. So it's coming. I'm not sure we'll come to that kind of detail very quickly, but I think it's an overview of an approach that is coming into play. Yeah.
Yep, I do see that it's coming because the whole world is talking about decarbonization, net zero.
But I think that depends on your client also, because a lot of times the client will have certain criteria internally to their own organization to achieve certain targets, whether it's sustainability, whether it's environmental, whether it's footprints, the carbon footprint. They have certain things that they need to meet, and I think I've had the benefit of working with some very good clients which have that criteria already set. Now, they may not know what the solution is, and that's where they come to the consultants and ask them, what are our options to do, how do we achieve this? How are we able to move forward and achieve this? And I think it's important. That's why it's critical to have the client on board early, so that in value engineering, so that they understand what the options are and what the opportunities are. And they may be willing to spend a bit more to achieve that. And that in itself will be value engineering for them, because it's giving them something that they need at a certain cost, obviously, but at the end of the day, it's beneficial to everyone. And it's looking at the building holistically, not just the facade, but I mean, what we did in terms of how we operated on a few of our projects, it was considering all of those, the mechanical systems, the facade, how do we integrate that, how do we marry all of those components, because these are all critical one to the other.
Okay, right on the dot, the points. So how we are able to link the sustainability with value engineering? Do they conflict or do they align?
You know, to be able to talk sustainability, we have to talk about ROI. You know, so the only way I'm going to convince you is if I tell you that your ROI is less than 3 years. You know, something to that equivalent before it becomes a factor. And certainly we have some data already with regards to that, showing the 1 to 3% incremental costs. So we can come back and say, okay, there's an incremental cost of between 1 or 2 or 3%, but your ROI will be back by this time. And so that's the only way we can sort of combat about why you're adopting certain green features. But in the end, a lot of it makes sense. You know, it's the window to wall ratio, the FVRs, the passive design elements, getting those right first, and the last stage, I call it the passive design elements first, in terms of your building facade, and then it makes sense towards the end. So I think, yeah, it's a bit of educating or learning from everybody, but that factor, instead of just value engineering on time, cost, and all, becomes the one other extra factor that should be considered, I think.
The overall direction and strategy has to come from the client. What's more important to them? So for large corporations and MNCs, a lot of them have really started to look at their overall corporate ESG plan, right? Decarbonization. So if they look at their whole company portfolio, they would have to set certain policies or principles that what they want to achieve. If they have a plan in place to be net zero or coming towards that, then that's a lot easier for the consultant team to follow, knowing what the client main criteria is. So sustainability, it's a huge issue now. And yes, we do see a lot of our clients putting that at the forefront. So value engineering, sometimes they are not willing to budge on that because they have a certain target they need to achieve for their various stakeholders. So that's something that needs the advice from the client rather than the design team.
Okay. Sometimes I find that when we are doing certain value engineering exercise, it's sort of like contradicting. For example, taking glazing as examples, increasing the thermal performances of a glass would give energy cost saving in terms of electricity to light up the building or to cool down the building. This is often the challenge in balancing sustainability and the capex, because to the client, they just want to reduce. Some of the client, they wish to reduce the capex as much as they can. So really depends on the client, how they want these sustainability elements to be embedded into their projects. Yeah. So yeah, we speak out most of our questions today. So let's go to the floor. Any questions from the floor?
No, we have one.
Jeff.
Hi. I just want to direct the last question from the earlier speaker, the Tai Chi master. Can I hear your guys' opinion?
She's asking your opinion on what.
Okay, well, let's
you
push this
feel-
back to Andrew.
Because it was your colleague, probably you can answer.
Yeah.
What was the point on the Tai Chi? What was the point of your speaker from your company? What were you saying? We're just doing the balancing or what? What was he trying to say?
Balancing art. I think the speech by Caleb just now, we actually try to point out there's a gap of the governance in Malaysia in terms of the facade safety. Yeah. Tai Chi Master, of course, is a good joke. I think everyone have a good laugh by the end of the day. Yeah. But okay, the serious question is like, are we having enough governance or not insufficient governance? Because like we do have our local code and authority requirement to set the boundary of what to do, what to check, and what standard to follow. And there's lots of international engineering requirement to check. So the emphasis is more on the facade structure components in terms of the engineering capability. Being a first element on the face of the building, there's one that easily fell, and once it fell off, it's caused a serious and huge public safety. But why this such an important and critical element is not required for the proper professional engineering endorsement and enjoy the proper check? Because we are putting everyone, the public safety.
I would love that. That means the facade liability goes to you and not to me. Right?
More business for me.
I'm having to sign off on everything. What is the fact of that? And the liability, the actual liability.
In a way, I would say it's fair because, like, as I say, it's a structure. I'm a structural engineer myself, but so it's actually a structural component. We can't push this to the architect or the contractors who might not have this professional engineering knowledge or know-how to make sure this is the proper construct element.
Yeah, it's about educating the client, right, what's best. Even though it complies to the local regulations, doesn't mean that's enough, right? So,
yeah, that was a questions that deviated from the topics. But anyway, like I said, if you were to talk about value engineering in facade design, in Tai Chi, all these things, actually to manage a facade value engineering design process, you refine the structural side of the framing. So you might be thinning the aluminum profiles on certain area, and you cut down the tonnage usage of aluminum of the projects. So that is a black art. So that's why you need some specialists like us to actually go through the options. We check the design thoroughly. So the guys that checking the design must be experienced, and it has to be understand from design point of view, familiar with the codes, understand the material fabrications limitations, and also to understand the constructability. I mean, you might end up having a value engineering by changing a fixing A to fixing B, okay? But because of the factor of safety of the fixing B, you incurred probably 5 times of the numbers of fixings. So does it call value engineering? To me, it's not, because putting the workers on site to drill the fixings 5 times, that is not a value engineering. Especially we talk about workmanship of the market now, shortage of labor. So to me, it's not much on cost saving.
So in terms of like, as I mentioned earlier, facade is just not system and material. Where in lots of discussion with the clients, that is what we always try to look at. Lesser performance, smaller sections, thinner glass, because they're purely on the material. But actually, there's only like 30% of the facade cost. Yeah, the real chunk of that, like what Sean mentioned, yeah, is like a labor. So also this thing depends on which country we're talking, making this conversation. For example, in Europe and Australia, labor cost is sky high. So that's why we try to unitize everything, prefab everything in the factory, and just install it on site. Personal experience, I was working in Australia. There was some panel coming on site, just slightly 50% off. So I have to ask my worker on site in Australia to just take the bracket out, shift it out, and cost me like 40,000.
So looking at the constructability and label, is actually a key functions in value engineering. Sorry, I didn't get your name, ladies. You were asking the Tai Chi questions. Did we answer your questions?
Did you get your answer? Yes. Any
Okay.
other question on this topic?
Any other questions from the floor?
I think everyone's tired.
Okay.
Everyone just want to go home? Okay.
I don't know. Have you ever had the value engineering that we're going down to the nuts and bolts? Whether what grade steel we're using? You know, at this point, I think I would like to recommend that at any project, let's allow for 5% incremental cost already tied into the cost estimate, so that we know realistically, and everyone's estimating by the end of this year there's going to be another 5% increase, that we've actually met that and not having to go to another exercise at the end and chop something else off.
Okay. Anything to add on?
Yeah, I would say like facade is like dressing us out. So I'm a M-size person. So no matter how, I need an M-size shirt. So don't force me to wear S size. It doesn't fit me.
I'm sure you look good in S size.
Yep. Yeah, I think you could touch on cost, time. I mean, especially when construction now is the time frame that's been given to build a building is so short, and at the same time, we need to cover cost aspect, time aspects, quality aspect, buildability aspect, and now even have a sustainability aspect. So to cover all these aspects in the process, we really need a good digital tools. So I think I'm proud to say that in Arab, we have invested a lot in developed very good tools, and like I have shown earlier, we are able to chunk out the VE solutions with even with the carbons, embodied carbons in the systems in a short time. So yeah, we need good people with good design skill, understand the limitations, and understand the constructability. Then
good planning as well.
Good planning.
Start early, right?
Yeah, to come up with good facade value engineering solutions. Yeah, that's all from me.
Right. Can I just request the panelists to please be seated? We'll finish. So what I've understood from this panel, definitely value engineering is not cost cutting. I think that's something which all of us need to understand. There's a gray area. Value engineering means cost cutting, but no, it's not. That's what our eminent panelists have said. So thank you so much, Sean. Thank you, panelists, for your time. Before we just end today's session, I'd like to inform you that we've recorded today's event. Next week, along with the feedback, we will send you a YouTube link of this event, and you can watch the replay at your convenience. I'd like to thank our event sponsors for being extremely patient and supportive. As I've mentioned, this was an event to be held back in 2020. August didn't happen, but finally we are really happy with the support and the turnout today. So thank you all. A round of applause for all of you. And we hope to return once again in August 2024 with another edition with newer topics. Now, before we end, and all of you to join the Shuko party, can I call Mr. Joerg on stage? Right, he's here. We'll give the mementos to the panelists, and yeah, we can end the day. Again, lamp points. We are credited with 1 lamp point. So if you, 1 lamp point, if you'd like to get yourself enrolled in the certificate, in getting the points credited to your membership, please fill up the form at the reception at the bottom. So thank you all, and I hope to host you once again August 24 at the Zak World of Façades in Kuala Lumpur.
And I need to thank, hello, 1-1. And I need to thank Ahmed, who lead us through the day, almost like Stephen Tanner.
No.
No, it was good. So thank you, Zak team.
Thank you.
Ahmed.
Thank you. Thank you. Give me the next one. For Sean. Give me for Sean. Yeah. Can I get the background changed? Sorry. Yeah, thank you. Caleb is here. Can I have Caleb and Jason on stage also? Get me Andrews. Andrews is there. Kept there. Give me Roger. Give me Roger. Give me Andrew. Get me Andrews. Roger. Give me. You get. He removed it and kept it. He told me it's ready. No naam nahi hai. Black. It's black. Huh? Yeah, you can. Yeah. Caleb, are you still there? Is he there? Caleb. Where is he? Can you call him? Yeah. Jason from Hilti. We'll have a group photo.